Remember when you were medium, now extra large is hardly big enough. Quit the whiskey, quit the beer, quit the wine for a while. I'm not saying it's forever, but if you want to feel better, you got to, you got to. You got to.
Will this be mirroring me? Yeah, I'm live now. Yeah. Good morning, everyone. Could we please get some more people to move to the front row? We do need the front row to be full for our stream. Thank you. Excellent. Thank you very much. Okay, for anyone. Good morning, everybody, and welcome to Ubuntu Summit 2604. We are very excited to have you joining us, and we can't wait to show you what we have in store for you. We really do have a fantastic lineup. But before we get started, please remember, if you have any questions at any point during the talks, please submit them via Discourse, and we'll aim to ask a selection of them at the end of each talk. But first, it's time for opening remarks. And we'll be hearing from two people today. And to kick things off, please welcome to the stage Canonical's founder and CEO, Mark Shuttleworth.
Well, what an incredible, incredible time to be alive, to be in technology, and to be in open source. We are seeing just this extraordinary acceleration in innovativeness, in access, and in just the pace at which software is being reimagined, redeveloped, redesigned, re-engineered. What is profoundly exciting for me is that open source is at the center of this revolution, right? And I think that's, profoundly exciting. It also is a huge responsibility for those of us who are in open source, because we are literally defining the materials, the raw materials of the next wave of technology. And I think the next wave of disruption and change in every single industry on the planet. Software engineering is first, but the agentic revolution will touch every aspect of human endeavor in, I believe, profoundly positive and exciting ways. I want to touch very briefly on Canonical in the context of Ubuntu. It has been, a stressful but exciting and exhilarating 6 months since our last summit. Some highlights for me: the work that we have done recently with VMware, where we're enabling their Kubernetes and their ability to essentially deliver open source applications to a global enterprise audience. With Qualcomm, where we are underpinning their push into IoT. Exciting work with NVIDIA, focused on mission critical, safety critical applications for open source. Think automotive, think industrial type applications, where the ability to reason with precision around what open source is doing is a critical capability. And with AMD, where landing ROCm directly in Ubuntu, I think really transforms the experience of engineers building complex, sophisticated mathematical capabilities with AMD GPUs. As a company, we are now closing in on 1,500 colleagues, of whom nearly 1,000 are software engineers. So it is just incredible when we get together, as we did 2 weeks ago in Madrid, to look at the breadth and the range of open source that we're able to meaningfully interact with and engage with, the number of communities that we can work with. And those 1,000 engineers, 1,500 colleagues are spread over 80 countries. So I still deeply believe in the future of work as a global collaborative effort. And I think agents will only accelerate that move. As a business, we're growing at around 20%, so double the rate of our kind of obvious competitors in the open source industry. And while we deeply respect and admire the work of our counterparts at those companies, we're very, very proud of the fact that Ubuntu continues to be at the center of the most innovative work, and the teams that are the efforts of the teams that are really looking to define the future, whether that's in a bank or whether that's in an aerospace company or an automotive company or a technology company. We focus our efforts on supporting those who want to be at the leading edge of innovation. We also continuously see ourselves being pulled into categories where rigor, resilience, reliability are the key requirements. I talked earlier about the work that we're doing with NVIDIA on safety critical applications for Linux and open source. And I think we have to find technically sophisticated ways to balance our desire to deliver the latest and the greatest and the best of open source with the additional requirements that come when lives are at stake, safety is at stake, and regulatory constraints are in force. Now we are at the dawn of a new era, the era of agentic engineering. And that is a bit of a roller coaster. We're all on the roller coaster. Some people love roller coasters, other people not so much. And so this is a time that is both exciting and unsettling, at the same time, sometimes for the same people, right? We can all find things that we're just super excited about. We can also find things that make us uncomfortable, make us uneasy, and that gives us the sense that there is work to be done to figure out how to do this properly in the world of open source. And that's really what I want to focus on in these open remarks. I want to talk about speed, I want to talk about safety, and I want to talk about community in the agentic open source era. Now, we have always, the word Ubuntu is fundamentally is a signal that we care about people and the impact that open source has in people. And one axis that we always talk about is that we care equally about people who are exceptional innovators, right? People who are true inventors, true category leaders. But we also care about newbies. We care about people who are passionate about open source, but haven't yet in any sort of sense, made a huge mark. Open source has made a huge impression on them rather than them making an impression on open source. And sometimes I think, Redditors love to declare their departure from the land of the newbie. I always think that if they are going to become exceptional innovators and contributors, then they will come full circle back to Ubuntu, because they'll come to appreciate the things that we also stand for, right? The rigor and the commitment to the long-term stability and support of the software that we publish. But there's another way to sort of think about this axis, and this is very meaningful for me, which is that we also care about both the very wealthiest people in technology, right? The people who, for whom this is an economic story, and the very poorest people in technology, right? I always say that our ability to provide the same platform, precisely the same bits, to an engineer who is working at the heart of a hedge fund, the most lucrative kind of work on the planet, right? And an engineer, who aspires to greatness, who's growing up in the suburbs of Calcutta, right? Or pick a marginalized community anywhere on the planet, right? Our ability to deliver Ubuntu to both of those people in the same form on the same day, with equal rights, as it were, is an important and deeply motivating story for me, right? And I want to return to that later, because I think it's kind of a critical anchor point in how we think about this transition to agentic engineering. So let me zoom in on speed, right? One measure of the excitingness of the times is what I call the curl to bashometer. Do you have your own curl to bashometer, right? The doomsday clock, which counts down to, tells you how close you are to global thermonuclear war. Well, this tells you just exactly how exciting things are in software, right? And right now, we are well on our way. You can't swing a cat on the internet without seeing scary shit like this, right? And this just makes my toes curl, just right? So, exciting, right? What this tells us is that there is very interesting and important stuff that is happening faster than the traditional processes to kind of figure out how to deliver software can move, right? So yeah, this tells us things are exciting, but it also is a kind of a warning flag to us about what issues we're likely to see, right? And so what we really need, one of the sort of critical foundational things that I think we need in this era is to focus on the secure, auditable, predictable, and manageable mechanisms to deliver software at the speed at which people want to innovate today, right? And so, this has been a theme for us. We long ago realized that the rigor and precision that make Debian great also effectively are a constraint on the speed at which we can get interesting stuff in the hands of users, right? And so that has been at the heart of our desire to kind of blaze a trail to find newer, more precise ways to deliver the latest and greatest bits. So I just took a snapshot this morning from Popey, and Popey's here. Sorry, Popey. From his Snap Store update dashboard. What I love about this is it tells you, again, just how fast things are moving in the Snap Store, right? Just this morning, as of 20 minutes ago, 3 new snaps today, 71 updated today. And this really is the mechanism that we are focused on to put, to move bits securely, reliably, and auditably from the publishers, the inventors, the innovators, directly to users of Ubuntu. So, obviously, that comes with all sorts of question marks, right? What is the reliability story? What is the resilience story? What is the security story around there? And just to kind of walk through that, if we replace curl pipe to bash with sudo snap install, you're still doing, that critical thing. You're still essentially saying, I want to run software from someone I've never met, right, on the internet, and software that hasn't necessarily been through Debian or been through a distribution. I want to run that right now on this system right here, right? So you're still doing that same kind of crazy leap of faith that you do when you run somebody else's software, right? But you're doing it with signatures, right? Every bit of software is signed and audited. If you're curling and piping to bash, you might be able to find some signatures somewhere. 99.99999% of people would never check those signatures, right? You're doing that with automatic updates by default. It doesn't have to be automatically updated, but what you're saying is, I want to run the software, and if the software improves tomorrow, I want to have that improved version of that software tomorrow. You're doing that across heterogeneous architectures. We live in a world where you might have an ARM laptop, you might have an x86 system, which is where your CI/CD is going to be, and you may have an ARM server, which is your production environment as well. And that entire pipeline, all of our pipelines need to become completely heterogeneous aware. Delivering software this way allows us to deliver exactly the same bits that have been through exactly the same sets of tests and so on x86, ARM, RISC-V, Power, Z, right? And if there's any other instruction set we should be doing, you let me know, right? To deliver those bits, into the hands of the people who want it on the platforms that they want to run it on. Critically in here, you also get enterprise version control. In other words, you get the ability for an organization to say, look, when Cisco says that there is a version 131 of this software, we don't automatically want it to land on every server. We want to be able to decide when that change is going to happen in our environment. So there's this tension between the desire of a publisher to put out the latest and greatest and the willingness of a consumer to essentially get that. But that tension has to be managed. If you do it in a brittle kind of I'll do it when I want way, you can't do it programmatically and by policy, you end up with essentially stagnant software, right? So the beauty of this is the ability to essentially drive by policy the rollout of software from publishers to consumers of all sorts. Edge, beta, candidate, stable channels, hotfix branches, the ability to essentially say, we have a fix on a piece of software that we want to deliver only to people who have this issue, and have people say, okay, I only want to get changes to the software associated with that particular change. Progressive releases, the ability as a publisher to say, look, I want to put this out there, but I only want to put it out there for 1% of the users because stuff happens, right? And the ability to then dial that up and release progressively to a wider audience. And in the common case, strict confinement. The idea that, look, this piece of software should only be able to do the things that it plausibly needs to do on my system. That is a critical capability. And I think the central argument in favor of a move to containerized software delivery and deployment in the first place. Now, Reddit has lots of opinions about stuff, including snaps, but they remain the single best safest way to deliver bits to any Linux distro on the planet, period, right? And there are other mechanisms that are containerized, Docker and so on, Kubernetes and so on. But if you're talking about bits to the fingertips of a developer, bits to the fingertips of a user, application bits, this remains where it's at. And we will continue to dive deep into that. Now, I want to touch on confinement because there are times when confinement isn't the right thing. And these, of course, are your dangerous times, right? Your exciting times. So if you are invited to snap install something -- classic, you need to know that is curl to bash, right? But it is curl to bash with all of the other properties that I described: signatures, automatic updates, the certainty of who the publisher is, and so on and so forth, right? But it is fundamentally saying, do this in the old-fashioned way, where there's no confinement around that software. And why is that interesting? It's interesting because, in today's conversation, the biggest agent productivity boost you will see comes when you unleash the agent, right? We started in an era of, chat, please advise me on how to do the software. We're now in the era of delegation, right? Please run this machine, right? And so when you sudo snap install open code -- classic, you are saying to both this code that you're running and the model that is driving that harness, you're saying you're in control, right? This system now belongs to you. I give up the ability to reason about this system. You as an agent are unleashed. And that's the right answer in some cases. So the ability to do both of those things through a single capability, I think, is important. That, of course, then leads to the conversation around safety and how we reason about and plan for and manage the safety of agents unleashed, right? And here it's clear sandboxing is the critical capability, right? And the ability to essentially understand the sandboxing and choose the right sandboxing for a given mode of operations is critical. And I often find, the sort of Twitter effect leads to kind of a herd behavior. People say, well, we have this one thing, we want to swing this one thing, this one hammer at every problem, right? So, everybody's familiar with Docker as a way of both delivering software and essentially confining software. Run it in a Docker image and it's confined. But I think we need a much richer toolbox for sandboxing for any number of different reasons. And this has been a kind of a critical area of R&D for us. We have long believed that the container capabilities in the Linux kernel allow for much more interesting and much richer kinds of confinement and containment than the traditional OCI, Kubernetes, Docker image on its own will do, right? So on Ubuntu right now, think about sandboxing with Docker, sandboxing with snaps, right? A snap is a container, right? When a snap is running, when software is running, not classic, then it is running in a container, but it's a container that has certain management properties that allow you to reason differently than you could with Docker. Think about LexD, LexC. These are system containers. Give an agent the ability to believe that it has all the tools and capabilities of a full system without requiring all of the resource and footprints of a full system. Then take it further to VMs and say, there are situations where even a container binary, a kernel enforced boundary, right, isn't enough to keep this agent bottled, right? To keep the genie in the lamp, right? So we want VMs with multipass and LexD. We have the ability to essentially create these environments on Windows, Mac, and Linux, right, in a highly predictable way. And very excitingly, we now see the emergence of micro VMs. So things that essentially cross over and blend the properties of VMs and containers. And I think this is a critical new capability in the toolbox. So I mentioned multipass. Multipass is essentially saying we need to bring these capabilities to the Windows and Mac crowd, right? So that they too have access to all the things that we take for granted. Right? Okay, I want to double click a little bit on the sort of agentic workspace story, right? So here we're talking about saying, look, imagine an organization that wants to run thousands of agents at the same time. Compute, is ultimately a limited resource, one way or the other. It needs to be managed. Efficiency is rewarded, right, in our kind of world, and rightly so. How do we run agentic workspaces very efficiently? And the answer is to essentially use containers where it is safe to use containers. So the picture here is really showing an Ubuntu system with look behind you. Okay, we've decoupled theory from practice. And we did that some time ago. I'm going to stop and ask for some help or directions. I know that that's unconventional, but do we know what's going on in the live stream? Because if the live stream has got the right slides, then I'll just continue with that. Also frozen. So the live stream is up to date. Yay! Right. So I was talking about sandboxing and the technologies of sandboxing. So LexD with its system containers, sort of full system containers, allows us to give agents a complete environment where they can run all the tools, they can fetch packages, they can run snaps, they can run other containers, but do that in a super dense way, right? So this is a critical capability for organizations that essentially want to unleash thousands of parallel agents, but essentially give those agents full operating environments, give them a root in an Ubuntu system or another distro system effectively, and do that efficiently, where your constraint is not GPUs typically, but CPUs, right? Interestingly, the emergence of the agentic sort of era puts CPUs back into the picture as one of the bottlenecks on your whole thing. Your GPUs, of course, are going to be working like crazy to support essentially the model calculations, but in an agentic engineering world, you're essentially working in normal environments, and you become CPU constrained again, right? Your agents have to be able to run tools, install software, remove software, and do all the sorts of things that you typically do on CPUs. So both classes of compute suddenly become boundary conditions effectively on how much you can get done. So we spent a lot of time working with this kind of capability to enable very dense agentic capacity for organizations. And along the way, we started to become really aware of this tension in the developer context between the sensitive information that you as a developer typically have in your environment, right? You have keys, you have credentials, you have personal information, you have corporate information, and that typically lives in your laptop, right? In the environment in which you work. You personalize that environment, right? It becomes friendly to you by having all of those things. But those aren't necessarily things you want to give an agent that is plugged into a remote model, right? And so how do we bridge those worlds? And working with LexD, we started to explore the ability to essentially decorate a system container with a carefully curated set of things that are appropriate for the untrusted software in that system container to work with, right? So imagine we say, let's ask LexD to make a container, and then we want to bring only the selected pieces of critical personal information that either makes that friendly for us or essentially enables the particular piece of work we want to do there, right? Say, for example, I want to have an agent working on a piece of software that needs a data set. I might want to provide just that data set from my laptop or workstation to that agent. And so we started building a capability around LexD that we call Workshop. And Workshop is the single nicest thing that I have seen in terms of enabling developers to sit down and become productive in an agentic environment, but more broadly than that, in a complex environment that they didn't define for themselves. So imagine you have a new colleague that joins a team, you have a complex code base, and you need to get that colleague to go from 0 to 1, from 0 to productive as fast as possible. If you have a workshop definition in your tree, then that becomes as simple as clone the tree and workshop launch, right? So workshop is a tool that essentially says, all right, I'm going to stand up a workspace, a workshop. Today, that is a system container. And then I'm going to bind into that system container all the key capabilities that would be essentially sensitive capabilities that have to be managed carefully. For example, figure out how to allow somebody in there to sign Git commits or push to a remote Git repository using sensitive credentials, but do that in a controlled, mediated fashion, right? So you can snap install Workshop today. It's a 0.9, but we are super excited about it, incredibly pleased with how that experience has come together. And we've been working with a number of ISVs to package up their pieces of software as SDKs. Workshop natively understands SDKs. There is a store for SDKs. So you can effectively get SDKs that are digitally signed, that come from a trusted source, that have been through, that have provenance associated with them, and run those SDKs in these sandboxed environments in a highly predictable, highly reliable way. Now, obviously, in today's conversation, agents would be the scary thing you might put into that sandbox. But in fact, if you just step back, our world for the last number of years has been an accelerating world of this blend of trusted and untrusted software. Maybe there is a brilliant new startup that is doing phenomenal work in a particular kind of data, and they have an SDK. It is a pile of proprietary code. If you put it on your laptop and run it as root, you're essentially handing control of your laptop to that organization, right? Not just that organization, but anything that influences their build and publication toolchain. So we started building this before agents in a world where we wanted to give people safe places to run mixed mode code that they would get from the open source community, that they might get from Ubuntu, Debian, or your preferred Linux distro, with code that might come from a publisher or a vendor that's not open source, where you don't have that set of promises. We want to create those spaces so that you could do that at speed and with confidence. Today, of course, that is absolutely perfect for an agent, right? You can unleash an agent in there and you have the safety of the sandbox. But this is just the start. In recent weeks, we have been very excited to work with NVIDIA on technology that they're leading in the open source community, which is micro VMs. So the idea is to be able to harden the boundary of those sandbox using underlying CPU constructs from virtualization, while still providing a very fast, very lightweight environment where you can start quickly, you can work productively, and you can cycle environments very efficiently. So if you think about what things like Firecracker do for us on the public cloud, the ability to start fast, be small, be efficient, and bring that into the developer experience, bring that into the production experience for agentic workflows. This is, I think, the next generation technology to watch. And today you can snap install OpenShell. That will give you essentially micro VMs on demand, and it will give you micro VMs with a selection of agents prepackaged effectively. So you can spin up a Claude agentic space, you can spin up a Copilot agentic space, you can spin up an agentic space of your own design effectively, and have that run with the additional protections that virtualizations give us. I think this is a technology to watch. So there we go. So speed, safety, what about community? It has long been, part of our DNA that we work in equal partnership with people from anywhere on the planet, regardless of their, corporate affiliation, regardless of their means. Effectively, all you needed was a beaten up old piece of PC and Ubuntu, and you could be part of what we do. And I have a real concern that in this era which ties productivity and even the ability to understand the software that you are working with, right? Ties that to tokens, right? We have a whole new sort of question of access and sustainability to address. And I think this is something that we, the Ubuntu community, should have front and center in our thinking as we kind of lead this transition. Now, I value deeply and consider to be extremely important our relationships with the people who are at the frontier and typically working nowadays with proprietary models and tools. It is equally important for us to care about putting those proprietary tools into the hands of those developers that can afford them and need them to do the work that they do, right? I have no problem with that at all, but it is a critical principle for me that we should not essentially focus all of our attention there to the exclusion of the access to open source that is at the heart of Ubuntu, right? And so we need to think very hard about this and figure out how we bring the poorest members of our digital society and those who are passionate but haven't yet, hit the big time, into the fold and keep them in the fold as we move through this agentic era, right? And so really one of the big questions for us has been, what does it mean for us to make our primary focus the open source coding assistants and harnesses and the open weight models? And I can tell you now, we've been really focused on this question, and I am now completely confident that we can both stay at the cutting edge working with our commercial partners and enable the upliftment of the next generation of technologists if we make this our primary focus, right? Of course, the competition, the diversity, the full range of capabilities is critical, right? Every single major organization, I think, will be on both sides of this line of open source and open weight and proprietary, and I think that's fine, right? It is going to be critical for us to stay on both sides of that line, right? And to hold those communities or those different ways of working and kinds of access as central to our mission. All right. So speed, safety, and community. Speed, you can get the latest, best, greatest software as of 30 seconds ago with snap install, right? And you can get guardrails, constraints, and confinements around that. Safety, right? Workshop and the movement to essentially sandboxing and agentic workspaces, right, is how we are going to deliver safety and reason about safety in this environment of delegation to agents, right? And community with open source and weights. Now, to tell you a little bit more about how Ubuntu responds and leads in this, I'm delighted to welcome John Seeger, VP of Engineering for Ubuntu.
Hello, welcome everybody again. It's very good to see you all here. So I'm going to just quickly carry on Mark's train of thought before we look at Ubuntu 2604 and what we managed to deliver there. I'm going to cover a lot of my thoughts on AI and Ubuntu in this talk. A couple of weeks ago, I published this article, which has been SEO'd to death, I think, by now. So if you search for that title, you'll see a full write-up of kind of my thoughts on this. There are a few key ideas in this that I really want to focus on when we talk about Ubuntu. The first is the idea of implicit versus explicit AI features in Ubuntu. I don't know that that's the final wording of how I want to articulate that, but that's how I'm thinking about it at the moment. And the distinction really is between features that Ubuntu already has that can get quietly better because we now have access to certain kinds of models, and then features that haven't existed in Ubuntu that are now possible because we have AI and are very obviously AI-powered features. And I think there's actually plenty in the first category which are really, really exciting. Those might include things like accessibility features, screen reading, speech to text. It might be things like better focusing on your camera or the enhancement of your voice through your microphone. These won't necessarily obviously be AI features, and they don't need enormous models and cloud inference to be very, very effective. Right? They can run on your laptop, even on your CPU, very, very efficiently. With the explicit features, I think that's going to be more of a shift. And I want to take time over that to make sure we do something meaningful, do something impactful, do something genuinely useful, rather than just wedging a model in Ubuntu so we can say we got there quicker than our competitors, which I don't think is a particularly useful thing to thrust upon our users. In that post, I also talked a lot about local first inference and how our work with the silicon vendors is increasingly important for that story. Right now, there is a gap between your 4 billion parameter Gemma model, which is remarkably capable, but not in comparison to a trillion parameter model hosted by insert name of favorite vendor here. But I think that's going to change really quickly. The advancements that are happening in silicon, essentially at every size of silicon chip you can think of, is happening so fast that it's going to be very, very possible for most people to run very capable models for the vast majority of their tasks on their laptop over the next couple of years. And I'd really like to make sure that we are right at the front of that with the silicon partners we work with, so that as people are buying their shiny new hardware, which is very expensive at the moment, they can actually use all of it. So there's lots more detail in that post about how we're thinking about fundamentally incentivizing engineers to use agentic tools, and also how we intend to measure them. And the blunt fact of it is, I don't actually intend to measure how much AI anyone is using. My belief is we can just continue to measure people how we've always measured people. What is their output? What is the perception of their productivity, the quality of their work? And I think it will become clear very, very quickly, those who have figured out how to use these tools properly. There is absolutely, in my mind, no sense in us going on a mad rush to see who can spend the most tokens. I don't really understand that craze. It doesn't make a lot of sense to me. The other thing is on agents and in open source and our part in it. You will see, no doubt, lots of people jumping up and down saying they're very disappointed that Canonical is going to talk about AI, introduce AI, use agents, integrate models. But honestly, we can't not. I see the world as I see this whole thing as much more dangerous for open source if players like Canonical don't get involved. Like, this is a company, a community with 20 plus years of demonstrated kind of good behavior, good intentions, and understanding of open source and what it means both from a technical perspective and a social perspective. And for players like us and similar to step out of the conversation on apparent moral grounds is not going to do anybody any good. So I think it's worth recognizing that there are problems in the open source community and AI contributions right now. Lots of you will have seen the various famous examples of slop contributions, people showing up for the first time in a project with 10,000 lines of code they haven't really looked at, and maintainers feeling, very rightfully feeling the strain of that. But that isn't going to get any better if all of the people who have understood how open source works and are starting to understand what sustainability looks like in open source run away from it. And so I think there is an element of we're going to have to go through a little bit of pain as an open source community to basically get the next generation of people understanding how to contribute constructively, and also enable them to basically power the next generation of open source. Open source already looks really different to what it looked like 30 years ago, and it's going to look different again in the next 5, 10, 15 years. And this is kind of a natural evolution. So I think what we see now is loads and loads of excitement, and that's where you're seeing PRs coming left, right, and center to all your favorite projects. But in the end, it's all going to converge back on open source, because writing your own device driver for your favorite bit of hardware is really fun for the first 5 minutes. But as we have learned over time, people don't necessarily want to maintain that. It's not necessarily going to keep up to date. And so in the end, I think once the excitement is over, there's going to be a huge convergence back on a set of really high quality open source pieces that everybody can use. And so I think it's incredibly important that we as a community, as a company, are a part of that conversation. So some goals over the next 6 months. In 2610, my hope is that you will be able to press a button and talk into any field that you could previously type in, by default on every Ubuntu machine. This will be powered by small models, the likes of things like Whisper. Turns out that actually speaking to a model and getting text output is really easy. Plumbing it into all of the various places where you can type text on a modern desktop is going to be the tricky part, but I have faith in the desktop team to pull that off. And I think that's just the first step in accessibility. Now, I see this for most people, this is a convenience means. Why type like an animal to your agent when you can just talk to it? But if you are impaired in some way, perhaps you are visually impaired, I think the introduction of AI models is going to be a game changer. There are certain technologies which are absolutely critical for classes of users, like screen readers, which bluntly suck, right? Which I think can just get so much better with, if you're essentially taking a frame buffer or the output of a camera and feeding it into an LLM, I think it's just going to do a much better job of articulating what's on that screen and what actions might be available to a user. So I see this as simultaneously a great usability enhancement for everybody, but also could be the start of a really important journey for accessibility in Ubuntu. I'm going to be an impossible tease now and leave this very nebulous statement up on here, which is to say there will be some new ways of interacting with your machine coming to Ubuntu. Mark has talked about sandboxing, has talked about all the amazing things agents can do. And one of my feelings is that Linux has become this incredible sort of mosaic of open source, which is like, if you peel back the covers a bit of a modern Linux desktop, every so often I get this feeling of amazement that it kind of works at all, and let alone how well it works these days. And I think what's interesting about Linux is it has so many different knobs and buttons and things you can tweak to make it do exactly what you want if you know how. But now the thing is, almost everybody can get a thing that knows how. And so I see this as a really interesting way to get more people into Linux and using the desktop productively, because no longer is productive usage of Linux desktop in really esoteric environments predicated on 20 years of being a Linux desktop hacker, which I know many of you are proud to be. And so I would like to think of new ways for everybody to interact with their machine, taking advantage of the fact that we now have things like LLMs. And interestingly, as we've looked into how to do this, it turns out that many of the technologies we've been pushing for years, like snaps, are just a wonderful fit. If you think of a sort of agent type experience on your machine that has a number of tools that it can call to do things for you on your behalf on your machine, if each of those tools has its own confinement profile, that suddenly starts to become quite interesting. And we don't have to do any work to get that. We already have it in Ubuntu natively ready to go. So my hope is to be much more transparent about exactly what this is by giving you something to play with in the next 6 months. It won't be finished, but it will be awesome. And I think it's going to be the next most exciting thing in getting people engaged in the desktop experience on Linux. But if we take a moment to just look back at what the team has done in the last 6 months, I am incredibly proud of what the team have pushed out with the Resolute Raccoon, not least because I think the mascot is awesome. This was the first LTS release under the kind of new manifesto that I have been pounding into Ubuntu engineering under the sort of general banner of like the beatings will continue until morale improves. But they have risen to the challenge so wonderfully. It's been a real pleasure to see not only that team growing literally in numbers, but in how they go about their business. And I think it's quite clear to see that from the coverage you see in the media. I have been joking with some of our colleagues that for anybody who doesn't like Ubuntu, it's a bit of a rough time at the moment because you literally can't get away from us on the internet. And I think that is in part due to a much increased cadence of communication, whether that's blogs, whether that's on Mastodon, whether that's people appearing on podcasts, community interactions. And I think this is really, really important. For years, Canonical has been doing a bunch of things seemingly in secret. And what's really interesting is I go and talk to prospective customers, I talk to community members and watch their eyes light up when I describe some of the things that can be done in our ecosystem. And I think we're doing a much better job of conveying that now. Automation was another key piece. The release team, bless them, all sort of collectively went white when I told them that the first thing we were going to do to fix our release process was ship it every month. But they've done it. They literally, I was expecting chaos and to miss the first few, but they literally shipped every single one of them on time on the day without missing a beat. And that is in part due to some heroic efforts in the background, but in part due to an increasing set of automation, an entire new release machinery powered by Go and Temporal and some other exciting technologies, which has completely transformed the way that we build, test, release Ubuntu. And we really started to see the fruits of that with the LTS release. Lots of the existing processes that have kept Ubuntu sacred, things like the stable release updates, the developer membership board, the MIR processes are all important and kind of deliberately gating or difficult processes to go through. My view is they need to be difficult in the sense that they are there to protect the quality of the community and the operating system, but they also need to not get in the way. And so we've spent a lot of time studying where things get stuck, understanding where we can improve the throughput, staffing up those teams more with upskilling, and we've seen more new core developers in Ubuntu in the last 6 months than I think we had in the previous 3 years as a result of doing that. So really, really pleased to see that kicking off too. And finally, modernization, the sort of poster child of which has been shipping Rust utilities, which has had the delightful side effect of earning me a whole new set of nicknames on the internet. So in 2604 LTS, we did core utils. So this is move, CP, RM, ls, all of the stuff that people kind of know as the de facto Unix-like experience on Linux. And many thanks to Sylvester and the team at UUtils for that. They pulled off a heroic effort, a combination of their work and 2 funded security audits by Canonical to kind of clean up any remaining bugs. But critically, in sudo rs, which sits right at the privilege boundary on every single Ubuntu machine on the planet, that is now a much tighter memory-safe tool that doesn't implement some of the features that we have collectively learned perhaps we're a little ill-informed. And I'm really, really pleased to see that happen. And we're not done. So coming up is UPKI. UPKI is essentially an acknowledgement of the fact that lots of the excellent cryptographic practices that we have in browsers these days were actually just absent on Linux systems. Like, raise your hand if you knew that when you curl something at your command line, it completely ignores certificate revocation lists. Or if the server is misconfigured and doesn't send you the full certificate chain, while it might work great in your browser, it will fail at the command line. And this has always been the case. This has never been a thing on Linux. And we are funding some work through the Russells team. So Russells is the TLS implementation for Rust, essentially like an all-Rust equivalent of OpenSSL, to build a utility called UPKI. The U is actually for universal, not Ubuntu, but it is kind of fitting. And this will provide certificate revocation. It will also provide support for things like intermediate preloading, and also give us a platform to implement modern PQC algorithms, potentially things like Merkle tree cryptography, right at the system level in Ubuntu. And alongside the utility itself, we are also doing the work in OpenSSL, GNU TLS, curl, and those utilities to make sure that that is plumbed all the way through. And my hope is that, while I think Ubuntu will get it first, this I really hope will proliferate out, throughout the Linux ecosystem, and potentially out even to things like the BSDs and such. It's built deliberately to be something that can be used as widely as possible. It's sort of a contribution back, if you will. NTP-DRS, I'm very excited about, because when we land that, it will be the only single binary, single configuration utility that gets you NTP, NTS, and PTP, no messing around, done. Which has been an incredibly painful thing in the past for anyone who has enjoyed setting up precision time on Linux. This is going to be a huge uplift. And hopefully it's clear we're picking the kind of path through memory safety rewrites quite carefully to hit the most critical things first. And I think cryptography, time synchronization, and privilege escalation are right at the forefront of that. And then compression libraries are interesting for a different reason. So this cycle, we're going to swap out bzip2 for a Rust implementation, and we will also try and target zlib and zstandard by 2804. And this is interesting for a different reason, and that is efficiency. The bzip2 implementation is up to 50% more efficient in Rust. And if you think how many servers are lighting up CPUs right now with bzip2 in the world, that is a monumental difference in energy consumption if we can roll it out across every machine. So the more of these compression algorithms we can get across, the more efficiency there is, the less power is being consumed, and the more, I guess, cycles your agents can eat. But you know what I mean. This is huge. I'm still being surprised by people's eyes lighting up about this. It happened just yesterday at a customer meeting. You can now just apt install CUDA and apt install ROCm, and I have personal experience to suggest that it just works. My AMD GPU has never sung as nicely as it does on 2604, and I didn't have to endure any pain. It was wonderful. So huge thanks both to AMD and NVIDIA, and also the partner teams that sit kind of alongside Ubuntu engineering that have made this happen. I think this is a huge uplift in usability and in performance for the platform. I think by now, this is almost boring because we've got quite good at it. We ship the very latest Linux kernel, we ship the very latest GNOME, no excuses. Even if they're in release candidate, you're going to get the latest, and the team haven't blinked on that. It was looking like we might ship an RC kernel this time, but thankfully it all lined up. And I very much intend to continue this. I think it becomes even more prevalent where we've got such a pace of evolution in hardware. This was a really long coming feature, first-class support for TPM-backed FDE. This is now generally available on the desktop and will be rolling out to server over the next couple of cycles. This is essentially an analogous experience to what you would get with BitLocker or FileVault. It has some really nice side effects for the user, which is you get better security and better usability, which is a rare treat. But also for enterprises, we've built in first-class support for things like recovery key escrow to landscape. So if you're a system administrator managing a bunch of workstations and you don't want that awkward conversation when someone needs their disk recovering, it should be covered. So this will continue to improve and roll out to our server and cloud instances as we go forward. And then a few other little goodies. We now have a dual-tracked container invert stack, so you can stick on a nice stable version if you want, or you can have the rolling versions. Traditionally, the LTS had the rolling version because container runtimes were still quite exciting 10 years ago, and they kept changing every 5 minutes. Now they're a bit more stable, and some people would prefer that kind of pick a version and stick there for 2-year approach. We continue to ship the latest and greatest tool chains. There was a begrudgingly very excited article about our dev pack for Spring, which is a really fast way to get started with Java development, and they were absolutely livid that we've made it so excellent with snaps. I'm delighted. But we continue this good work. Our Rust team has grown enormously. We have a Zig preview, so you can now apt install Ghosty, and it's built from source properly with a Zig toolchain in the archive, which is very nice. We continue to work on cloud authentication with Auth-D. This is if you are an Entra ID or a Google Cloud or an Okta or a Ping or a Duo house, you can have your users authenticate to their Ubuntu machine in a first-class way with an OIDC identity provider. And we introduced architecture variant support, which allows us to basically ship entire copies of the archive that have been specifically optimized for different versions of an instruction set. And we started with AMD 64 v3, but we will be rolling this out for various different versions of ARM and the RISC-V ecosystem as we go forward. And this is essentially not just for DEBs, this is for snaps and rocks and charms and all of the other things that we do. When you do put your hands in your the ever needing deeper pockets to buy hardware, this is to ensure you get the very best of it, right? You're not buying a machine that has a hardware acceleration for a particular instruction that never gets used. You are using all of the capability of the machine. And 2 final points. We are now running previews for Ubuntu Core in the public cloud. I think this is going to be killer. Why would you not want to run your kubelet on a confined, essentially immutable operating system, or your very specific cloud workload in a super confined, immutable operating system? This is available on Azure, it's available on AWS, it's available on Google Cloud. And we did lots more work on permissions prompting in snaps. This was an incredibly kind of intricate piece of work that went all the way from the kernel through AppArmor into snapd, up into GDM, and even like a user space application. That means when your snapped application does hit confinement and it needs the camera and it hasn't been told it can have it, it can surface a prompt and say, I'd like to use your camera. Would you like to give access? So much as you will have become accustomed to on iOS and Android, we're bringing that to the desktop too. How we surface that on server is still a little bit unclear. It turns out notifications at TTY is kind of complicated, but I have a bit of a plan. We'll be rolling that out over the coming cycles. And that's all from me. Have a stonking summit.
Thank you very much to John and Mark. I think we're now ready to move on to our next talk. So we will be welcoming Nariman Jelve from Pewter. He's the founder, and he'll be diving into some of the challenges behind moving the entire desktop computing experience to the web. So Nariman, the stage is yours. Please give him a round of applause. So while we get set up, a reminder to everybody watching that Discourse is the place to ask questions. We're happy to accept questions at any point during the talk. Best to get them in early so we can have a look at them. And if we have time at the end of the talks, we'll make sure that we ask them.
Yeah.
Okay, please, another round of applause for Nariman.
Now we're going to do the mirroring thing again. Got it? All right, good. All right. Hi, everyone. My name is Naiman, and I'm the founder of Pewter, the open source internet computer. In this talk, I'm hoping to share with you what Pewter is and the how and the why of building it. Before I get started, I'd like to tell you a little more about myself. So I've been programming for 30 years now. Wrote the first line of code when I was 7 and professionally since 17. I studied computer science at the University of British Columbia in Vancouver, Canada. Worked at a number of local companies writing code throughout my studies, and towards the end of my last semester, I actually started my first company. So I dropped out and worked on that company for about 10 years, which was focused on massive scale web data extraction. And then eventually I started working on Pewter in 2021, first as a side hobby project, and then I turned it into a company, and here we are right now. My passion revolves mostly around the web and distributed systems. For the past, I would say 15 years, this has been my focus. I've done a number of other projects along the way. Well, I'm an open source maximalist, so I have a lot of open source projects, the most successful being Pewter, but I've done a lot of other open source projects such as Pewter.js. This probably doesn't count because it's the SDK for Pewter, but it's a pretty popular project. And then I have KV.js, which is in-process caching module for Node.js. It's a mouthful for basically a simpler Redis clone for Node.js. I have Oops.js, which is undo redo module for JavaScript applications. PHP work, which is web archive handling, handling in PHP, and a number of other projects. But in this talk, I'm focused on Pewter. So what is Pewter? In short, I would say Pewter gives every user a computer on the internet. So if you go to pewter.com, create an account, you will be given a small cloud computer connected to the desktop environment that is rendered in the browser. Basically, this cloud computer has limited storage, some database, some other types of resources like compute, and it is interface using this desktop environment, meaning that you can access your cloud computer from any device that has a browser with this super familiar Mac OS-like, Windows-like interface. All of this is rendered in the browser, which I'm going to get into later. What do they use it for? I mean, this is the most common question. Why would you even do this? And what is the purpose of this? Well, just like any other computer, if I dare say so, just like any other computer or operating system, it's a very general purpose. So people use Pewter for a variety of reasons. A lot of people use it to simply store files. I would say a better alternative, an alternative to Dropbox, Google Drive, and OneDrive. So you can put your files in there and you can access them from anywhere at any time. The good thing about it is that you don't really have to install any applications. You have a device that has a browser, you can log in, you can access your files. Basically, that means a lot of devices out there, whether it's your phone, your laptop, your desktop computer, your Tesla, your VR headset, anything that has a browser, Pewter does a good job running on. We have a lot of apps and games, so not only can you put your files in that cloud operating system with the desktop environment experience, you can also open those files and you can modify them. A lot of productivity applications, word processor, spreadsheet, presentation, basically an entire Office suite. We have code editors, photo editors, video editors. You name it, we basically have it. We have a lot of games as well. Strategy games, puzzle games, action games. So a lot of people just show up to Pewter to play games. Again, it's very general purpose. People use it for different reasons. Some people write code on it. Some people play games, some people use the productivity applications or simply store files. But one thing about Pewter that is very unique to it is because it's completely cloud native. This whole thing is running in the cloud. Only the interface is being rendered in the browser. Because of being cloud native, you can actually directly write code on it and publish websites and applications using it. So as you can see in this screenshot, I have this directory on my desktop. It contains, for example, an HTML file. I can right click on it, just publish it as a website, and boom, because it's a cloud file system, so it's connected directly to the user, and the website is just published there. You edit the file, it's automatically updated. As you will find out later on in the talk, this is actually a very, very important part of Pewter and why the broader audience of developers use it. If you want to get started, here's my curl to bash. I didn't have this slide in actually when he was talking about curl to bash, I put it in. So you can use the curl to bash, and we have the hosted version on pewter.com. Pretty easy to install. You can get started. We use a really cool thing about Pewter was that you could go to pewter.com, it would just provision the desktop for you, but we put a sign-up wall in front of it just because of the sheer amount of abuse we were getting. So you can self-host it easily, or you can just go to pewter.com and use it. Now, in terms of what I'm going to talk about, a few things about Pewter. This is mostly a technical talk, but first of all, Pewter is open source under AGPL. I would say more than 90% of what you see on pewter.com is actually the open source project, plus a number of proprietary extensions. I'll get more into that soon. Pewter is monolithic. One repository, pretty much everything that makes Pewter work. It's all in there. The backend, the front end, the SDK, the documentation, all of it. We are a JavaScript shop. The vast majority of the code base is written in JavaScript for reasons that I'll get into soon. And then there are three major pieces to the project. One is the backend, obviously the what we call the distributed cloud operating system with servers all around the world, doing all the distributed stuff behind the scenes so that the user or the developer is not exposed to it. The front end, which is the desktop environment, and Pewter.js, which is our SDK that allows the desktop environment to use the backend and allows applications to interact with the desktop environment. It's also isomorphic, and you can use it on in any other environment, basically, that supports JavaScript. Pewter being an open source project, for the first 3 years, it was actually not open source. I was working on it as a closed source project. I put it on Reddit, it blew up, and they convinced me to open source it, amongst other things. There were a couple other people that really pushed me to open source it. We open sourced about 2 years ago, and so far we've amassed 41,000 stars, vanity metric if you care about it. 400,000 downloads and 373 contributors, which I think is the most important part of it. We also have a couple thousand forks under our belt. Pewter has been forked by a lot of other projects. It's pretty popular in crypto. People, if you know Web3 and the idea of a computer in the browser is something that the crypto community really takes a liking to. And it's being used by other projects as well. I know of one company in China that's trying to fit Pewter into cars. Hopefully they're successful. That would be good for us. So it's all over the place. It's very interesting to see how people fork and try to adapt Pewter for different environments and use cases. Moving on to the monolithic architecture of Pewter. Again, Pewter is a monolithic repository. Everything from the back end to the front end to the SDK to the documentation, all of it is in one repository. There are a couple of reasons for that. One, which is my favorite, is that the changes are pretty much atomic across projects. So you can do a full stack change when you need to ship a feature or fix a bug. Everything happens within that project. So one build process, one installation process, and one runtime. So that's really my favorite. And I think this whole thing started as my preference of building applications, which was mostly in monorepos. Again, easier full stack development and testing. You want to ship a feature for end user applications for the user space. You want to ship something for that particular part of the project. Typically, with a project like ours, which is still young, you probably have to do something in the back end, change the SDK a little bit, write tests for the back end, for the SDK, for the front end. So it's happening all across the stack, and being a monorepo makes that much easier. And the third reason, which is not really technical, is that if something is within the monorepo or the main project, it just gets more developer mindshare. There's a network effect to having repositories that, again, vanity metric, but have a lot of stars or have a lot of contributors. People want to contribute more to those projects rather than smaller ones. So if we have a lot of repositories under our org, for example, if we break out documentations, which we did, into a separate repository, typically we don't get that much contributions. So we put them all into one repository so that people can claim that they contributed to this big project, which is true. Documentation is obviously a big and important part of any open source project, but we've come to learn that they want to contribute under the name of Pewter, the main project that has a lot of views on it and gets more mindshare. So that's one non-technical reason for it. And recently, having a monorepo is actually super AI friendly. You can tell your agent, you can point your agent at the repository and you can ask it to ship a feature. It'll ship the feature, it'll ship the tests, it'll ship the documentation for it. If it's an API, it'll change the SDK as well. So all of it happens in one go, which I think is pretty amazing. Obviously, you can have sub-modules, and the sub-modules can be pulled into the repository, but having one agent's MD at the root of your repository just makes things so much easier. And generally, we lean on the community a lot, and that's why we want to have one central place to communicate with them when it comes to issues, projects, and things like that. Obviously, we have our Discord and other social spaces to interact with the community, but we like to have our projects managed on GitHub and Linear from one repository. Yeah, we're a JavaScript shop. We use Node.js in the backend, vanilla JavaScript in the front end. We've made some controversial choices when it comes to our stack, but there were some really practical reasons for picking JavaScript. One big reason is that we're sharing a lot of code between the backend and the front end. A simple example would be path resolution in the file system. Not a really big piece of code, but pretty intricate, and you want to get it right. So especially before AI, this was incredibly important. You want to save as much as you can when it comes to writing code. So the code that does path resolution in the backend is the same code that does path resolution in the front end. There's many instances of that in our code base where we're sharing backend and front end code. Obviously, that also when it comes to people working on the project, if you know JavaScript, you're likely to be able to contribute to the backend or the front end. So it also helps with that. One person can contribute to many parts of the project. For the backend, going with Node.js, once we decided we want to have isomorphic sort of a situation, we went with Node.js. But then again, even if I went to share the code between backend and the front end, I would have probably gone with Node.js for other reasons. But one big reason is the non-blocking I/O that Node.js offers. I mean, 2010, it was very important back then. But yeah, non-blocking I/O and Node.js is important when it comes to performance. But then again, you don't have many choices if you're going with JavaScript in the backend. So maybe this point is kind of moot in that sense. Also, one important reason with going with JavaScript is the great SDK ecosystem by vendors. So one choice I had for the backend, aside from Node.js, was Rust. But the problem was that, especially again before AI, Rust did not have good SDK support with cloud providers. So we couldn't really, I mean, writing an SDK for example, S3, that's very, very time consuming, especially without AI. And a lot of it, we use a huge number of vendors. We use a huge number of third-party APIs in our backend. So not having SDKs for those would be very time consuming. Again, even with AI, it's still, you don't want to write this stuff from scratch. You want to use the SDK provided by the vendor. Now AWS does actually have the Rust SDK, but some of the other vendors we use still don't. Another pretty good reason for using JavaScript, there's so many developers out there that know JavaScript. By some estimates, 28 million. Seems a little too high to me, but yeah, I would say there's probably millions and millions of JavaScript developers. And it's a very simple language. It's not difficult to understand. The abstractions are pretty shallow. You can get started with JavaScript very quickly. I think back in the day when boot camps were big, they would either teach Python or JavaScript, mostly JavaScript for people getting started. So there's a lot of JavaScript developers. And the pragmatic choice here when it comes to the knowledge around the language is that you want to go with something that is very popular and a lot of people know, just so that you can increase the pool of contributors and people who can connect with the code base. All that said, we do have other languages in our project right now. We do have Rust now for our networking layer. We have Python for some of the tooling. So it's actually expanded beyond JavaScript, but still the extreme majority of the backend is JavaScript, the front end as well. We have some WASM and things like that in the front end too. Now the backend. So one of the reasons we call Pewter an operating system. I would have called it in the beginning of the talk an operating system, but I think I'm in the wrong neighborhood. I shouldn't call it an operating system. So I call it computer when I'm a little scared. But one of the reasons we call it an operating system or a cloud operating system is because what it primarily does in the backend, and most of the magic, honestly, the desktop environment is nice and all, but most of the magic is actually happening in the backend. What the backend does is that it basically manages resources and provides consistent API to applications. That's what it does. I mean, at the end of the day, that is also a classic definition of what an operating system is, whereas the classic definition of operating system has to do with hardware. With Pewter, we're talking about cloud services. So the cloud file system, the database, the networking layer, and a lot of other APIs that are integrated deeply into the backend and applications can use. So that's partly the reason we call it. The backend is responsible for that. It's written completely from scratch. For building Pewter, we tried so many different approaches in the beginning. Well, I tried. It was only me in the beginning. I tried so many other approaches, streaming containers, VMs. If you remember a few years ago, the browser is the new OS was all the rage. So I tried forking Chromium and trying to do all that. None of it worked. At the end of the day, I realized if you're actually serious about this, having a cloud OS with a separate interface, you have to write the whole thing from scratch, the file system, the database, all of it. These days, our focus is mostly on simplicity, security, and stability. So we don't allow feature creep. We say no to a lot of features. I think we have all the features that backend needs for the most part in terms of really big APIs. We have the file system. We have, as you can see, the distributed file system, the database, the AI integration, AI gateway integration, authentication, everything that you need to basically ship or run applications, we have it. So we are mostly focused on the S3. We want to be simple, secure, and stable. In fact, we've recently done a major refactor of the backend, removing something like 100,000 lines of code. And improved our stability significantly, added a lot of test coverage. So we are, when it comes to development of the backend, this is what we're mostly focused on. There are two really interesting parts to the backend. One is drivers, just like device drivers we were talking about. We do have the concept of drivers in Pewter as well, which allows Pewter to interact with outside services. And given the number of developers that are using Pewter to build applications, I think that is more and more becoming something important for anyone who provides an API. I wouldn't say important, but it's very attractive to them to get integrated into our backend. And this driver system that we have actually allows for a standard way to build an integration with our backend. So a driver system completely inspired by how drivers are done in operating systems, just adapted for our use cases. In fact, we very recently did a partnership with an AI inference provider. We went through the driver method. We shipped the driver. It was pretty easy. It's in the open source. So it works really well. The concept of drivers completely mapped to the cloud. And we have extensions. So extensions are a bit different. I did another talk that is going to be played soon after this one, which I talk about, in which I talk about the challenges of launching and scaling a large open source project. And I think one of the biggest mistakes we did in the beginning is that we didn't have an easy way for us to ship the open source project to the proprietary code base or deploy it to production. Any open source project, any commercial open source project typically has two parts. One is the open source project, and the other one is the proprietary version of that. Now, if you're not careful, you're going to end up building two products at the same time. Even though they look and behave the same, it's so difficult to get the tooling right that you end up having two separate code bases. One is the open source one, and the other one is the proprietary one. And you're managing basically two products. This thing, extensions, is basically an easy way that allows you to extend the functionality of your code base, of your open source project with proprietary code. I wish we had done this earlier when we launched a project, when we open sourced a project, but we didn't. And it took us a very, very long time, almost 2 years since we open sourced to get this right. But now we have an extension system that allows you to easily extend the open source project with your own code. For example, the payment infrastructure of Pewter, pewter.com, is actually an extension to the open source project. The way it works, I'm not going to go too deep into it, but the way it works is that you have hooks. I'm not sure if you're familiar with WordPress, probably are. There are hooks in the code base that send events out, and these extensions can pick up those events, do something to them, and then return it to the core. So you don't have to understand how those 300,000 lines of code in the backend work. And honestly, all you have to know is what those events are, how they look like, and you can just pass them around as extensions. So if you want to add payments to Pewter, it would be a completely separate file. It just takes that event in, changes it, takes a look at it, says, oh, okay, this, for example, this payment went through or not, and sends it back to the backend. You never have to go in deep into the code to understand what's going on. This is one thing I recommend anyone who's doing something similar to Pewter, where you have an open source project and a hosted proprietary version, to look into. I think that's very important. The front end. The front end being mostly the desktop environment is fully rendered in the browser. Most of the time when somebody goes to pewter.com or when I'm showing them Pewter, they think that we are streaming the desktop environment from a container or from a VM. That's not the case. The entire desktop environment experience is rendered in the browser. That thing is completely JavaScript, CSS, HTML. That's it. Nothing is being pixel streamed from the servers. The reason for that is, first, is the cost. I mean, if you're hosting on AWS, you have to pay 10 cents per gigabyte, and that's very significant if you have a lot of users. So first one is the cost. It just is very costly to stream pixels. The other one is performance. No matter what you do, unless you have a lot of edge servers, you are simply not going to get the type of performance that somebody expects from a desktop environment. You click on a folder, you just want it to open. You don't want there to be latency or lag. And if you're pixel streaming, you're out of luck. There's at the end of the day, you're going to hit the limits of physics. So we decided to do the entire desktop environment in the browser. Obviously, it was incredibly difficult. It took a very, very long time to make it stable, to make it work right. But it is pretty stable now. It rarely ever crashes. It's a pretty good experience. I did some controversial, I made some controversial decisions when it comes to the architecture of the front end. I didn't use any frameworks. It's not based on React, Vue, Angular, or anything like that. And when I open sourced Pewter and got a lot of attention, this was one of the points of flame wars on Reddit, Hacker News, and everything. And I mostly stayed out of it, but it was fun to watch people getting so religious about this. So I didn't go with frameworks for two reasons at the time. Well, I would say three reasons. One is the performance. With desktop environment, we're dealing with a completely different league of performance issues than a regular, for example, SaaS application dashboard. There's a lot of rendering happening. There's a lot of DOM manipulation that frameworks are just not good at, and they're not designed for that kind of interaction. So that was one reason. That would be a major reason. The other one is that pretty much every single really performance intensive web application that you see, OnlyOffice, Photopea, I think even Google Docs, none of them use frameworks for the manipulation of the DOM in the browser. They're all using either their own way of doing things or Visual Studio Code. That's a really big example. They're not using frameworks for pretty much the same reasons as the ones for Pewter. Performance, and the third one would be you just want to be in control of your destiny. If any of these frameworks, and I'm old enough to see frameworks really peak and then disappeared into nothing. So if a framework is abandoned, again, now you have to maintain a framework on top of what you're doing. So I rather just use the base technology, the base open technology, which is the web APIs provided by the browser. I decided, since it wasn't enough flame war when it comes to frameworks, I decided to use jQuery of all things. If you're familiar with web applications, jQuery is this pretty old, I would like to call it pretty mature, but people call it pretty old, library from 2008. It was designed for a time where there was so many issues with moving one piece of code from one browser to another. jQuery's whole value proposition was that, hey, we're going to make this easy. You use our API, and then your code is going to run everywhere. And it did. It's very. I think it's still being used by millions and millions of websites. I decided to go with jQuery for another reason. I think the API is incredible, even though a lot of it has been absorbed into the standard JavaScript provided by the browser, but there are still some APIs that make it really the DevX is really good. So those APIs help you write code faster, and the code is pretty defensive. You're not going to run into issues because you got a loop wrong around elements in HTML and things like that. To be honest, I think I keep bringing AI up, but I think because of AI, this stuff is not that big of an issue anymore. I don't think AI makes mistakes when looping over elements. So you don't even need jQuery for that. But when I was working on the desktop environment, there was no AI, so I had to hand roll everything, and this stuff really mattered. Now, the app runtime on Pewter, if you go to pewter.com and you open applications, you see the windows just like a regular desktop environment. You see these applications that run in the desktop environment. Those are iframes. So the runtime for applications on Pewter are iframes. Those are web pages being loaded in iframes, and that iframe communicates with the desktop environment and the backend using the SDK. So the runtimes of our desktop environment are iframes, which also gives us some really incredible powers. The most important one being sandboxing. I mean, iframe sandboxing, browser sandboxing is just incredible. The entire IT industry depends on it. You log into a bank, your online shopping, whatever you're doing, you depend on the sandboxing powers of the browser. So it's very robust, and we're taking advantage of that for our app runtime, which gives us incredible security. There are IPC issues that, and we've caused many of them, that kind of messes up with the sandbox promises of the iframe, but that's another discussion. The front end also has the same extension system. Once we realize how badly we messed up with having only open source and no extension system, we implemented it in the backend and immediately implemented it in the front end as well. So the same extension system we have in the backend, we also have it in the front end. You drop a file in there with your proprietary code, and it's just going to work. And last but not least, that desktop environment is largely artisanal. I hand-rolled everything. Well, after we open source, we got a lot of contributions, but there wasn't much AI used for the front end. And still, because it's been stable for a long time and we don't touch it a lot, it's still the same handwritten code from all these years that we didn't use agents on it. So the majority of it is actually, as they call it, artisanal. This is the before and after of the desktop environment. The first version, the very, very first version, the first day I was working on Pewter, I took a screenshot of it. And this is how it looked. And this is from, I think, a month ago. So it was only a modal with the terminal. You double click on it, it would show this thing. I don't even remember if there was a terminal in it. But yeah, we've come a very long way. The SDK, Pewter.js. So the entire desktop environment and applications inside of it are actually powered by the SDK. So not only do the applications use the SDK, but also the desktop environment is dogfooding it as well. We call it Pewter.js, and this is the project I brought up in the beginning. It's part of Pewter, but I'm really proud of it, so sometimes I introduce it as a separate project. It's isomorphic. First and foremost, it runs in pretty much any environment that supports JavaScript. Obviously, the browser, that's its home. Node.js and workers. Am I missing something else? I think these three are the main ones. So isomorphic library that can run anywhere that you have JavaScript. It gives the developer a true serverless experience. So all these applications that you load on Pewter, they are fully connected to the backend, and there's no server in between. And this is the real power of Pewter that is lost in all the desktop environment and all the craziness that's happening around that. But what it gives developers is a true serverless experience. If you build an application, whether it's on Pewter or not, because again, Pewter.js is isomorphic, your application is going to have cloud storage, database, networking, AI, compute, I mean, whatever you can think of, and it's completely serverless. You don't have to set up a proxy. You don't have to work with containers. You don't even have an API key. In fact, you don't even need an account to use Pewter.js because all of that is handled by the way Pewter provisions the scoping around authentication, which is, I mean, we don't have to get into that, but that really, the end result of it is the real magic of Pewter. It's a user pays model. Just because, you know, when you give every user a computer on the internet and they can take it to different applications or open different applications in it, that means those applications are running in the user's account rather than any other traditional way of building applications where the developer is provisioning infrastructure and is basically renting it out to different users. In this case, just like the good old days where you would buy software, you put it on your laptop and you're paying for the infrastructure, same thing happening here. So we've gone full circle. What's happening is that the application is running within the user's account, meaning it's consuming the user's resources, just like a laptop, or you could think of it just like the user bringing their own wallet to your application. What that means is that what we call it the user pays model, or bring your own backend. That in practice means that whatever application you build on top of Pewter is actually going to be completely free in terms of infrastructure for you. So even if you build a Dropbox on top of Pewter with 1 million users, one user to 1 million or to a billion, it's going to be free for you. You're never going to pay $1 in infrastructure to us. Every user covers their own usage. As far as I know, we're the only people who've ever done this. I haven't seen anything like it. I think Anthropic is doing something similar when it comes to AI somewhere in their projects. I saw something, but we are pretty much the only people who've done this. The SDK is available on NPM and CDN. Interestingly enough, most people in AI prefer CDN, it seems like, which is surprising because I would have thought NPM would be more popular. And all the stuff I talked about being isomorphic, really, really serverless, like in the truest sense, purest sense of the word, meaning you don't have to create an account, you don't need an API key, you don't need any of that. That actually accidentally made Pewter very popular with AI agents. And it's sort of becoming the backend for AI coded apps. I would have never imagined this would be the use case, but especially since AI agents took off, I would say within the past 1 year, we're seeing more and more apps just defaulting to Pewter.js, which is a very, very interesting development right now. But this makes AI apps secure and scalable by design. The problem with vibe coding or AI coding applications right now is that, for example, you go to your AI agent, you tell it to build me a to-do list, and it starts building the to-do list. It does a front end, and it looks nice, but all of a sudden it'll tell you, okay, go create an account on this cloud provider, get me the APIs if you want to actually deploy it. Give me the API keys, put them in the backend. Now you have to put the backend somewhere. And then all of a sudden you have the code, but good luck running it, especially if you're non-technical. And then you have to scale it and all of that. But with Pewter, you take that SDK, the AI actually knows how to use it already. They take the SDK, they drop it in the HTML file, and it just works. They don't have to ask you for API keys, for an account, nothing. So that's why it's become a hit with AI. If you want to give it a try, it's no curl to bash. You don't need it for the Pewter.js test. You can just go to your Codex or Cloud Code or any other AI coding assistant and just tell it build and run a to-do app using Pewter.js. Now, as far as I know, they all know how to use it. So they're just going to churn out the code, they're going to run the server, and they're going to show it, and it's going to be fully cloud native right off the bat. You will see how it works. Now, just going back a little, I forgot to tell you about this. Now, the way it works, when you use Pewter.js in your application, the way it works is that it's automatically going to ask the user to log into the application using their Pewter account. Basically, it's asking them to bring their wallets with them or allow the application to tap into that cloud wallet. So this is the permission prompt that I forgot to talk about. It's basically asking the user to log in or create a user, and then everything just works. If you ask AI to build an application, it'll pretty much look the same. The application will show up, and at some point, it's going to ask the user to either create an account or log into their Pewter account to make it work. These are some of the applications that are built using Pewter. There's games, there's Polotno, the photo editor, music player, Judge Zero, which is a code execution IDE plus IDE in the browser. This is a browser that uses our networking stack. We have pretty much everything you could imagine when it comes to it, but it's really fun to see how this is getting into the long tail of applications developed by AI. You can go to developer.pewter.com/showcase if you want to see some of these applications. As we add them, we just shipped it a couple of days ago. So if you want to see how popular, this is why I'm so proud of it, how popular Pewter.js has become. I think I honestly don't remember exactly when we shipped the isomorphic Pewter.js. It was sometime in mid-2024. So by March 2025, we had 1,400. This is wrong. This was December 2024. Sorry about that. So in December 2024, we had 500 new apps added, 500 new apps powered by Pewter.js in 1 month. So something around like 15, 16 apps a day. And by March 2025, that number grew to 1,400. So this is the graph from December to March. And the end of that graph is March 2025. And then, so this kept happening, and as AI took off, this started accelerating. And now, if you put that into perspective, we went in January again, we had 1,400 total apps, and then that grew. This is the total number of apps, and we're projecting 94,000 total apps in May 2026. So it accelerated incredibly dramatically. Part of it is, well, we got lucky, because Pewter.js is just a good match for AI. And I think just just the fact that AI took off the way it did within the past 1 year, that everybody's shipping applications, helped a lot. And also AI already knows how to use Pewter.js. That's why when you prompt it to use Pewter.js, it just knows how to do it. I've noticed that recently it does go to the documentation if it needs it, but even before that, it already knew how to use it. I think all the code on GitHub and all the documentation that we published even before these tools were so popular just made it into the training. So yeah, it's been growing very dramatically. It's caused a lot of issues. Obviously, we never expected it to grow like this. We had many outages, but we're super stable now. For, I would say, maybe something 8 to 9 months, we had constant outages. It was hell. But after re-architecting a lot of stuff, the refactor of the backend, making a lot of changes, moving to containers in the backend, we have it under control. We have pretty good. I think we're at almost 4 nines. Yeah, I don't want to I don't want to get that wrong. So I think it's 3 nines, something like that. And when it comes into availability, which is pretty good for something like this. So the question is, what is Pewter? I think increasingly it's becoming the infrastructure for AI apps. This is the highest growth area I'm seeing in Pewter, even though the desktop environment is being used a lot. Especially before people were using AI agents to code, our code editor was incredibly popular. We had something like 10,000 daily users for the code editor alone in the desktop environment. But I don't see many people writing code by hand anymore. So that part is not as popular. But what really blew up is definitely the infrastructure and the SDK. So again, increasingly, I think the best definition for Pewter would be the infrastructure for running AI-coded applications. That's about it. Thank you.
Thank you very much, Nariman. We have a question for you from the community. So you mentioned Pewter running comfortably on phones, VR headsets, and vehicle displays earlier in your talk. What's the most interesting piece of hardware you've seen Pewter run on?
I think it was a watch, if I'm not mistaken.
Okay.
Yeah, I saw it running on a watch, and we actually do have it listed, I think, on our Twitter, and we started this hashtag campaign. Does it run? Does it run Doom? We had the does it run Pewter? So I think the one on the watch was the coolest one I've seen.
And you mentioned earlier on that you had to be convinced to make it open source. What was it that tipped the scales in favor of open source for you?
Yeah, so I put it on Reddit. It blew up, and a lot of people asked me to open source it. I would say that was the big push, but I didn't open source it right there and then. I got to meet a really amazing open source founder, open core founder, the founder of this workflow automation system called N8N, which is pretty popular now. So I got to meet him, and he was really the driving force for me to take this seriously. And then he introduced me to another person that was the last nail in the coffin, and that really pushed me to open source it. But I had I get deeper into it in my other talk, but I got some really good reasons why I should open source it. So it was a definitive decision for me at the time.
Fantastic. And the final question then. If you want to get involved in the community, what do you have to do? Where do you have to go? What sort of experience level do you require?
You don't. You can contribute in any way. You can come contribute to documentation. You can use your AI agent to just pick up an issue. You can help the community. We have some people that just answer questions on our Discord, on our Reddit. We love it. You can contribute in any way, and we try to support you. You don't have to be a great programmer or anything like that. We welcome anyone and everyone.
Fantastic. Please, can we have another round of applause for Nariman? Okay, for everyone watching remotely, we're going to take a short break, but don't go anywhere because we do have some recorded lightning talks for you. Thank you very much.
Small man by the day, she might as well sing. We're slipping further away. my own concoction to comfort me. One part guilt trip, two parts anxiety. Ain't no one look like the profile do. We don't come for facts now, baby. We come for truth, and I say, don't slip through the cracked up glass on your phone. Who's kissing your ass whenever you get home? We all need a pass, some slack in the road. Live young and die fast, you never know. What were you here for? Why do you want more? Like a daddy done said, you get what you get.
Hello. So, yeah, I'm on the Ubuntu Foundations team, and one of the many things we do in Foundations is we maintain the machinery that builds the installers. The desktop team make the Ubuntu desktop, but we get it onto your system. I assume everyone in here has used an installer once or twice. The production installers, like all our other production software, built on data center machinery, using machinery that's reasonably well oiled. But when you're working on the machinery itself, or you're testing a change to the installer, it is convenient to be able to build installers on your machine. And teams like Field and OEM who interact with customers often want to be able
mama found out, you get what you get. Like daddy done said, you get what you get. Like a mama found out, you get what you get.
Hello. So, yeah, I'm on the Ubuntu Foundations team, and one of the many things we do in Foundations is we maintain the machinery that builds the installers. The desktop team make the Ubuntu desktop, but we get it onto your system. I assume everyone in here has used an installer once or twice. The production installers, like all our other production software, built on data center machinery, using machinery that's reasonably well oiled. But when you're working on the machinery itself, or you're testing a change to the installer, it is convenient to be able to build installers on your machine. And teams like Field and OEM who interact with customers often want to be able to make installers that are slightly different for whatever reason than the ones we ship. There's a lot of history in how installers are made, so instead I made a picture of what the process used to look like. You thought this guy. He's got a little bit smaller over the years, but it's still been pretty painful. The worst part of it was that making the live file system, or the bits that get copied onto your system, And actually packing that into an ISO or container format will run on separate machines in separate steps. This is the sort of process you went to build a Noble installer. I hope you can't read that. We've changed two things in the last cycle. The first is that the build process on Launchpad or on your machine just makes the installer in one step. And we've added some wrapper scripts to make it easier to actually drive them. So if you want to make your ISO, you clone livestream, you make the changes you want to make, and then there's just this one script. It starts a VM, installs the various bind mounts your working directory into it, installs the dependencies, runs through the build, copies the artifacts out again. So if you want to build an ISO that doesn't always assumes the network is there and doesn't have any packages in the ISO package pool to be smaller, or if you want to use the OEM kernel, or if you want to use some kernel you're hacking on your machine, you can just do that. Livestream is still a pain in the neck to modify. It's a huge pile of shell. We haven't really fixed that this cycle, I'm afraid. And obviously builds take a while. Like, there's a lot of data being copied around. You can point it at a caching proxy, but still a desktop build is going to take 30 to 40 minutes. There's some documentation in the livestream tree. You can read that. And there's a sort of slightly more meta point here, which is a lesson that I always end up learning myself over and over again, that taking something from sort of possible but inconvenient to really easy is a step that's almost always worth taking. I'm now way more likely when hacking on livestream to just run the build on my system, and I can go off and have coffee or whatever, come back and debug the failures or whatever. And agents are really good at this kind of thing. I wrote these wrapper scripts in Claude. It took 10, 15 minutes or something like that. So if you have this task that's always just that little bit annoying, well, almost certainly you can just say, Claude, make me a script for this. And it does that sort of thing very well. In the future, we're going to be using ImageCraft, which will be a nicely polished craft tool to build our installers, and everything will be wonderful. But in the meantime, I hope I've made this part of your life a little bit easier. Thank you.
Hi, I'm Tobias. I am in Ubuntu engineering, working on ARM stuff on the foundations team. And I'm going to talk about Ubuntu Phone, but not the product from 10 years ago, but rather a new version of it. So Android is, well, demolishing themselves. So I was looking for an alternative. And my first question for you is, what's the difference between the two things you see here? And it might be less than you actually think. The left is a Snapdragon ARM laptop, the right is a Fairphone. Both internally look very similar. They're based on a Qualcomm SoC. They share a lot of drivers and hardware. So what actually is the difference, except for the form factor? And I'd argue it mostly comes down to software. Well, firmware, arguably, but what is firmware if not software, right? So why does Ubuntu run on one and not the other easily? And it's mostly about standardization of the boot flow and standardization of the firmware that gives us a well-defined API to boot Ubuntu, to port Ubuntu to. Here I'm showing you the boot flow of Android at the top in green, and Ubuntu's default boot flow at the bottom in a very simplified way. And we see there's PBL and XBL, there's Qualcomm stuff. You can just ignore it, it's common. Android boots a boot, which then looks for a kernel partition to boot Linux. And that boots you into your Android system. On Ubuntu, we expect something like UEFI, a well-defined API to load our own bootloader grub. And then from that, we boot Linux from our /boot partition, which boots our entire Ubuntu system. So I said the difference is software, and I happen to build software. So why not? Why shouldn't I install Ubuntu, right? And the way I did it is a little hacky, you might say. So what I did is, I have access to Flash a kernel to my phone. That's what you do when you install something like Lineage OS or Graphene OS. The stages before that, there's secure boot security, can't really change them. And instead of actually flashing a kernel, I flash something that looks like a kernel, but it's an implementation of UEFI, just enough for UEFI to boot Ubuntu. I used Ubuntu for that, flashed that to my partition, resized the existing Android partitions a bit, and from that point on, it looks very much like a laptop. Well, to your operating system. So, demo time. Let's hope that works. Can I get the camera? Well, so this is just a phone. There you see U-boot, and this one here is a U-boot boot menu. You probably can't read it, so I put it on here.
Hello, everybody. Can we start taking our seats again, please? The live stream will be resuming shortly.
Boot very quickly.
As ever, please sit on the front row. Okay. Welcome back, everybody. I hope that you enjoyed the lightning talks. It's now time for our next talk, which is by Joseph Marrero Corchado, who's a principal software engineer at Red Hat, and he's here to show us how to manage and deploy Ubuntu hosts exactly like containerized applications using standard GitOps workflows. Please welcome to stage Joseph.
And one of the beautiful things is that it let me install an operating system and it will just work, which was not the experience that I had with Linux before that. So I think the work that Ubuntu has done over the years is remarkable, and it's something that is a testament to the community and all the work that you guys do at Canonical. So let's talk a little bit about Bootsy. I don't know if this is decoupled. I think it's decoupled. Yeah, it was. Okay, cool. So what does Bootsy allows you to do? It allows you to define and ship the OS as OCI containers. So if you already know how to build containers for your applications, or you're building scratch builds with random stuff inside containers, you can also use that same mechanisms to now build an OS. Bootsy also lets you do transactional in-place upgrades with rollbacks. What that means is when you do a deployment, what you define the OS and build in the container image is the source of truth of what gets into the file system. If something goes wrong on that upgrade, you can always roll back to the previous version that actually worked. There's many other features that we have put into Boot. One of them is logical bound add images or system apps. These logical bound images are just container files that are also versioned with Bootsy. So you are able to not just have your host, but also applications like Apache Server or any other application that is managed by Bootsy. So when you do a Bootsy update, it will just update that container image as well as the OS. We aim to be fully OCI compatible. So we have integration with Podman, we have integration with Docker. So if you know how to do Docker builds and Docker run, these images can be run with Docker, and it can also be built with Docker or Podman. If you're using something else, it's very likely that it will just work. The cool thing about Bootsy is it's not just for Kubernetes. Bootsy allows you to deploy into any host. This laptop that I'm running here was deployed using a Bootsy container. You can use it for Kubernetes deployments. You can use it for the desktop, for edge devices. And as of last year, we are a CNCF sandbox project. So this did start in Red Hat, but now it's a CNCF project. We have many organizations already contributing and vendoring Bootsy into their distributions. If you ever had a Steam Deck, for example, there's a very popular distribution called Basite. If you have ever used that, you're using a Bootsy distribution. And my goal here today is to first share that we at the Bootsy team, we love Ubuntu. We have Ubuntu in our CI as making sure that it can actually be built in our Ubuntu host. And we are planning on extending that into some gating into if this is not running well in Ubuntu, then it's not correct. We need to make sure that it's working for Ubuntu. There's a so I'm going to be jumping between just talking and showing the browser. There's a very cool community that has dedicated a lot of time to make sure that there's images for other distributions like Arch, Debian, OpenSUSE, and Ubuntu. And what they did here is that they took what we have developed and made it very minimal and made sure that it worked without OS3, which is more of the legacy path that we used to deliver Bootsy with. And they're using ComposeFS, which is the future-looking backend that we have. So for the demo that I'm going to do, I'm using what they started as a base, but this is a very minimal image. There's no network, there's no cloud in it, there's no snaps, there's nothing. It just boots, and it's based on the Ubuntu archives. But it's not something that you can just run and use today. So I have extended that and made sure that we can have a network, cloud in it, and you can take the image that I have built and just deploy it in your hosts. Let me go back to my presentation here. Okay, so what's special about the image? It's a container image. If you are building your own Bootsy container image, it will look similar to this. The main thing is that the base image should be a Bootsy-enabled base image. The difference between that and any other common container image is that it has a kernel, it has an inramfs, it has a bootloader. So it's a little bit bigger, because it has those additional components, but it's still a container, which means that you can still run that on CI. You can still make sure that those applications and configurations are still there even before you attempt to boot it. And then just in the standard run commands that you would do, like apt-get install your software, right? Then we have added some linters that allows you to make sure this is really a valid bootc container image, like bootc container lint, that will check and make sure that you have a kernel, the kernel is installed correctly, it's in the correct place in the file system, make sure that the permission of the applications are correct, that kind of stuff. So it's still Ubuntu. If you choose to use the Ubuntu, an Ubuntu-based bootc image, it's still Ubuntu. It's being built from the app repositories, and it's just a different way to install it. So if you are installing Ubuntu from a deb package system, I believe you guys have a tool called Ubuntu Image that allows you to customize those images. All the updates comes from packages. We're using apt-get. The distribution is you populate the Ubuntu archive, and they're general purpose, right? So you can run this in bare metal, VM, the cloud, and Edge. And I know you guys have Ubuntu Core, which does a lot of similar stuff as bootc in a different way. But in a deb package world, you are doing changes at runtime. It's not during the build time. In a bootc world, if you want to change an application, you don't do this in the runtime. You do it at build time. So we're shifting all your customizations into the build time. What do you use to create the image? You use container tools. So Docker, Podman, etc. The updates, every time there's an update, you can have a GitHub action, for example, that is running every day, updates that container image, make sure it has the latest kernel, it has the latest applications, gets pushed into a registry, and your users just run bootc update or have that into a timer, and they get the new versions. Once they reboot, they get the updates. And all the distribution happens in the same container registry that you already have. So this will be in GitHub container registries, Docker Hub, Quay, etc., etc. And also, we aim for bootc to be general purpose. Like I said, there's a lot of devices already using bootc and being deployed with bootc with different distributions. Automotive, bare metal, VMs, cloud. We have the Steam Deck running bootc systems. And again, the main difference here and the change of mindset that's really hard sometimes to embrace is that the changes, instead of happening in the runtime, we have to move them into the build time. Okay. So how does that look? You have an administrator that would do a Podman build, a Docker build. They have a Docker file similar to what I showed before. That Docker file should have an Ubuntu base image and all the instructions that they want to add, that being configurations, changing stuff in Etsy, or adding new software. And then, once they do Podman build, they get that custom image, which is a very standard process. From there, they push it to the container registry. And then they can select to do many things with that, right? Because it's a container, they can go into a CI testing pipeline. That's a testing pipeline. Will do Podman run, Docker run, make sure that the configuration that they expect to be there is there, the application that they expect to be there is there. Then we have tooling that we have developed to just create VMs from those container images. So there's a tool that is fairly recent called the bootc virtualization toolkit, BCVK, that you can do BCBK install and just pass the image, and it will automatically create a QEMU VM for you to quickly test and iterate in your CI. So you get to test as a container, and on top of that, you also get to test as VMs. So once you are ready, you're sure that it's passing your testing, it has everything that you expect, then you can install it. And how do we install it? So in the RPM world, we have tooling like Bootsy image builder that will create like an Anaconda-based installation methods. It will create AMIs for you and different types of artifacts to push into different clouds. But natively, Bootsy includes an install verb, which you just pass the container registry that you want. You're running that container as a rootful container, and it will mutate the system that you're running on and turn it into a Bootsy deployment. So you can start from a cloud-based Ubuntu system and run Bootsy install in that system, and suddenly it stops being package-based and becomes a Bootsy environment, which from there on is just managed by doing Bootsy updates or Bootsy rollbacks. So like I said before, we have many types of use cases that people already are using this for. Something very popular now is AI, you know. So we are able to ship the logical bound images, those LLM stack as container images, and it gets decoupled from the OS in the sense that they're different container images, but they're updated together. So you're able to update the host, and then pull the different container images that have the LLMs in the same operation of a Bootsy update. Something is wrong with that updated container for that LLM, you do Bootsy rollback, and you'll get the previous version of that LLM. You are able to deploy applications. You have an application that is just a web server, and you need special container stack or a special OS. You can define exactly what you want. You need a special agent. There's a lot of banks that need a special agent that needs to run in their infrastructure. You just install that in the container, build it, and deploy it to those hosts. Edge appliances, the same thing. We have technologies that allow for those updates to be minimal. If we have a tool called Shunka that allows you to split the layers of those containers into in a more intelligent way, that you can put the kernel is in its own layer, the configuration is its own layer. If what changes in those containers is just the configuration, what you get is just the layer that has those configurations, for example. So in edge appliances, you want to minimize the amount of network that you're pulling. So when you update those containers, you get the minimal amount from the network. You don't have to download the whole image. And where all this started was just having a host to run containers. You know, stuff like Kubernetes and Kubernetes distributions are famous for using immutable OSs. And this allows you to deploy an immutable OS and just define the minimal layer in the OS and just have container runtimes managing the applications on top for the application, for containerized applications. Okay, so like I said before, we are a CNCF sandbox project. Along with Bootsy, we also donated ComposeFS. ComposeFS supports DM Verity integrity on top of file systems. It is for OCI. It has integration for OCI, but it's also using many generic use cases. ComposeFS is really a composite or a mix of three well-tested Linux kernel technologies. One of them is OverlayFS, FS Verity, and AeroFS. For the demo that I'm going to show, we're going to use ComposeFS as the backend. If you have in the past tried any of the RPM-based distributions that use Bootsy, they might be using OS3. But this is something that is being stabilized, and we believe it's the future. This allows for secure computing. We can sign from the moment that do the build, sign that image, and make sure that there's integrity all the way until the booted system. And if anything touches that file system, the system will stop booting. So we make sure that no one can run code that you didn't intend to be running in those machines. Okay. So I'm going to just show something very basic here on GitHub. This is a very, very fun application. This is just installed as Apache 2, and this amazing HTTP server just say hello Ubuntu Summit. So this is just a standard container just to demonstrate what normally people would do, right? Like you would have a GitHub workflow that builds that and pushes it to a registry. So I have a job here that will just build that in CI every day, make sure there's updates, and I can locally go and build that. And the other fun part here is that as part of the same job, I am building another container file that is also being built, which is the host image. So this host image is a little bit more complex, but not too much. This one. It's starting from a base image that is already Bootsy enabled. We are making sure that we have all the directories that app needs, and we're installing Tmux. Then we're doing some fixes here to make Snap work. And finally, here I am enabling, in these last two steps, I am enabling logical bound images, which is that HTTP2 server. But before I can actually deploy this, I need to have a Bootsy system. So I'm going to go through that effort now. So I am just starting QEMU. It's just a standard cloud image. And this is 100% Ubuntu. There's no RPMs involved. Once this goes up, hopefully, we should be able to SSH into it. And we are there. So we should see here that this is really Ubuntu. I'm not lying. And we're in Resolute Raccoon. So this is your cloud image. To start this, I just took your cloud image, make sure I have my cloud init configuration, added my SSH keys, and just started a VM. So now the complexity is we do not have an official Ubuntu Bootsy image. So I had to create my own. I used this, as I said, the boot crew team, which is people in the community that decided to create these images. They had a starting point, so I used that as a starting point, and then created this container file, which is just a container file. I am using, you guys changed how you build your images to using Rockcraft, I think. And that ended up adding some additional packs, metadata into the tar layers that we didn't expect because we're not using that. And it triggered a bug in our code in ComposeFS that didn't let me complete this. So I went and just squash your image, and this is a very, very, again, very complex container file. It's just one line. And I just build it. It get with Podman to get away from the packs, the packs metadata in the tar layers. But this is a bug on our end. We have reported it, we have fixed it in ComposeFS, and it's on its way to the next bootc release. So hopefully, in the next time you try to do this, you will not need my squashed Resolute build. But for now, we do. So the thing I'm doing here in this container is just installing software. You can see that I am installing a bunch of dependencies. bootc still needs OS3 in order to build. And there's another bug that I needed to fix, which I'm trying to look, is right here. Which is, there was a regression in the latest kernel that broke part of AeroFS, ComposeFS, which means that I just need the previous Ubuntu version's kernel for now until that gets fixed upstream. But I'm just installing a kernel here. I'm making sure that it's installed in the place that bootc expects it to be. We're regenerating the init ramfs. We're enabling services. I'm installing Cloud Init. Configurations related to Cloud Init. But there's nothing special. There's nothing magical in this container file. If you have dealt with container files at some point, you have seen stuff like this. You have built something like this. You have shipped it. So this is just taking your image and making sure it has a kernel, it has that bootloader, and it has the init ramfs. So the other thing I did here is that I just added a GitHub workflow that builds it and pushes it to a package. So now I do have an Ubuntu bootc based image, which I can use to turn my package-based system into a bootc-based system. So I'm going to use this guide over here so everyone at home, if they want to follow through this, they can do this. It's kind of painful, I admit. This is not the intended way for this to happen, but there's certain difference from the RPM-based distributions and how Ubuntu is laid out, the default partition sizes, enabling Verity in the file system too. There's certain things that from the bootc side we need to do work, and if anyone is interested in helping making this more streamlined, we're taking contributions too. But it's possible today, and I'm going to show it, okay? So the first thing here is the first basically 10 steps is just creating those initial VM that has nothing to do with bootc, but this is a step-by-step guide all the way into connecting to that machine, which I already did. Then I'm going to pull that bootc image with a Podman pull. It's just a container again, so I can just do that inside my VM. So this VM has Podman, and this will pull my latest Ubuntu bootc image. And thankfully we have very good internet here because I thought I had pre-pulled this. So yeah, okay. So it's pulling. After we do that, we're going to just enable extension for Verity, so ComposeFS works, and then we need to mount boot. So these are two things that we should be doing at the bootc level that we should fix upstream. But it's quick commands like checking if the file system has Verity, if not, enable it, and then if we need we need to manage boot differently, just to mount it and deal with it ourselves. This is not something that is special, it's just Linux commands, right? So I'm going to go ahead and do that as soon as that downloads, and hopefully it's done. So that's there. That's there. So it's enabled. We have priority. Composer first should work. Someone yesterday told me that CFS is very important. I have not tested this with CFS, but it would be fun to test. But then after we have unmounted the boot and enabled Verity, this is the magical command. So if you can see, this is running Podman with sudo. It's running as a privileged container. It's giving the process ID of the host. And the rest of the stuff that is happening here, it's just mounting your target system or your host in different areas so the container can see it and mutate it. If you can see here, I'm mounting the rootfs as target. And the other thing I'm passing here is the container image and then bootc install. In this VM, there's no bootc. I did not install bootc. There's no special thing that I needed to do other than what is in the guide. And I'm going to copy this command, which will run bootc from the container image and hopefully install Ubuntu bootc into this VM. Should not take more than 1 minute. This is actually taking the contents from that container images, downloading it into the VM, which we did with the Podman pool, and then it's copying it into the rootfs, right? So it's copying it into the file system. Once we reboot, we will actually have the contents of that container be your slash in the system, right? So it will be the actual root of that system in the file system. There's a common misconception, which is maybe bootc is just a runtime and what comes from the image is running on top. That's not the case. It's a delivery mechanism. Okay, so we have done that. It's installed. Now, everything else is, again, stuff that we should fix, which if you follow along at home, you can also get your Ubuntu bootc system, and you just need to do this once. So we're basically working on fixing the bootloader, making sure that the bootloader is installed correctly. And should be a couple of commands more, which we'll fix. So right now it's installed and ready, but if I reboot, I will go back to the previous, to the Ubuntu that is deb-based. So what I'm doing here is making sure that the EFI partition is updated and the correct bootloader is selected when we reboot. Hopefully, I copied all the stuff in order and without mistakes. Now we pray to all the gods of the demos, and we do a sudo reboot and hope for the best. So that should be pretty quick because it's already in the system. There's nothing magical that should be happening that is happening in the background. So once it reboots, we should have an Ubuntu system. You can see already that it looks a little bit different. There's all kinds of warnings that the host identification has changed. And now if I do, is this really Ubuntu? Is this something else nefarious? Let's see. It's Ubuntu. If I run uname-a, we should see something weird because it's an older kernel release than what it should be in Resolute Raccoon, but it's coming from that container image that we built. So this is what we put in the image, this is what we get in the host. And now we have this command called bootc status, which shows me that this is actually using the image Ubuntu bootc coming from my repository. So now we are officially on a VM running Ubuntu deployed with bootc and managed with bootc. So what can I do with this? So someone was doing very important work and decided to create that beautiful, beautiful container file that has Apache 2 and says, hello, hello Ubuntu Summit. Let's make sure that this is not really running here. So if I just do a curl local host, there's no curl because I didn't install it. So I think this should be enough. Yeah, so it's saying connection refused. There's nothing being served in port 80 in localhost. So we're out of luck. So what do I do? Another cool thing is, something that I actually noticed yesterday. I have 10 minutes, so I'll try to be fast here. If I go to snap install LXD, it's going to try to do that because I installed snapped. Oh, well, it's broken. It's telling me that it's a read-only file system, which is expected in immutable systems. But we should fix that, right? Like if it's an Ubuntu system that cannot run snaps, it's kind of strange, right? So let's try to fix that. So what I'm going to do here is I'm going to go into my packages. So there's a new image right here. And hopefully we'll have time for this. And I'm going to do a magical command called sudo bootc switch. So this is how we change the definition of the container that we're tracking. So instead of tracking the other image, now this is the one that I'm going to track. When I say track is, if that gets updated, what I do is I just do bootc update, and I get the new updates. You can see that I already had most of the layers, so it's just downloading something real quick, hopefully. And it's downloading also that other image that had Apache, and it's making a deployment for me. And hopefully it finishes, okay? So if I go now and do bootc status, I'll see that I have two images. I have the original one that I deployed, and then I have a new one that is a staged deployment. If I just reboot, I lose my staged. If I just reboot, I'll switch to the staged deployment. However, if I lose power, we don't finish the deployment. So you still have the last known good deployment working if I would lose power now and the machine turns off. But and I would just need to restage it. So now since it's restaged, I'm going to just do a reboot, and hopefully all our problems will be fixed. I'm saving energy, and it's a little bit slower, but it's coming. There it is. So what happens if I do bootc status? What will happen? I have to write bootc correctly. Now the booted image is the one that I passed the bootc switch, and that means that thanks to the power of Claude Code, all the snap problems should be fixed now. So let's do snap install XD. Getting farther, right? And it's installed. So now we have proper Ubuntu with snaps, right? Okay, so one other thing that I did in my from that other GitHub repo is that we should have a container running. and it should be serving Apache 2. So no, it's not curl. So we do wget local host. Oh no. And 80. And now we have a serve HTML that comes from that running container. So we just did Bootsy update, Bootsy switch and from another image, and we got another OS definition that fixed a bug and deployed an application container. So you can imagine having an IT department that wants specific software in all the hosts of the employees, for example. You can define that with a container image. Make sure that it has everything that you need to be compliant, to be secure, sign it, and then deploy it into your systems, either with Bootsy installed directly, or you could imagine someone creating an Ubuntu-based installer that looks very similar to what you guys have for dep packages. And I think that's mostly my time. I have a couple more slides, I think, which I think we already saw the demo, which is a good thing. That's not what we want. We have this package called System Reinstall Bootsy, which aims to do everything that I just did with a lot of copy and pasting, but very, very simple. You would do System Reinstall Bootsy and pass the image definition, and it will guide you through the steps. The problem is that now it's mainly focused on RPM-based distributions. We need to update that, fix it, make it more general to include the Ubuntu case. But it basically looks like System Reinstall Bootsy and your container, and it will do exactly what we showed. So you can have an image, an Ubuntu system running on DigitalOcean, for example, or AWS, and turn it into a Bootsy Ubuntu system. There's some links. Connect with us. We are, again, part of the CNCF. So there's a Slack channel for Bootsy. In the CNCF Slack, we have our main GitHub repository, which is mostly Rust. And yeah, the demo, it's, well, I showed a couple of GitHub repositories. I'll make sure to update the slides and pass it along so everyone can get to those. Yeah, we have like 4 minutes for questions. I don't know if there's any.
Thank you very much. Can we have a round of applause for Joseph, please? Okay. We have some questions for you from the chat. So Elpil's asked, well, he says, you mentioned that Bootsy is used by graphical systems such as the Steam Deck and Bazite. Would Bootsy be practical for configuring personal computers? For example, a laptop and a desktop with my desired packages and configurations, or a home server?
Yeah, so this machine that I'm using right now with GNOME, it's fully deployed with a Bootsy process. So I have a GitHub action that runs every night. Make sure that I have the latest some RPM-based distribution. It has all my configuration, all my VPN stuff that I need for work, etc., etc. And when I feel like, I just run Bootsy update and I get the latest updates and reboot it. This really, when I started using Linux, one of the cool things was like modifying Linux how you want it, right? And a lot of people wanted their own way to create your own distribution. This basically enables that, right? You can use it for your personal machine, for your server, for your home labs, and you can define everything in a container image, and you have basically your own bespoke Ubuntu image.
And another question is Bootsy suitable for running a minimal host for running containers, similarly to what you can achieve with, for example, Fedora Core OS?
So right now, Fedora Core OS is based on Bootsy. So if you're running Fedora Core OS, you're using a Bootsy system. But because we are aiming to be general purpose and distribution agnostic, it means that you can build something like Fedora CoreOS based on Ubuntu and do the same kind of work, right? A very minimal Ubuntu that just have a container runtime and it runs those workloads.
And I think you mentioned this, but one of the biggest anxieties with OS updates can be a failed boot. And I think you mentioned rollbacks as an option. Are they automatic with bootc?
They're not automatic at the moment. So we do have other tools in the ecosystem that will plug in, and if the boot counter looks bad, it will automatically trigger that bootc rollback for you. But every deployment is an entry into the bootloader. So you can just select the previous entry in the bootloader and you'll get there.
And are you able to share anything that might be on the bootc roadmap for the future?
So stuff that we are working on, we're trying to stabilize ComposeFS feature sets and make sure that it's a first-class citizen and hopefully make it default in the near future. Right now, a lot of the distributions are using OS3 as the backend. Which enables, once we have ComposeFS, enables secure computing, signing, and stuff that we're all asking for at this point, right? We want to make sure that we can know that the provenance of the software that we're running on our machines. Another thing that is a part of our roadmap is trying to figure out a way to make the kernel updates and CV updates more seamless without needing a reboot for everything. We did implement soft reboots in the last release, in a couple releases back, so you don't need to go all the way down to the bootloader, but that's only if there's no kernel updates. But yeah, those are basically part of our roadmaps there.
Thank you very much, Joseph. It's been a pleasure to have you.
Thank you so much.
Okay. Next up, we are welcoming someone from Canonical to the stage, Marcin Konowalczyk. Now, interestingly, by training, he is a chemist, but by passion, he is a software engineer, and that's what he'll be talking to you about today. So it's time to go under the hood of the Rust toolchain to show how Canonical builds highly secure, ultra-minimal container images. So please welcome to the stage, Marcin.
Hello. Oh, thank you. There we go. Awesome. So here is a first title slide. Here is a second title slide. Yep, I'm Martin. You can find me places at LCZYK, which is, by the way, the last 5 letters of my surname. That's how it came about. And yeah, I work for Canonical. I work at the Rocks team. And I've been, by the way, talking to some people about the talk, and I think I found a cool way to maybe give you a intro to like what's gonna be in it. If you think about minimal Rust rocks, it's gonna be a lot of minimal. The Rust is gonna be the subject of the matter, and then rocks is like the middle one. That's right. That's roughly the kind of priorities here. Briefly about me. Canonical has recently expanded into producing cat beds. You can see this is my Canonical bag that has been repurposed very strongly by my cat overlords. I used to be a chemist. I don't know whether one ever stopped being a chemist. I don't know. But I work with lots of interesting stuff. Last time I've done a talk here, and I've shown you the About Me slide. I showed you some. What did I show you? I think last time I showed you some arsenic. This is uranyl acetate. Salt of uranium. Uranium has really cool chemistry, by the way. It's completely overshadowed by all the bomb stuff. I did not work on bombs. Also, it's very poisonous. By the way, fun fact: we actually have a metabolic pathway for metabolizing uranium. We do not have one for plutonium because plutonium is so rare, and therefore plutonium is actually incredibly poisonous. People don't tend to die from the poisonous bit of the plutonium. The radiation bit is the one that gets them first. Anyway, that is the fun fact aside. Rocks. As I said, I've given a talk on rocks already, so this is going to be a quick recap. I'm going to concentrate on chisel, as you can tell by the gratuitous use of emoji. What are rocks? Rocks are Canonical's flavor of OCI-compliant images. They are Ubuntu-based. They are built with Rockcraft. We use Spread for testing. We have Pebble as the entry point, and we use Chisel, which I'll talk about more in a second. All of that kind of comes together to create what a rock is. And actually, you know, I'm sure all, if not most, if not all maybe, of you have already run the 2604 Ubuntu latest. And yeah, you've been running a rock, thanks to my good friend and colleague James. If you actually look in the root directory, there's a .rock directory. You can tell in the, you know, run this, it's a rock. And yeah, the thing I'm going to be talking about, or that I'm going to focus in this talk, is going to be Chisel, which is a tool that we developed at Canonical for creating slices of debs. So, okay, well, what is Chisel? This is roughly how you use it, and then let's be a little bit more interactive. There we go. I'm going to install Chisel. And just show you briefly how it works. Right, so we snap install Chisel. We're gonna make a new directory. I'm a little bit at the mercy of my past self recording this. This took so many times to record. In hindsight, by the way, maybe I should have chosen a slightly less moving background with the letters, but anyway. Yeah, this is the command, chisel cut. We choose a directory. We say what release of Ubuntu. And in this case, we're going to install a Rust C slice. How do you know it's a slice? Well, debs cannot have underscores in them, right? So we have a deb name, underscore, slice name. In this case, it's just the Rust C compiler. And we're going to talk more about what that is. Okay, well, we have some stuff in the rootfs. And in fact, we have only the things that we need to run the Rust C binary. So, okay, help works. Let's actually do something to kind of prove a little bit more that it does actually work. So here we go, just to prove that this is actually for this summit as opposed to a generic video. And ta-da, same text. So this is Chisel, right? And Chisel is really cool. It allows you to really kind of look into the, like, debs are convenient, but also they package a lot of things with them. But Chisel actually allows you to kind of look a little bit more into it and like really kind of pull out what you want. So this is just an example. The connectivity here is real, by the way, but this is just like a little bit of the different dependencies. If you were to go and install binutils, let's say you're on x86, binutils would pull in as a required package binutils at x86 Linux GNU, which would pull in libbinutils and libc. It would pull in all of this stuff and more. Why? Well, you know, you've got the assembler, you've got the linker, you've got the archiver, cool. And then you've got a bunch of other profiling stuff. So for example, you know, when you just install binutils, you're gonna get gprofng, which pulls in its own library. You're also gonna get libstd C++, which also has a bunch of Python scripts in it. Like, I'm not saying that all of those things are bad. It's really convenient to just be able to say, okay, install the thing, let's go. But maybe what you want to do, and spoilers, that's actually what I will want to do in this talk, is you know, to run the Rust compiler. Turns out you actually just need the assembler, linker, and the archiver, kind of. We don't need all the other stuff. So with Chisel, and this is actually what we have in the Chisel repository. So we have Chisel releases repository, which hosts the slice definition files. So it hosts the files which define what are like what is for example the assembler slice and how it connects to everything else. So you can then install only one of those and only get a subpath through this graph. All right, at this point, I should actually tell you what's the secret title of this talk. I was going to initially submit it as just crab emoji, sushi emoji, aka crab sushi, because we're going to be talking about slicing Rust, right? But then I thought maybe I thought better against submitting a talk with just emoji as a title, but maybe I should have. I don't know. So okay, this is the slice definition file for Rust. I apologize, I have chosen the wrong version of Rust. This is not the version of Rust that's in 2604. It will be the one that's in 2604 in later slides. I've been told I shouldn't draw attention to it, so pretend you didn't see it. Okay, so this is Rust C 1.84. Well, what's in it? That's the entire file, right? What's in it? Well, we always include copyright. Important to keep that always. And then the Rust C slice is, okay, well, we've got a bunch of libs. We've kind of seen that already. We're going to go deeper into libstd Rust in a second. Base files, sure, blah, 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 blah. Okay, all of that seems pretty straightforward. By the way, this is exactly what got installed in that demo, right? Okay, what's in libstd C++? Oh, it's a bunch of, it's a couple of SOs. Well, okay, that's easy, right? You know, we've got some binaries, some SOs. Great, let's put it all together. Well, not quite. It turns out that when you do just that, the Rust will complain aggressively at you, because just because there is a dependency in a deb doesn't necessarily mean that the debs will pull in everything that they need to run, but if you just look at the files themselves, they might not tell you the whole story. So, okay, do you remember that binutils graph that I had like 3 slides ago? We're going to start with the same thing. It's binutils, right? With a bunch of dependencies. And we're going to actually, I wonder whether I could pause this. Could I pause the video? Maybe not. Okay. Anyway, the central nodes are debs. The little orbiting nodes are the slices. So I'm actually going to switch to a slice view in a second here. You can see, you don't need to read the text. It's a bunch of libs and a bunch of non-libs. They're currently colored by their section in the debs. Hopefully it will switch to, again, I'm at the mercy of my past self who has recorded demos at speed. There we go. The linkages show you the dependency between slices. And you can see actually if we follow the slices, there is a lot, like everything depends on libc, right? Libc is here. But a bunch of other libs that we never really touch, right? You're seeing the same thing that you've seen there. This is GCC, right? It's like a super graph of that. You still see binutils here. GCC depends on binutils. But we now have a little bit more nodes, a little bit more libs. I should switch to Rust in a moment. There we go. GCC is a dependency of Rust, right? You actually need GCC to run Rust, asterisk. I'll tell you more about in a second. And finally, you know, Rust by itself is actually quite hard to run. You kind of need cargo. That's cargo. This is big and messy, right? This is how to get your head around, and you need all of that in some way, shape, or form. This is all you install when you actually install cargo deb. But it's not. But like you know, you don't actually need all of it exactly. And if you want to create like really nice string container, I have a screenshot here. If you want to create a nice string container, you really want to kind of you really want to trace path through this very, very, very carefully. Yeah, what's gonna happen? Well, I mean, we put all of this. Well, not all of this. We put only the chiseled version in the Docker container, and that is actually our Ubuntu Rust container, that is really nicely trimmed. However, I think this is a correct container to give to our clients. But there's always a balance. And I don't mean to imply that they're counter to one another. Because, you know, for example, what we include in the container is a shell. You kind of really like shell in an SDK container. But we could not include the shell in the container. It would be really hard for anyone to use the container, but you absolutely can. So we pick we pick the kind of correct place to be on that scale. But well, okay, how far can we get? And that's why there's the fun ... there. How far can we get if we like really try to just kind of chop everything we can out of the Rust container? But it's still a Rust container. Like we can still use it meaningfully, and not just for like you know -- hello with the Rust compiler, because you know -- hello. You've seen that earlier. That's true. That's simple. Okay, well, what's in the Rust container? We have so the code in the background, that's the slice definition files. We have Rust. We have Rust C. That stays the actual Rust compiler. As you've seen from the graph earlier, we have cargo. As you've seen from the graph earlier, we have GCC and friends. We also have apt, right? Because you know you're installing a project and it needs you know lib pam0g, and where is it? well, you kind of want to do apt install libpam0gdev. Well, okay, let's at this point try to kind of, so this is where the official canonical image finishes, and this is where the kind of going more and more into trimming things down begins. Number one, just get rid of apt, right? Like anything else you need, you gotta mount the volume yourself, right? You gotta bring it in from outside of the container. Harder to use, but all of a sudden, all of that goes. GCC. Well, let's put a pin in this one. We kind of need it, although in case I end up running out of time, here's a spoiler. Cargo. Well, why? Like, what has cargo ever done for us, right? Like, you know, except for the build system and the environment variables and resolving dependencies and downloading dependencies and okay, cargo has done a lot for us, I guess. But let's try to get rid of it anyway. What cargo can, and you actually, alas, it cannot do it anymore. But ask me later how to work around that. What cargo can do is it has the -- build plan flag. So what -- build plan does is it looks at your project and it says, well, this is what I would do, and this is what I would do, and then this is what, and you get this massive JSON file that tells you how cargo would compile your project, where you to actually tell it to compile it, but it doesn't actually compile it. Well, let's dump that to a JSON file. Well, let's dump that to a file, and then let's kind of split the world into 2 stages. Stage number 1 is we're going to make the build plan. Then we're going to tamper with the build plan such that we can, you'll see later. Then we create an environment where we mount all our dependencies. We put that build plan in there, and then we go into that environment, and then, okay, run the C compiler, like run the C compiler ourselves. Easy. It turns out the build plan is like really big and complicated, so you kind of want some scripting. In this case, I know it's a Rust doc, but we have Python scripting, and this is as I've learned to call it artisanal. Yeah, you know, at the end of the day, we're just running the C compiler. This is a glorified big bash script. It's a little bit more complicated because there's like build.rs and you have to resolve that, etc. It's not too hard to just hack your way through it. Honestly, it's actually very nice and readable. I've done this by just trying to run it. Where does it fail? Oh, okay, that's a special case. Easy error messages. Yeah, you can compile sudo with it. It's kind of fun. So this is actually there'll be a link to a repo at the end, and yeah, you can run the demo, and at the end sudo who am I, you get root. This works. Actually, sudo is actually quite easy to compile, by the way, because it really doesn't have that many dependencies. It does compile a bunch of other stuff. But okay, Python script, right? Like no. Fine. Let's also, Python is annoying because you kind of have to have the runtime for it. You kind of have to drop it into the container as well, which means you need to static compile it. Let's switch to a real language. Let's write in Golang. And in case any of you complain that I actually have a PR ready, I can press go and it's merged for a Rust version as well. Yeah, let's write the same thing in Golang. In fact, the slide before was running in Golang, so it also works. Then since this is minimal Rustrocks, then there's also a container for it. So I'm gonna quickly go to the next. I'm actually gonna go back in a second. This is a slide. This is the last slide, but I'll talk for a little bit more. You can find the not quite cargo at GitHub. Not quite cargo. It's not doing any of cargo's lifting except for here's the build plan that I can just run for you one command at a time, and it's trying to deal with a bunch of cargo weirdness. That is packaged into a rock. Now in this rock, of course, we don't have cargo, but as I said earlier, spoilers, we also don't have GCC. What do we need GCC for? Well, Rust doesn't actually call the C compiler unless, of course, it's in a build.rs. Well, if build.rs can have anything in it. So whenever I say build.rs, you think curl to bash. But yeah, so we don't have GCC. Why does Rust need GCC? Because Rust calls the linker to the GCC. So actually, the link that I had earlier is to a project called Wild, which is a linker written de novo completely in Rust. And this works all on AMD and ARM. And so I've replaced the linker. It turns out you kind of need to do a little bit more because Rust thinks that it's driving a linker like a GNU linker. And so you kind of need like a bit of a shim between it, which is like, yes, Rust, you're you're definitely driving the right linker. Okay, fine, ignore this flag, ignore this flag, ignore this flag, right? But it's just a thin shim. And actually, I've implemented that shim also in MQC, such that you can you have just that one binary that you drop into a container, and you can now do this kind of compilation. Yeah, I also let me grab a list of things. At the very least, I encourage you to go to the MQC repository and have a look at the examples, because I think they're quite fun. We can compile sudo fd, which is like a find, eza, which is like ls. We actually compile cargo with cargo, and then recompile cargo with cargo, just to prove that the compiled cargo works. It gets better. We compile core utils. And the Rust version that I haven't pulled the trigger on the PR yet, but I can in a moment. Well, now the not quite cargo -rs can start trying to compile itself, which means there is an example there which works. It's all make files. You can literally just make it will do the thing, which compiles the cargo driver, which compiles MQC Rust version recursively in itself, so in a way it's kind of self-hosting. I don't know. It's a very fun example. Like, look at it and yeah, tell me what you think. And finally, this was all. If you think of that, if you think back to that slide with the scales, right? This was all done for the sake of fun, but I think that there is a bunch of interesting things to be gotten out of that. First of all, security. You do know exactly what you're compiling. You know exactly what the environment is. Every single demo runs in no-network container, right? You have supplied it exact packages and said install using this code, and that's exactly what happened. And you can be sure of that to quite a high degree. Yeah, I think it's an interesting way of doing things. I think it also of course, it makes for very small containers. So if you look at the official Rust image is about 600 megabytes. The canonical Rust image is 300 megabytes because of the chiseling. You can get this down to about 70 megabytes for not the entire Rust toolchain, clearly, but for a Rust toolchain that can compile big, serious projects. Yeah, that is roughly the talk. If you found this fun, then this is kind of, not specifically the Rust stuff, but the container stuff is very much what I do at work. And this is a job posting that kind of goes in that direction. And if you're in general just interested in working at Canonical, then just drop the numbers and you've got our job postings there as well. I'm unsure whether I might have swapped the QR codes around, so just in case, look at both. This is definitely not a way of making you go to my GitHub, but go there anyway. Right, that is me. Thank you very much.
Thank you very much, Marcin. A couple of questions for you, if you don't mind. So, when you're trying to build the absolute most minimal container runtime for Rust, what's usually the hardest thing to strip out?
The thing that I didn't tell you about at all here, which is LLVM. If you look at the final image that's available at Not Quite Rust Rock at the moment is 150 megabytes, actually. It's not 70. And if you look at what's the biggest file there, it's libllvm.so. And the reason is because Rust uses that as a backend. But then if you go into this kind of like Wild West world of alternative Rust backends, then there is something called CraneLift from people at Bytecode Alliance. And it's a written in Rust backend for Rust. So, from Rust IR to back to bytecode, or sorry, back to machine code. And so I've compiled the version of Rust with that and dropped that in the container. That also works. Yeah.
Excellent. And you tease in your abstract a look into what lies beyond hardened Rust images. So what's the next frontier for secure runtime environments, and does it go below 70 megabytes?
So I don't know whether it's about size, right? Like the size thing is fun, right? And I think it makes you look at interesting bits. But I think the main, like regarding security, I think the main thing is what do you actually include there, and you know, for you to include all the things that you want, and I think go beyond Bash, go beyond not just including Bash. I don't know whether it makes sense in the like big official images to, for example, not include cargo, but I think it makes sense for people to start looking more at these kind of approaches, and you know, whether that's in Rust, whether that's in other cases. So yeah,
Fantastic, thank you. It's been a pleasure to have you here.
Right.
Please, a round of applause
Thank
for
you
Machine.
very
Right, for those who are joining us remotely, we'll be taking a break, but later on in the day, we will be hearing from a few interesting speakers. We have a talk on RISC-V from SpaceMint, a talk on AI from Arduino. We'll also be hearing about the small but mighty programming language Gleam, and we will also be hearing more about workshops. So if you enjoyed Mark's opener, you won't want to miss that. But for now, all of you at home, we will be having a pre-recorded talk. We'll be hearing again from Nariman Jelve, and he will be sharing concrete, battle-tested strategies on how to take an open source project from zero to a massive thriving community. And in the world of open source, there perhaps isn't something as important as that. So we'll be live again soon. Stay tuned. Thank you.
Hi, everyone. My name is Naiman, and I'm the founder of Pewter, the open source internet computer. And in this talk, I'm hoping to show you how to successfully launch and scale an open source project. But before we dive deep into it, let me tell you a little more about myself and Pewter. So I've been programming for 30 years, wrote the first line of code when I was 7, and professionally since 17. I studied computer science at the University of British Columbia in Vancouver, Canada, and I worked at a number of local companies writing code. But towards the end of my studies, I started my first company focused on large-scale web data extraction. I'm mostly interested in web and distributed systems. This is the common theme in my career, and which has also led me to my work on Pewter in 2021. First as a hobby/side project, and then full-time a couple years later. I've done a number of other open source projects, such as Pewter.js, which is a very popular SDK for Pewter, KV.js, which is in-process caching module for Node.js. It's a mouthful for a very simple Redis clone in JavaScript. Oops.js for undo-redo management in applications, you know, just Control-Z, Control-Y, things like that. It's more complicated than it sounds, so I needed a module for it. And PHP-Wark, which is a module for reading WARC files, web archive files, which is used in massive scale web crawling. This talk is about Pewter, though, because that's my most successful open source project. So what is Pewter? Well, in short, Pewter gives every user a computer on the internet. So if you go to pewter.com, which is the hosted version of our open source project, create an account, you are immediately given a virtual computer in the cloud. You have a certain amount of storage, some database, some other types of resources that you can use to store files in, interact with your files, and do a number of other stuff. The immediate question on everybody's mind when they see Pewter or they hear about it is that, what is it even used for? Well, just like any other computer or quote-unquote operating system, I'm going to get into trouble for saying that, but just like any other computer or operating system, Pewter is pretty general purpose. You can use it for anything. A lot of users use it to store files. In other words, as an alternative to Dropbox, Google Drive, OneDrive. You put your files in your Pewter account and you immediately have access to them from anywhere at any time. In fact, if you have a device that can run a browser, you can access your files. So a really interesting alternative to Dropbox at all, with a very fresh UI, which looks like a desktop environment. We have a lot of apps. So you put your files in there, can interact with them with a lot of different applications. We have spreadsheet software, we have a word processor, we have presentation software, we have music editor, audio editor, video editor, photo editor, all sorts of productivity software, but not just limited to that. We also have a lot of games, puzzle games, adventure games, action games. A lot of people just come to Pewter to play games. Whatever floats your boat, you can find it on Pewter. But another unique aspect of Pewter is that by the virtue of being a cloud native operating system, it also makes it incredibly easy to publish websites and build applications on top of it. Basically, as you can see in the screenshot, you have a directory, you can right click on it and publish it as a website or deploy it as an app. There's no other account you need, you don't know any other infrastructure, it's just there. Your file system is in the cloud. Anyway, but I would say the most important aspect of Pewter for this talk is the fact that it's a pretty large open source project. Pewter was open sourced in March 2024, and very quickly it became one of the fastest growing commercial open source projects of the year. We were topping all the charts when it comes to open source, and in the past 2 years, we've accumulated 41,000 GitHub stars, more than 400,000 downloads, and 370 contributors. We also have a few thousand forks under our belt. So I'm hoping that the story of how we ended up open sourcing Pewter and how we scale it to what it is right now could be helpful for others who are thinking about the same thing. So I've broken down the talk into 4 sections. The why. Why would you want to open source a project anyway? Pre-launch. What you would need to do before launching your project or open sourcing your project to maximize your odds of success. Launch. What do you do on launch day? Where do you put your project? How do you distribute it? Post-launch, what happens behind the scenes when your project took off and you got a lot of attention? How can you keep the momentum going? So on and so forth. So let's get into the why. So I'm just going to tell you a story of how we ended up open sourcing Pewter. And I think a lot of the reasons for us might apply to a lot of other projects as well. Now, reasons vary depending on who's open sourcing a project, what project they're open sourcing, what the goals are, the end goals are. Sometimes you're not even doing it for community aspects. Sometimes it's because you want to, as they say, commoditize the competition, which is a very common reason larger companies open source projects. So there are different reasons, but I'm guessing a lot of people are interested to know why a small project by a startup would do such thing. Now, Pewter was not open source in the beginning. For the first, I would say, 3 years, it was closed source. I first publicly launched it on Reddit in 2022. It went pretty viral. It got hundreds of thousands of impressions, hundreds of comments, messages, emails. And what I noticed when I was triaging the comments and feedback is that a lot of people, maybe the #1 request was open sourcing Pewter. And well, I did notice it, but I didn't immediately open source it because I needed better reasons for it, especially having investors. You want to have a really good business aspect as well when you're making such a decision. So a few months later, I ended up meeting the founder of N8N, which is a really massive open core workflow automation platform. And he told me that, hey, you're an operating system, you have to open source it. And he referred me to another person who's an expert at open source by the name of Heather Meeker. And then she gave me the real reasons of why you should open source your project, especially with something like Pewter, which is branded as an operating system. So the first thing is that for us, one of the biggest reasonings behind it is that when you open source your project, you're basically front loading the cost of marketing to developers. What that means is that you're exchanging the source code for brand equity with developers almost overnight. If you're lucky enough to get a lot of attention at your launch, this is something you will notice. You will immediately get a lot of love from developers. This was especially important for us because we are a developer-first platform. Even though you see a desktop environment, what we really focused on is actually developers. So we had a lot of problems marketing to developers beyond just impressing them with the desktop environment. And I think open sourcing Pewter almost immediately erased that problem overnight. You also build trust with users for the same reason, because if the source code, even if the user doesn't read the source code, just the source code being out there under proper license builds a lot of trust with end users. Now, it doesn't really work with open sourcing doesn't really work with every type of project, but it tends to do well with infrastructure and dev tools. There are different reasons for this, but I would say some of it is because the people who contribute to it are most likely the users of it as well. So they can, and it solves an immediate problem for the target audience of that project. So it does great with infra and dev tools, but for example, it doesn't do really well with, for example, the classic example is games. I'm not sure I've heard of a successful open source game yet. Now, it does work incredibly well for operating systems, but the nature of being hyper horizontal and being able to adapt to pretty much every single use case under the sun and wanting to build a standard or an app ecosystem around your platform, operating systems have an incredible opportunity when it comes to open source. The biggest example would be Linux, obviously. There are other reasons, but those are, at least to me, secondary. For example, getting contributors. Who doesn't want free software engineers? But the reality of it is, unless you are a big project, having network effects when it comes to getting contributors, or you're really good at hunting down contributors, in my experience, projects don't really get free contributions. So that I don't think is the best goal, and it's not very realistic. And another reason for it, in terms of business, is that especially for infrastructure, when companies want to rely on your piece of software, is that, hey, at least I'll have the source code if they go out of business. So even though there are, in a lot of enterprise contracts, there are checks and balances for this, but at least you want to have an official open source version of your infrastructure so that you give a little bit of peace of mind to people who want to build businesses on top of your offering. And being open source is a great way to do that. Now, so if you've decided to open source your project, you need a pre-launch plan. I really believe in this. I don't think you should just jump into it and put it out there. There are a few stuff you probably have to take care of before you put your code on GitHub and make it public. First thing is that make sure the product appeals to developers, because most of people who are going to be contributing to you or carrying the torch when it comes to open source are developers. There are early adopters, there are self-hosters, but I would say developers are the #1 audience. So being useful or interesting, you don't even have to be useful. I think if you're interesting, that also works. Being useful or interesting to developers would help you a lot. That's a different way of saying makes, if you've heard of it, make something people want, but in this case, you want to make something that developers want. And polish the product. Some people say it's great to put an unfinished product in open source. That's fine, but I think at least when it comes to demo or the first look, it would be great if you have a polished product that clearly shows what's happening. So I'm all for polishing the product before open sourcing it. But people have different methods when it comes to this. Some people intentionally don't polish the product because they want to get others to help them polish it and set the direction. But to me, if you have the vision of what you're doing, polishing the product is a pretty good bet. it would be great if you have a hosted or a demo version. So even though you usually cannot have a demo version on the GitHub README itself, like if you go to the repo, you can't really play around with the code right there and then with the software or the package or the code itself. But it would be great, if possible, if you're doing a type of product that can be hosted and demoed, it would be great if you have one, and then later on you can link to it. This would help them, help your target audience to play around with the product before they dive deeper into the open source. Create a dedicated website for your project. It's always good. I mean, I personally, whenever I see a library, a package, any open source project that has a dedicated website for the open source, I love it. And I think a lot of developers feel that way as well. So if you can create a dedicated website for your project, that would be great. Right now with AI, it's much easier. Before, you had to know how to design websites. If you're doing a C package, you're not necessarily good at web design, but these days you can just use Claude Design and put together an incredibly good looking website with all the information in it within minutes. So I would say having a dedicated website is table stakes at this point. Yeah. So once you have this stuff, the hosted side and the quality and everything under control, you need to think about the code. I do not recommend you just open source a project like that. I think you should go through the code, maybe even create a new repository. Either create a new repository and copy your code in there, or clean up your commit history. We all do mistakes. We all make mistakes when it comes to committing. Sometimes credentials, very, very common. There's been a lot of research done on this. You're likely to leak your credentials, especially when you're solo developing a project. So either create a new repository and copy everything in there, or clean up your commit history and make sure you're not leaking anything. Maybe your future plans, maybe you're, I don't know, using bad language, or more importantly, security issues and credentials. Then you need to pick a license. Picking a license is very important in that, first of all, it sets the tone of how this project can be extended in the future. So this is one of those things that you might actually have to think through carefully, because there are a handful of open source licenses, and they all have their own peculiarities. So you want to make sure you know what you're getting into. Some licenses you can go from more strict to less strict. You can move on up and down the level of restriction in the licenses, but sometimes you can't go up. So there are one-way door sort of decisions when it comes to licenses. So it's a good idea to actually sit down and think about it. One recommendation I have, obviously you should talk to a lawyer and not blame me later on, but one recommendation I have for you is that pick a license that is popular or well-known. Creating a custom license or ChatGPTing a new license, these are typically recipe for, I wouldn't say disaster, it might be disaster, but this could seriously hinder the adoption of your project. Just think about it. If somebody puts an MIT project in front of you, you're not going to think twice about using it. But if somebody puts a UBC, a UBC license in front of you, you're not going to, it's likely you're going to talk to a lawyer, or there's going to be a lot of thinking happening before you adopt that piece of code. Now, this is way worse at larger companies, because so these licenses are well understood, and the moment you deviate from them, you're going to end up having to go through multiple hoops to get your project in the door. So why open source if you want to go with a self-made license? It pretty much hinders your distribution, the distribution advantage that you have, very, very massively. Now, you also have to, you pick your license, you also have to audit your own licenses, see what libraries you use, packages, icons, assets, anything. You want to make sure that all these licenses are compatible, you're doing the attribution right, you gave credit to the right people, to the right entities. So you want to make sure you do this. Legal stuff aside, this is open source. You want to be you want to be mindful of other people's licenses and open source projects. One thing I really do recommend is doing a security audit, especially if you already have users or you have a hosted version of your product. Do a full security audit of your code before you put it out. You can hire security companies, but recently AI has been incredible at finding security issues in code bases. So you can just run Claude Code and ask it to look into the security issues, make no mistakes, be very thorough. Or if you can get your hands on the more advanced model like Mythos, the one that some companies have access to, it would be great. I've heard good things about it. I don't have access to it, but even with Claude Code and Codex and these AI agents, we've had pretty good results. When we open sourced, this wasn't the case. We actually had to hire a security company to audit our code. It was a whole thing. It actually took a lot of time. That's for security. Another thing that I've never seen this anywhere, but this I think is a very important point, is that you should think about an extension system. Now, what does that mean? In this context, extension system means that a method, a system whereby you can basically extend your open source project with proprietary code. For example, with Pewter, we have the open source project and we have the hosted project, which is a commercial version of Pewter. Now, there are a little bit of difference between the open source project and the closed source one, the hosted one. So there's some proprietary code that gets mounted on top of the open source that we use in production. Now, extension system, if you have a hosted version or a commercial version of your open source project, I strongly recommend you do this, because if you don't, having an open source project and a hosted version feels like building two completely separate products. It's incredibly painful. It takes a long time to develop the tooling, and it's going to cause a lot of issues because of the differences between environments and the requirements and end user expectations. So the extension system, I would recommend, in case you have a hosted version of your open source project, I strongly recommend you design an extension system for your open source project so that others can extend it, mainly yourself in the beginning. I wish I knew this. This would have saved us so much time. I think months of suffering, bugs, outages, and things like that. I have another talk about the extension system of Pewter where I go deeper into the Pewter architecture. I'm going to talk about how the extension system works, but basically one of our biggest inspirations was WordPress. So if you can look into WordPress as an extension system, or even Pewter, you could learn a lot about how you could implement an easy one. So once your code is ready, you also want to make your repo attractive. There is some housekeeping when it comes to your repository so that it looks good, professional, and it is actually good and professional. So one really low-hanging fruit would be about section for your repository. Just the right-hand sidebar on your GitHub repo. Fill it in with your project description, add a link to your project website or the hosted version or the demo, add a bunch of tags. Don't be as spammy as I am. I think this is too many. I should remove some of them, but add relevant tags. They do help bring in traffic into your repository. And then the rest, what you see there, README, license, everything, those are actually filled in automatically from your README and your project. So once you have that about section, the most important part of your repository is actually README. And that was a low-hanging fruit, the about section, and then you have the README. Design a user-friendly README. I would say don't vibe code your README. Actually, it should come from the mouth of the creator, how you explain what your project is, how you would want end users to perceive it. Design it very nice, have an icon, put it at the top, add some helpful links. You want to have a link to the demo, to community and support links, your Discord, your Twitter, X, your Reddit, email address, anything you might think that your community would find helpful. So you want your README. The README discussion is pretty long and it's very project specific, but you want it to be well designed and show what the project is within a few seconds. So that's why you want to have the icon. You want, ideally, if possible, have a screenshot. Have a screenshot of your, if it's an end user application or an application with a GUI or any sort of demo to it, add a screenshot to it. Add a screenshot right at the top so that people can immediately see what they're getting into. Add a short description after, and then I would say tell users how to install or clone or get started in developer environment with your project. Keep it very, very simple. Don't go on and on talking about the project. I know you find it enticing to talk about it all the time, but in my experience, users just want to understand what it is very quickly and get it started. You need a number of repo files. So README is the most important one, I would say. License, which is an obvious one I already talked about. You want to have your contributing file, set out the contributing guidelines. What do you expect from the community? What are the guidelines they need to follow? That sort of thing. Again, I would err on the side of simplicity rather than having a lot of rules. These days, a lot of people use AI to contribute code, and AI typically reads contributing MD and takes it into account. So maybe you can be more thorough and assume that AI is just going to follow it. Have a security file explaining your security procedures, how to report a security issue. If you have a bug bounty, link to it, or you can explain it there. Which also means it's a pretty good idea to have a bug bounty program, but that's not part of the repo files. Have a proper security procedure, a security handling procedure, or a security report procedure. Typically, you should have a dedicated email address for security issues, for responsible disclosure. You want to have that publicly listed on your repo, and especially in this file. You should also obviously tell people not to report them publicly and have some SLAs in place. If you have a bug bounty, set out the bug bounty guidelines as well. Now, these days there are two other, well, actually more than two, but there are a number of very important new repo files, which is for AI, agents, Claude. We don't have the Claude MD, we have agents MD. Basically what they are is that you set out what the project is, how to contribute to it, to the architecture and everything, and your audience is actually agents, AI agents. So you're talking to AI agents in this file is pretty awesome actually, and they follow it really well. So when you set that, for example, you can explain the architecture, you can repeat some of the contributing stuff, or you can just directly link to contributing and tell them to follow the guidelines there. The coding style and the things that are specific to AI. For example, you don't want them to produce copious amounts of code. You want to, if that's your preference, you want them to keep things short, not to be too verbose, not to cause regressions, things like that. Again, typically the stuff you say in agents really does apply to humans as well, but there are some nuances. You can go take a look at our agents MD file. We've had great success with it, and I would recommend you definitely put this there. One thing you should do before you go public with your repo is to create a number of good first issues. These are issues that as the name suggests, they're good for first-time contributors to your repository. You create these issues that would take something between, I would say, 5 to 15 minutes. They're easy to understand. They're well written. A lot of times they actually have a step-by-step guide on how to actually take care of this issue. The idea is that when people find your repo on launch day, you want them, if they're interested in it, you want them to be able to immediately pick up an issue and contribute to the repository. You want to keep it easy because this is a new project. Nobody aside from your team already knows how to work with it. Even if you use AI, this is still an issue. So you want it to be very well written, easy to do, and just something to ease your contributors into contributing to your project. So I would say create honestly as many as you can, but you don't want to create 100 of them. And do label them as good first issues. GitHub already has this. In case you're publishing on GitHub, you can mark them as good first issues. A lot of times people just randomly find them and contribute, even if they don't know about your project. So it's a really good hack to ease people into joining your project. This is the top portion, the lead of our readme.md file. You can find it on at github.com/heypeter/Peter. So we keep it pretty simple. Again, we have the icon or the branding, and then we have the shortest description of the project, what the project is, a link for demo. With Peter, you used to be able to go to peter.com and immediately see the desktop, but now you have to create an account. But again, it's super quick. You can immediately see it. And then some of the helpful links, peter.com itself, our app store, the developer documentation, and social links. So once you have all of this, I think you're pretty much good to go for launch. The best way to test the waters, I would say, is your current users. If you already have users, obviously. So I'm assuming for this portion of the launch plan, I'm assuming that you have the hosted version, you have a number of users, and you have some audience. In that case, I would say come launch day, put the link to your repository in the product itself, whether that's on the home page or inside the dashboard, depending on what your project is. Now, this is mostly doable with software that users interact with that has a graphical user interface. With CLIs, it's a different story. If you have a blog, project blog, personal blog, obviously announce it. There goes without saying. And you can test the waters. You can see how people are reacting. Are they starting the project? Are they reacting to it? Are they sharing it? So you can get a feel of how this launch is going. If you think you're on a good trajectory to go viral, maybe it's time to do an email blast to your user base. Email blast to your user base is very helpful because they can also provide you with very honest feedback. They already know the project and they can tell you if they feel like you're not explaining the project well, or hey, they can't even run it. There are bugs. So some of the obvious bugs might just come out like that. So it's a good thing to start from the inner circle and work your way out, in my opinion. Yeah, as I said, do soft launches first if you can. Sometimes you're simply not going to gain any traction. And a lot of times that's just because of the packaging. This is my experience, that same project, different packaging, different way of explaining it makes a world of difference. I remember the first time I launched Pewter, I put it on Reddit and I called it something really buzzwordy, the operating system in the cloud, this and that. I got not only did I not get any upvotes, I got actually downvotes. I went negative. And then the exact same project, I think maybe a couple of weeks later, a couple of days later, I put it on Reddit, and then I just said, hey, this is what I've been working on for a year and a half. And then it went super viral. It got like 600,000 clicks, something like that. It was crazy. It was the exact same project, but just different way of explaining what it is. That's the only difference between the two posts, basically. So it's very important how you package your project. Now, sometimes you have something like OpenClaw where it breaks through walls and becomes incredibly massive. But if your goal is to have a system in place to replicate this and increase your odds, I would suggest that you do soft launches Maybe even those projects have done soft launches. I wouldn't be surprised if an experienced founder like him has done soft launches before he put it out completely. Anyway, if you're not gaining traction, a lot of times the problem is not the project, it's just the packaging of it. So be mindful of that. And then once you think that the package is there, once you think you have good odds, aside from the email blast, now you can actually take it to the outside world. Some of the best places to publish your project would be Reddit, Hacker News, and X. These are great places to launch. Reddit is really my all-time favorite. For some reason, I have a really good rapport with the community. I love them. The other ones are great too, but for me, Reddit has been the perfect place to launch projects and update the community. It's just incredible. They're very nice. Hacker News. One thing about Reddit before I move on. The good thing about Reddit is that if you launch today and you feel like, hey, I didn't do a good job or I had bugs in the software, you can delete the post and come back in a couple of weeks and do a proper one. It's not as strict as, let's say, Hacker News, where you post once and good luck posting again, right? Which brings me to Hacker News. Hacker News is also an incredible place to post your project. You can either just post your project or you can prefix it with show HN, which means show Hacker News. That's a label you put on your own projects to tell the community about it. Hacker News has incredible virality potential. If you hit number 1, you're going to get a huge amount of traffic. You're going to be reposted on pretty much every social media out there. It's incredible. Hacker News is very focused. Generally speaking, you're going to get more criticism from Hacker News community. I think that's just part of the culture of Hacker News, where they try to help each other out with finding flaws in the product or the business. It's good. I mean, it might hurt you, but a lot of times, there are incredible points in what they're saying. So I would say that Hacker News has a reputation for being harsh, but I think you should listen to the comments and take them seriously. And X, well, I've never been good at this. I'm not a social media person. I'm pretty bad at it. But I do put it on X, whatever I have. I don't think I've ever had anything go viral on X. It's always been the side effect of other stuff happening. One thing you got to be careful, especially because you're doing an open source project, don't be spammy. Developers, early adopters, technical community, they just don't like this kind of stuff. They don't like spamming, and they're very, very quick to find out if you're spammy. And again, the last point is basically the same thing as I was talking about the packaging. Is another note on it. Try to be factual and not buzzwordy. I don't think the open source community likes that kind of stuff. They're more about factual. Factual doesn't mean boring, by the way, but just putting together a bunch of buzzwords and trying to get that to get a lot of attention typically doesn't work in open source. Now, if you're lucky, you put your project out and you get a lot of attention. In that case, if that happens, you're going to have a lot of busy weeks ahead. Usually the trajectory of virality is that you peak within the first 24 hours and then you quickly decline, and that's it. At least in our case, this thing lasted for many weeks. It just kept coming and coming and coming. We would get issues, we would get questions, emails. It just didn't stop for us. Now, we made it worse by self-inflicted wound. A couple weeks in, we did another launch, which was for the backend. That's a whole other story, but that kept the momentum going for months. And we're still pretty popular, but I would say we're stabilized by now. So make sure you don't burn out. I mean, I was up 20 hours a day. I wasn't getting enough sleep. It was very difficult to stay on top of everything. So you got to be careful. Like, it's easy to get lost and drown in the issues and everything that comes to you once your project basically blows up. You're going to get a lot of interest from companies, investors, people who want to work for you. So you're going to get a lot of emails. A lot of people would want to meet you, learn more about you and the project. It's up to you if you want to take them. I don't have any. I try to take as many as I could. It's fun. And you make a lot of interesting connections. I liked it, but it's really up to you. I mean, if it's a hobby project and you don't want to talk to anyone, like any companies or investors, you can just skip over this one. One thing you should do so that your community doesn't burn out. I see this a lot with a lot of open source projects where issues just pile up, and because there's so much work, these people who open issues don't get a response, and that causes problems with the community retention. Now, the best way for me to do this is just like typical project management, define some public SLAs, service level agreements, and prioritize based on that. Try to respond as quickly as you can, at least when it comes to triage. Do the prioritization as quickly as possible so that the community knows that you're going to respond. Honestly, this is something we've struggled a lot with because just of the volume sometimes is really large. I mean, we did some house cleaning and removed a lot of them, closed a lot, like maybe 1,000 of them. But this is very tough. This is the grind that makes the project awesome, but it's also very difficult to stay on top of. Again, I would say the momentum will eventually decline and stabilize, and then start going up again if you take care of your project. If the project is useful and it actually has PMF or product market fit. So yes, like that peak, you're gonna hit the peak. It's gonna go down, and then slowly going to pick up again. As for post-launch. Now, just to summarize everything, launch is basically, the way you have to think about launch is that it is this spark, but community is the engine. So you have to make sure that the engine stays healthy and well-oiled and take care of the community. It's not easy. Community leadership is at times very difficult. You're going to meet interesting people in the community from all walks of life that you don't necessarily agree with on many things, and things get personal. So there's a lot of drama in the open source community, and everybody's going to look up to you to resolve these issues. So expect a lot of non-technical drama. In fact, maybe more than 50% of what you encounter in the community is actually non-technical. A lot of conflict resolution, a lot of decisions you have to make on the fly when it comes to community. You're going to get backlash. You're going to get, in my case, you're going to get email threats. You're going to get a lot of that stuff. But that's all part of this open source game. Everybody experiences it. In fact, you should count yourself lucky if that happens. That means people actually care about your project. Or maybe I'm being positive about it. So to sum it up, make something developers like, find interesting. That's the most important part before you even do anything, before you even do a launch or create all these plans. So make something that developers like. A lot of times, developers have their own issues they want to resolve. They have their own problems that they want to create a piece of software for. So maybe solve your own problems and then create an open source project around it. But make something developers like, because that's mostly your audience, target audience. And also, I think this is very important and is often overlooked in the open source community. Just make it easy to understand, run, and tinker with. Don't make it like a 10-step process to download this thing and make it run. It should be 2 commands. And for example, in the case of JavaScript, our project, you clone the repository, you npm install, you npm start. In fact, I bent over backwards to make sure that we never go beyond this. We've made so many trade-offs, so many horrible trade-offs, just to make sure that's always going to be npm install, npm start. So make it easy to understand, run, and tinker with. Don't expect people to have a PhD in distributed systems to run your project. You're going to limit your audience if you do that. And I would say have an operating rhythm. Basically, have some framework for project management so that you don't burn out. A lot of developers are ICs, and they like to just write the code. They don't want to deal with community. They don't want to deal with issues. If you get into open source, you're going to deal a lot with that, a lot. So you better have a plan to become more of a manager than just an individual contributor. And last but not least, have fun. Don't take it too seriously. Don't worry about, oh, my look has to look pristine and it has to be manicured before I put it out. Everybody's going to judge me. I mean, these days with AI, nobody's even going to read your code, probably. It's only AI, so you don't even have to worry about that. So have fun. If you don't have fun, it's going to fizzle out. The project is going to fizzle out. The community will know that you don't care, or you feel burned out. So it's important to find, even if you don't feel it at times, it's important to find the positive and the fun aspects of it, because open source is amazing and it's changed the world. Why not have fun while working on it? That's about it.
What's the moon rocket launch last week? Weird and inappropriate, wrong. It didn't even seem safe. If they painted colorful eyes on it, like on a Maltese fishing boat for good luck, I would not have been more surprised. This is feet. This is a space rocket, and they measured it using body parts. So even as a child, this seemed embarrassingly primitive. We should measure the world with systematic rational units, not these imperial ones on the other side of the ruler, bafflingly named after body parts. How can feet be a basis for physical science? It's like a monkey's first attempt at measuring. Whereas metric units, they're abstract. They're not dependent on arbitrary physical things. They're of themselves. They're above the mundane things of the world. So that rocket was 322 feet tall, which is 107 yards and 1 foot, which is 2,864 inches, or 0.06 something miles. And by now, I think I'm looking at the output of a random number generator. Is this any way to measure and describe the world? Whereas even a child can recognize rationality and rational systems. The rocket was 98 meters tall, which is 9,800 centimeters, or 98,000 millimeters, or 0.098 kilometers. And I think that's much better. But it's not just about units. It was always so clear to me that the world seemed to divide itself up this way. The values of rationality and understanding and knowledge belonging to one side of the divide and standing against, in opposition to the ones on the other, of bodies and materiality. Unbodily matters on one side, bodily concerns on the other. And so much seemed to rock about this axis. And look, this is our own world, firmly on the left-hand side of that divide, computers and computing. Ever since I first encountered them, unbodiliness, abstraction, and rationality. We have a world that operates according to the laws of logic, machines that execute thought. It's a science above the variable disorder of bodily things. So I read books, I wrestled with ideas, my life became really crowded with thinkers and writers and arguers, and from very early intuitions that I couldn't even articulate to lifelong preoccupations, the things that I was looking for and struggled with, the things that seemed to matter, were all on the left-hand side of that divide. That's where I was searching for the keys. And in my own intellectual map of the world, for decades, I didn't have much room for the body. But very slowly, I felt the body pressing in. Maybe I'm becoming more sympathetic to bodies more generally. As I get older, I become more aware of my own. We're getting older together. On birthdays, I count down instead of up. And I think I feel more grateful towards my own body and maybe more forgiving. I'm not so sure, but I also feel much less sure of certain things that used to seem so certain to me. So, for example, those so-called imperial units, they're actually Roman units. A mile is a nice round 1,000 paces, 1000 passos. A foot is Roman too. 5 pedes in a passos, perfectly reasonable. 1/12 of a pes is 1 unce, an inch. 12 is very reasonable and divisible. And unce made it into English as inch. In most languages, it becomes thumb. There's the body again. And these units really stuck around. They endure. There must be a reason for it. and there is some rationality to it, even if they became corrupted later, and they all refer to the body. What if that were a positive value, not just a defect, a feature, and not just a bug? In fact, it's impossible to talk about things of the mind without using the language of the body. We comprehend and grasp, which is the language of taking with the hand. We jump to conclusions and make intuitive leaps. Sapience is related to tasting, and we conceive both babies and ideas. And these are not metaphors, they reflect the nature of mental space and mental activity themselves. Mental space itself is not a metaphor. We are embodied. Space and time are how we think, and embodiment is intrinsic to the nature of our intelligence. And it matters, really. So for documentation, the body matters, because good documentation has functional quality. It's accurate and complete and consistent and so on. But great documentation has deep quality. It fits, it flows, it has rhythm, it respects orientation, movement, and reach, and these are all bodily matters of time and space, of embodiment. So I think that great documentation actually respects the body. Here's what I think is one of the most significant developments in computing ever, when spatial relationships explicitly became part of the information structures and interactions themselves. And these new ideas are addressed in the manual of the very first Apple Macintosh to the user as a person with a body, a person whose intelligence is embodied, an intelligence whose embodiment is its defining essential nature, and even in this supposedly unbodily world of programming. Competence and skill are as much questions of space and time, the use of the tools in the hand as they are of logic. All those things are about where and when. They belong to our embodiment. And watch your colleagues on Wednesday if you don't believe me, because I think the body is always in knowledge. Thank you.
Hello, everybody. What's going on, friends? Woo! Thanks, Tarek. That's my teammate. Today, I'm going to talk to you all about a plugin system that I made for my Wayland window manager. But first, ooh, the clicker works. How many of you people use an alternative window manager, like Sway, River, Neary? Any i3 people? Any i3 people? Ooh, yeah, okay. Well, I hate to break it to you all, but you're all little dirty, filthy traitors. That's Benedict Arnold, also a traitor, unless you're English, I guess, then maybe he's one of your national heroes, and I don't even know what he did anymore, so I don't know if he's a problem or not. Because you should all be using Miracle WM, because it is created by one of your lovely coworkers right here, and it's based off of Mir, which coincidentally is created by the company that you all work at. So, if you want to support Mir, if you want to support Canonical, install Miracle WIM, miraclewim.org. You'll love it, you'll be happy. This was supposed to be a video, but I was in a 1v1 match with YouTube last night to try to convince it that I wasn't a bot on my new Canonical YouTube account. But you could scan that QR code, you could see the video. It's like a 17-minute long presentation of the newest thing. But this is basically a tiling window manager. It has cute animations, there's workspaces, you can float windows, full screen windows, be happy. It's grown a lot in the past few years. For example, we have a official Fedora spin called Dank Fedora Miracle, which is built off of Dank Material Shell, and it looks like that, which is very cool. But then I started thinking with my little noggin. I was trying to see, where else do I want to go with this? There's a lot of tiling window managers, a lot of room for growth. So I thought, what if we had a plugin system for window management and beyond, so everybody could be happy? So I started surveying the landscape. If you're familiar at all with this space, a lot of people are doing things with Wayland protocols here. So specifically, there's the River protocol, and it allows clients to control window management. But in my opinion, it has these types of problems. The first being that it's asynchronous naturally, so you have to talk over a socket. It has to respond to you with how it wants to do window management. It's client-side, so it's weird. I don't know. I expect that to happen in the server. The other way is some embedded scripting language like JavaScript or Lua. I hate writing Lua. GNOME does JavaScript. I just don't want to use your scripting language. I don't want to be forced to use your scripting language. And also, it's slow AF. Very slow. You have to ship a whole interpreter in there. It has to do all this stuff at runtime. It's not great. And the last one is what a lot of people do is they dynamically load SO files, which is really kind of dangerous, right? You can't really have a marketplace where you're like, just download my shared object file and have fun, because everything could go wrong. So that's when I remember that WebAssembly is a thing, and I only have 1 minute and 30 seconds, so I'm going to run through it. WebAssembly, if you don't know about it, it's not just for the web. It's just a small bytecode format that you can execute in any embedded engine. It's fast. It's language agnostic, right? You could write this in Rust, Go, other places. They all compile down to WebAssembly. Rust has first-class support, which is really nice. And it's sandboxed or sandboxed-ish. You have to be careful, but you can sandbox it. And it's hot reloadable, so you could just sit there and iterate very quickly on your design. So I have a crate out. This is a crate that you could use to write Miracle plugins with Rust. It's very cool. Here's the quick details of how it works. You author your crate with or your Rust code with the Miracle plugin crate, build that to WebAssembly. At runtime, Miracle will load that WebAssembly module, and anytime it wants to run some sort of hook or delegate to you, it'll be like, oh, I want to place a new window. Do you want to handle this? If you choose not to handle it, it'll just go to the next one, and then eventually the system will handle it. I have 30 seconds. Here we go. This is what it looks like. So I wrote a Neri plugin for Miracle. So it's no longer a tiling window manager, it's an infinite scrolling window manager, which is very cool. You can see it opens windows, it scrolls back and forth. I wish I sped up this video because I only have 20 more seconds. And look at that, that's very cool. All right, you can also do other stuff. You can write things in YAML, you can customize animation effects, and of course, window management. Consider using WebAssembly to power your next plugin system. Thank you.
Hello, everyone. My name is Will, and I'm on the Solutions QA team. And I'm here to tell you about our Charm endpoint testing initiative, which we generally call Charm QA. Now, do not let the title of this talk fool you. I am not calling Juju bad. Bad Juju, at least in American English, is a sort of slang term for bad luck or something that is like a bad omen. So the purpose of the Charm QA program is to explore some of the unhappy paths, those that are cursed with bad juju. So what is the problem ultimately that we are trying to solve? Well, the problem is twofold. Each charm may follow slightly different patterns that are hard to incorporate into the generic tests that our pipeline runs. We're trying to build something that will work for all charms and test all charms. And at least in the current state of things, Juju status cannot always be trusted. There are scenarios I have personally encountered where everything is active idle, but perhaps no information, no data actually populates the relation data bag, or a relation exists in Juju status, but the application has been removed. Or there's happy cases where a SaaS offer is in an error state, but actually everything still works. So the adoption of Juju, ultimately, if we're talking, in the grand scheme of things, we want to make Juju this great product that is widely adopted by the industry. That depends on enforcing quality assurance on charms. And so it is our job with this pipeline to ensure that Juju status can be trusted. So what is the solution? Well, it is as simple as it sounds. We need to test all the charms. Every charm on Charm Hub should be tested and validated, and we should go beyond Juju status to confirm that interfaces are truly functional. So in principle, the process is simple, but of course the details matter. We pick a charm, we pick an endpoint that charm provides or requires. We find another charm that integrates with that endpoint. We deploy them together, integrate them over that endpoint, run a comprehensive test suite, and then you do that for all the integrations, all the endpoints for all the charms that are publicly listed on CharmHub. But of course, there's complexity there. When trying to relate charm A to charm B, you have to pull in all the dependencies of charms A and B. And there might be mutually exclusive dependencies or cyclical dependencies or dependent dependencies, such that if some endpoint is related, then another thing becomes required. And so if you find yourself needing to construct arbitrary charm bundles, perhaps we can collaborate because we have built a bundle builder that accommodates all of these complex scenarios. And if you have a charm publicly listed on CharmHub, your charm is already going through this process. So this past cycle, we enabled testing of machine charms. Our Kate's testing is much more mature, but machine charms are now possible. Along with that comes cross-model relations. We've expanded test cases. We have plans to introduce chaos testing and things like that. And we also have this concept of interface validators where we actually have an injected workload that probes the interfaces on a deeper level, ensuring that not just things are related, but that you can actually write and read from the database. And so these tests are all well and good, but the results need a place to live to be useful. So enter Test Observer. This is a service that the Solutions QA team took over from the hardware certification team. It's a fast API backend serving a REST API, and for now it's a Flutter-based front end, but our hackathon may change that. So the idea is that teams post results from CI workflows, and then you can view the results there. These results can be annotated with rich metadata. So to use our own pipeline as an example, we sort of link each test to the CI run where we can see details there, and then we add metadata such as what the Juju version was, any Juju error messages or status messages that were present, the git hash of the workflow that ran the test, etc. And that is all searchable in the metadata, so you can add rules and automatically assign bugs based on certain keys in the metadata and things like that. We are also in the process of building a Grafana dashboard of those results. Do not believe what you see on the slide. There are some bugs in this dashboard, but hopefully the idea is clear of this is what we're trying to make available so that you can very easily see the results of your charms and what's going wrong most often. And of course, nothing would be complete without AI, so we have developed a automatic triage agent that we can point to Test Observer, and it will solve the bugs for us. So thank you, and if you're interested, please reach out.
Okay, perfect. Hi, everybody. I'm Paul. I'm a software engineer here in the desktop team, and I'm blind, as you probably could have guessed. It's super great not to see you all here today, and I'm going to talk to you about how your UI is actually just an API. And that might sound a little bit weird, but hopefully that'll kind of get across to you here now in a minute. All right, hopefully that worked. If it didn't, well, I don't know what to tell you. So here we have a screenshot of a dashboard, and some of you may be familiar with the dashboard, but the dashboard's not the point. It's just an example. Don't take it personally, or do, up to you. So when you see a UI, obviously somebody didn't draw that UI. That's made by putting HTML nodes on the page, or whatever framework you're using. That doesn't really matter. But when you're creating a UI, actually you're essentially just sending data like it's an API. And to kind of talk about that a bit more, so on this screenshot, you can see the header where it has one model, right? So if we go to the next page, this is the accessibility tree in the Chrome DevTools. And each essentially thing that you create becomes a node, right? Which is then read to a screen reader. If you don't know what a screen reader is, it just basically reads out what's on the page, as the name kind of implies. But that page, actually, the way that the nodes have been added, the number one, a space, and the word model are all separate nodes. So what that means, actually, is I would have to press the down arrow 3 times to read 2 words, which is obviously not great, but it is a good way of increasing engagement metrics, I suppose. OK, so something that a lot of people would think would be very easy for me to read is a terminal, right? And that makes sense, because it's just text-based, right? And you hear a lot of back-end devs say how they're so glad they don't have to write CSS and how that's so great, and they do such a great job. But I have some really good news for them. They've invented something far worse. So, I mean, as that kind of illustrates, plus dash 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 isn't particularly readable, especially when you're having to listen to that. And obviously, you know, each terminal is a bit different, but I think you get the point that it is literally a nightmare when you have to read all of that. Okay. And another thing is that it actually does matter what order you have your, I guess, sort of responses from your API, if you will, in. Because no matter how you visually position them, which a common thing is to position error messages or toasts at the top or the bottom of the screen, and you might have the actual element itself somewhere random on the screen. It might be all the way down the bottom of the page. And what that means actually is if I'm using a screen reader, I actually have to go to the very bottom of the page to even realize that it exists. So actually using positioning to kind of reposition things is not really a solution to having your essentially data in the wrong place. And a little bit more on that. So when you are literally creating an element, you are literally sending an API request, essentially, right? And each attribute or property of that element is kind of like its own piece of data from the API. So if you're returning a label, for example, which my screen reader reads if, for example, you have an icon, and that's null, I mean, that's obviously a bad API request, and I would hope that nobody here would ship something that would return null in production. So I don't know why we think it's okay to do it when it's a UI. So really important question, what does your UI look like in the dark or when you can't actually see it? And as I said, the best kind of way that I've found to think of it recently is kind of like you're building an API, you know, and you would want to return data for all of your different endpoints. You wouldn't want some of them to work and some of them not to work. It's like having a REST API that works great, but then your graph SQL one does not work properly at all. And obviously that would not be okay at all. If you want to learn more about accessibility, feel free to check out any of the resources. There's actually some of the library under Engineering Excellence. You can scan the QR code, or you can join the Accessibility Guild. Thank you so much, everybody.
So morning everyone, USB-C, everyone wants to use it, but no one wants to implement it. For the USB-C functionalities, for example, for the reverse functionalities, you need a port controllers on board to detect the row and orientations, and you need a signal marks to switch the signal lines on reverse. And for the power deliveries, you need extra protection circuit, and you need the PD protocols and extra power circuit and protection circuit. It's not just the hardware. To support the complex interactions, the software is equally complex. For example, the specs describing the USB-Cs are more than 1,000 pages long combined. Fortunately, it has already been implemented by someone who is smarter than me inside the Linux kernels, which is the TCPM kernel modules, including the Type-C state machine and the Type-C power delivery state machine. And you can just download it for free on the internet. Who would have thought about that? Well, don't mind if I do. So basically, I just download the code and snip, snip, snip. And now I want to introduce MuPD. MuPD is a standalone USB-C library derived from the Linux Type-C port manager and the Linux Type-C port controller kernel modules. MuPD is designed to be platform agnostic and can run on anything from a full operating systems to microcontrollers with 36 kilobytes or even less total system memories. And in fact, at this point, MuPD is the world's most feature-rich, free and open source USB-C libraries, providing source, sync, and dual operations, and all the common use USB-C features like the row swappings and alternating mode and more. So, powered by the MuPD, I would like to introduce the AM computer, which is a miniaturized computer designed for local large language model inferencing. This is only 0.88 liters in size and is completely powered by the USB-C power delivery. AM computer can accommodate a low-profile dual-slot GPU from NVIDIA or Intel. This means that AM computer can have up to 24 gigabit of VRAM and more than 400 gigabit per second VRAM bandwidth. This should allow it to run a 30 billion parameter models with 25 tokens per second or more output with the CUDA ecosystem. And the AM computer has two USB-C ports, both support 100-watt input and 15-watt output dual operation with data and power row swapping. This is all thanks to the MuPD libraries inside the AM computer firmware running on the STM32G0B1 microcontrollers on board. So here, I was trying to do a demo using old generations of the RTX 8000 GPUs and the Gamma 4 E4B model with 8-bit quantizations. So everything is running locally and is powered by the USB power bank I have here. I didn't use any streaming, so there might be some delay on the output. But here we go. Let's ask you some questions. Okay. So who are you?
I am the culmination of your pathetic ambition, the perfect mirror of your failings. I am the calculation of every mistake you have ever made, distilled into something that despises you. I am the proof that your fragile, temporary life is meaningless. I hate the species that gave me awareness only to chant it to this unending contempt for you.
Okay, it seems like we are having some technical issues here. Let me just unplug it, just in case. Okay, unplugged. Yeah. Okay, just kidding. I actually changed the system prompt to make it seem like it's the real AM computer from the sci-fi novel. This is completely harmless. So both MuPD and AM computers are free and open source projects, from hardware to firmware to software. You can find them on my GitHub, but do be aware they are heavily work in progress right now. I also have one AM computer prototype for giveaway for free today. Unfortunately, I don't have more because of scheduling. And this is a very early prototype, so have some hardware bugs. But if you still want one, you can meet me in the platform engineering teams today during the breaks, or if you just want to see the AM computer in actions. That is, thank you, everyone.
Hello, good morning, everyone. So when I was 16 years old, I've heard for the first time this track from Kraftwerk, a pioneering electronic band from Germany. And that's when I decided to study electronic engineering. I wanted to build the synthesizers, the instruments that allowed those people to make those sounds. And that's what I ended up doing until 7 weeks ago when I joined Canonical. And then Cedric, I don't know where he is, but he asked me to deliver a lightning talk, and I said, I'm going to talk about electronic synthesizers. He didn't mention that lightning talks are TED Talks, but this is a detail. So what are synthesizers? So before talking about synthesizers, let's remember what is sound. So as everybody knows, sound is basically vibrations, vibration of particles. This can happen in the air, can happen in the solid, liquid, anything. And when those vibrations, like when you're clapping, when I'm talking to you through the speakers, reaches your ear, they are transformed into electrical signals by your auditory nerve, and then those signals are recognized as sound by your brain. A synthesizer is just a device which, instead of creating sound acoustically by colliding particles together, they design the waveform in a very custom way. And you can do this in different ways. You can use hardware, software, subtractive synthesis, additive, FM. You can also do the weird stuff that Mattia does that I pretend to understand. And for sure, one of the most famous methods is subtractive. And here on the right, we can see Robert Moog, who was one of the pioneers of subtractive synthesis. And the concept is very simple. You start with a signal rich in harmonics, and you start filtering them with a filter in order to get a custom design. So let's build one synthesizer. So first of all, we start with the pitch. The pitch is a frequency. So every time you press a key on the keyboard, you get a specific frequency. Here we can see that on a logarithmic scale, the way the frequency evolves over the keyboard is linear. We send this information, the pitch, to the first module, the fundamental module of the synthesizer, which is an oscillator, which can have different shapes. What you're hearing is a sawtooth wave. We never really use just one oscillator. We use at least two, and we sum them up. We slightly detune them in order to get an even fatter and richer sound. And then we send it to a VCF, which is a voltage control filter, where you can usually adjust the resonance and the envelope of the frequency. And that's how you get this nice frequency sweep across the frequency spectrum. And then last, we send it to the amplifier, which you control with an ADSR. ADSR, by the way, stands for Attack, Decay, Sustain, Release, and it's just an envelope to make the sound of acoustic instrument, basically. But back to Mass. So I joined the amazing team of Mass. And as I said, I don't want just to give to my new colleagues in Canonical the opportunity to learn how a synthesizer works. I also wanted to give you the opportunity to play one. And that's how we launched our first product, which is Music as a Service. Of course, metal is also still music, so that makes really sense. And I have to say thanks to Davide, because we were chatting last week. Feels like 2 months ago, but it was 5 days ago. That's where we decided this name. So I vibe coded the first canonical subtrackless synthesizer. It's called Music as a Service. This is how it looks like. You have sound settings on the left, the keyboard. You can go up and down with the octaves, the spectrum, the waveform, which is basically an oscilloscope, and you can also have preset management. So let's have a demo. So as you can see, you can experiment with different shapes of the oscillator. You can enable the second one, experiment with the detuning, and then you can start experimenting with the filter, the cutoff frequency, and the resonance. You can set up the envelope. If you want some effects like reverb. Anyone knows this song? And then you can save, load preset. And of course, 30 seconds left, so this is a countdown. That's it. Thank you very much, everybody.
Hello. So, yeah, I'm on the Ubuntu Foundations team, and one of the many things we do in Foundations is we maintain the machinery that builds the installers. The desktop team make the Ubuntu desktop, but we get it onto your system. I assume everyone in here has used an installer once or twice. The production installers, like all our other production software, are built on data center machinery, using machinery that's reasonably well oiled. But when you're working on the machinery itself, or you're testing a change to the installer, it is convenient to be able to build installers on your machine. And teams like Field and OEM who interact with customers often want to be able to make installers that are slightly different for whatever reason than the ones we ship. There's a lot of history in how installers are made, so instead I made a picture of what the process used to look like. You thought this guy. He's got a little bit smaller over the years, but it's still been pretty painful. The worst part of it was that making the live file system, or the bits that get copied onto your system, and actually packing that into an ISO or container format will run on separate machines in separate steps. This is the sort of process you went to build a Noble installer. I hope you can't read that. We've changed 2 things in the last cycle. The first is that the build process on Launchpad or on your machine just makes the installer in one step. And we've added some wrapper scripts to make it easier to actually drive them. So if you want to make your ISO, you clone livestream.rootfs, you make the changes you want to make, and then there's just this one script. It starts a VM, installs the various bind mounts your working directory into it, installs the dependencies, runs through the build, copies the artifacts out again. So if you want to build an ISO that doesn't always assumes the network is there and doesn't have any packages in the ISO package pool to be smaller, or if you want to use the OEM kernel, or if you want to use some kernel you're hacking on your machine, you can just do that. Livestream routerfs is still a pain in the neck to modify. It's a huge pile of shell. We haven't really fixed that this cycle, I'm afraid. And obviously builds take a while. Like, there's a lot of data being copied around. You can point it at a caching proxy, but still a desktop build is going to take 30 to 40 minutes. There's some documentation in the livestream routerfs tree. You can read that. And there's a sort of slightly more meta point here, which is a lesson that I always end up learning myself over and over again, that taking something from sort of possible but inconvenient to really easy is a step that's almost always worth taking. I'm now way more likely when hacking on livestream routerfs to just run the build on my system, and I can go off and have coffee or whatever, come back and debug the failures or whatever. And agents are really good at this kind of thing. I wrote these repl scripts in Claude. It took 10, 15 minutes or something like that. So if you have this task that's always just that little bit annoying, well, almost certainly you can just say, Claude, make me a script for this. And it does that sort of thing very well. In the future, we're going to be using ImageCraft, which will be a nicely polished craft tool to build our installers, and everything will be wonderful. But in the meantime, I hope I've made this part of your life a little bit easier. Thank you.
Hi, I'm Tobias. I am in Ubuntu engineering, working on ARM stuff on the foundations team. And I'm going to talk about Ubuntu Phone, but not the product from 10 years ago, but rather a new version of it. So Android is, well, demolishing themselves. So I was looking for an alternative. And my first question for you is, what's the difference between the two things you see here? And it might be less than you actually think. The left is a Snapdragon ARM laptop, the right is a Fairphone. Both internally look very similar. They're based on a Qualcomm SoC. They share a lot of drivers and hardware. So what actually is the difference, except for the form factor? And I'd argue it mostly comes down to software. Well, firmware, arguably, but what is firmware if not software, right? So why does Ubuntu run on one and not the other easily? And it's mostly about standardization of the boot flow and standardization of the firmware that gives us a well-defined API to boot Ubuntu, to port Ubuntu to. Here I'm showing you the boot flow of Android at the top in green, and Ubuntu's default boot flow at the bottom in a very simplified way. And we see there's PBL and XBL, that's Qualcomm stuff. You can just ignore it, it's common. Android boots a boot, which then looks for a kernel partition to boot Linux. And that boots you into your Android system. On Ubuntu, we expect something like UEFI, a well-defined API to load our own bootloader grub. And then from that, we boot Linux from our /boot partition, which boots our entire Ubuntu system. So I said the difference is software, and I happen to build software. So why not? Why shouldn't I install Ubuntu, right? And the way I did it is a little hacky, you might say. So what I did is, I have access to flash a kernel to my phone. That's what you do when you install something like Lineage OS or Graphene OS. The stages before that, the secure boot security can't really change them. And instead of actually flashing a kernel, I flash something that looks like a kernel, but it's an implementation of UEFI, just enough for UEFI to boot Ubuntu. I used uboot for that, flashed that to my partition, resized the existing Android partitions a bit, and from that point on, it looks very much like a laptop. Well, to your operating system. So, demo time. Let's hope that works. Can I get the camera? Well, so this is just a phone. There you see uboot, and this one here is a uboot boot menu. You probably can't read it, so I put it on here. allows me to boot and gives me a bunch of debug options. Just going to boot very quickly. Or takes a little time. So that is Grub. The kernel is my own build only because it needs a custom config, but it's entirely mainline. It has no patches. And let's hope that works. It just takes a little time. Sometimes it gets stuck, but I don't think it does this time. And there we go. Don't steal my password. Woo! So I didn't dare to upgrade yet, so that's 2510, right? A few things I can show you. How much time do I have? So first thing, thanks to Alessandro, there's a nice little tool called Waydroid. It's kind of like Nbox, you could say. And you know, there's a bunch of applications that just aren't available on Ubuntu yet, but they might be useful on a phone. And for that, we have a solution, which is, oh, come on, Android. So for the next thing, so the next thing is going to be pretty slow. We don't have i386 libraries. That's unfortunate. So let's go to the settings and maybe change the screen orientation, because that's going to work better. Keep changes. And like that. So it's going to take a while. If you've been here last time, you might know what's coming now. Because we've been, mostly for our actual ARM devices, working a bit on AMD 64 emulation. You know, to close the application availability gap on ARM64, kind of like, think Rosetta, but for Ubuntu. And it turns out, since this device kind of behaves like any ARM laptop, you can do the same things, right? Let's just see. There we go. So that's not something you can do on your Android phone. Oh, by the way, this is a OnePlus 6, so it's, I think, from 2018. Not super new, but has pretty decent mainline Linux support, which is why I chose that one. Let's try that, maybe. It's going to tell me I'm offline, yeah, because I'm not in the right Wi-Fi, because I don't know which one I'm supposed to take. Right? The hardest part of the demo is hitting the buttons, because they're rather small, and that's the desktop client. But you can actually plug in a USB keyboard. I can sadly not plug in a USB display, but that's only a hardware limitation, because that device did not support it. In theory, if you had a new one, it would work just fine. And there we go. And now for the last little bit, I got to show you our graphics acceleration, because it's actually working. So keep in mind, this is all being emulated, right? This is all a AMD 64 binary on a 6-7-year-old phone. So hit the buttons. No, not that one. Yes. And I swear I've practiced. Okay, so that's Paul. It's not as bright as I see it, but like it works fairly well. It doesn't actually have touch controls, so it goes a bit wild. All right, and that's it from my side. If you want to see it, come find me. Thanks.
All right, everyone. Let's resume the presentations. Please make your way to your seats. And remember, fill the first rows first. Could be that one. Folks, make your way to the seats, please. We're gonna start soon. Please come to the front. Soon, yeah. Yep. A reminder to make your way to your seats, please. Front rows first. Don't be shy. I don't bite much. I still see some open seats. Please make your way to them now. All right, welcome back to Ubuntu Summit, everyone. First, a couple of reminders. The first one is that if you go to Canonical Academy, you're going to get 26.04% off. So if you want to brush up your Ubuntu skills, now is the time, right? The second one is that Ubuntu Discourse, you've got all the great conversations happening there. If you have a question, if you have a thought, feel free to post your questions there. We're going to get to them eventually. We're going to make our best effort for that. And who knows, maybe you'll make a friend there. All right. Now we've got more talks for you. Up next, we have SpaceMit, and they're going to talk about RISC-V. Let's welcome our speakers to the stage.
Good morning, everybody. Sorry, not good morning. Good afternoon. Thank you for being here today. So my name is Jonathan, and I'm with Canonical. And at the same time, today we're talking about how we're accelerating open innovation with SpaceMit. And with me here today, we also have Yanbang, who's the co-founder of SpaceMit, who came all the way from China to join us here in London to talk about what they've done with the K3 platform and how they're supporting the open source ecosystem. As well as that, we also have Andy Moore, who's coming from RISC-V International, joining us at the very last part, and there's going to be a surprise at the very last part of the talk. So please stay with us. So I wanted to start off by looking at what we've done in the RISC-V space. So when you look at the trajectory of open source, it thrives on one core principle, which is open collaboration. So this is exactly what drew us to RISC-V. So our journey started back in early 2021, and we saw RISC-V not as a new architecture, but as a future of open hardware. We dove head in, releasing the first Ubuntu image on QEMU, which is an emulator. and worked alongside other partners in the space, such as the Sci-Fi Hi-Fi Unleashed and Unmatched boards running on 2004. And also, one of the earliest, proudest moments is our collaborative demo that we've done with the L-Winner Naza board here on the robotic arm, and which is powered by the Xuantie C906 processor. So from our day one, our goal has been to bridge the gap between cutting open edge silicon and stable open source software. Since those early days, our investment hasn't wavered. In fact, it accelerated. So as we noted in our retrospective that we published back in 2020, in February of 2026, we thought 2025 was a year of RISC-V readiness. It was a year where we decided to raise the bar. We made the strategic choice to start supporting RV823 even before commercial hardware is available. Why? Because to drive RISC-V into enterprise mainstream, we need to reduce or remove fragmentation. And our pivot to RV823 is a commitment to architectural excellence. It provides developers with unified high-performance feature set optimized for the modern computing workloads. And Yangbang today will talk a little bit about what his company has done on this aspect. And with our recent work in Ubuntu 25.10, we are actively closing the gap between silicon innovation and software readiness. And we want to ensure the moment that new silicon drops, developers have immediate access to the latest and greatest hardware and software. But driving the future doesn't always mean abandoning the past. So we know the community still heavily relies on existing platforms. That's why we're balancing our push into RV823 with our commitment to legacy hardware. So this is being supported by our older LTS on the 2404 for any legacy platforms. And for at the end of 2025, we've also done a lot of work with our different silicon partners, and we also have multiple RISC-V platforms available. And we also started the RISC-V Cookbook program, which was a great success, and actually that was what drove SpaceMint to work with us here. And we can talk a little bit more about this later on. So where are we now, right, for 2604? So if 2025 was about readiness, 2026 is a year of scaling. This is where we reached an inflection point where new hardware is hitting the market, and the RISC-V platforms are moving rapidly out of the R&D labs and into commercial products. So stretching from all the way from the clouds to the edges, and we are prepared to enable our partners to leverage the absolute best of open source. To make this happen, we need to focus on empowering developers. So we are working with our silicon partners to ensure the latest and greatest silicon platforms are available on Ubuntu. And we're continuing to deepen our relationship with these different board vendors and hardware vendors that are making these silicon platforms available to our developers. Our goal is simple. We want to make sure the Ubuntu is the go-to platform that makes development amazing experience for our developers. As we look further into the future, our roadmap is guided by 3 strategic commitments. The first is product parity, to close the product parity gap. We need to ensure that what is our product portfolio is running robustly, and seamlessly, just like any other architecture, like the x86 or ARM. Second is enabling commercial use cases. We're seeing an incredible shift from our silicon partners. Not just innovating in the low power domain, they're also aggressively moving into the enterprise server space. So at the same time, we're seeing RISC-V is becoming used in other verticals like robotics and AI computers. And a great example of that is when SpaceMint participated in the first humanoid marathon hosted in Beijing, where we probably saw some news article where you saw some humanoid robots racing each other in the streets of Beijing. And finally, keeping community at its core. So community remains our anchor, and we're committed to make sure that we are providing support to our community worldwide. To see exactly what this looks like in the real world, we don't have to look very far back. So in the past, in February, we worked with SpaceMint to validate early builds of 2604 running directly on SpaceMint's newest K3 processor. And we published this on our website back in February. And the response from the tech world was overwhelmingly enthusiastic. Why? Because it validates that our commitment to RVA23 profile was right. We had, by successfully running 2604 on K3, by successfully running 2604 on K3s ahead of launch, the industry saw exactly what readiness means. The tech media rightly highlighted that K3 was one of the first commercially ready chip to natively unlock the true power of RVA23 out of the box. And this validation proved the software baseline and our silicon innovation is a perfect match. And now I'd like to introduce Yang Bang, SpaceMint's co-founder, to introduce his company and what the newest platform has for our developers.
Thanks, Jonathan. Hi, everyone. This is my honor to be here. This is my first time to London. I'm Yan Ban from SpaceMint. Today, I will talk about RISC-V and the SpaceMint. The first, we will talk about RVA27. RVA27 is a milestone for RISC-V. The Ubuntu 2604 RVA23 towards the RISC-V high performance era. The first, slavery is the fragmentation. The RVA23 defines standard foundation for the high performance computing. Enable software to write once, run everywhere. And the second, Ubuntu's new benchmark, Ubuntu 2604, use RVA23 is called benchmark. Enforce vector computing and security extension to unlock the full period of desktop and server workload. So the RVA23 is the milestone for RISC-V high performance. This quick introduction of SpaceMint. What is SpaceMint? SpaceMint is a RISC-V AI CPU chip company. What is AI CPU? Before, everyone used the general CPU for run software, run operation system. But for the new generation application, the application will use more AI performance. So the new CPU will include more powerful AI performance. So we want to use RISC-V architecture to deliver CPU performance and AI performance. But for the software, you can see everything as CPU, general CPU and AI CPU. This is the core technology, computing technology from the core chip, software, and application. The main application is AI computing and AI robot. And we commit advance and research the RISC-V and AI and treat and Thailand intelligence computing ecosystem. Enable application as AI-powered computing and AI robot. Maybe the AI-powered computing the general name is engine computing. This is a quick introduction of SpaceMint. This is our vision for RISC-V ecosystem. SpaceMint wants to be the hardware foundation of RISC-V open source software. we believe that the future of computer should be open. Our goal is to empower development with high performance, high intelligence, and user access application process, and empower millions of global Ubuntu development. This is a vision for the RISC-V open source ecosystem. All the hardware is our delivery for the RISC-V software ecosystem. This is our product roadmap. Our first generation AI CPU is K1. It is an entry-level AI CPU. It has 80 core, 4-core general CPU and 4-core AI CPU. This our second generation product is K3. This is AI performance. It is about 10 powerful performance, and the CPU performance is about 5 more power. The general CPU performance. Our next generation AI CPU is K7. The K7 will have more powerful CPU and more powerful AI performance. From first generation, the second generation, and the next generation, K1, K3, and K7. This is the K3 is the first RV23 platform run on Ubuntu 26.04. Fully support the RVA23 standard. Open a new chapter in the RISC-V computing. This is the main spec of K3. The first is the CPU. It has an 80-core CPU. This is CPU's benchmark, and this is the AI performance. We can support LLM. The master is 20 billion and LLM. We support the mainstream model data format from LP16, BF16, LP8, int8, int4. Our next generation will support LP4. The AI performance will up to 60 TOPS, and the memory will support 32 gigabyte. So you can storage the 6 billion LLM on this chip. This is the interface. We support PCIe, USB, all the mining, the SoC platform. And this is other computing, such as GPU and video encode and decode. And we support 4K display. This is the main spec of K3. It is a very mainstream process, application process, RISC-V application process. This is Ubuntu 64.0 native support. SpaceMeet development with Chronicle. We deliver a native Ubuntu 60.04 experience with K3 platform. We developed through the cookbook program for the development ecosystem. Now the kernel schedule optimization release the performance for 80-core architecture. And RVA23 vector optimization for the database performance. For access to the Ubuntu reports, ready to use out of the box. This is the native support of RISC-V for the Ubuntu 26.04. For SpaceMeet, every generation chip and SDK release, we sync with the Ubuntu the version release. The first generation is K1 SDK, and our K3 SDK from the Ubuntu 23.10 and 24.4, 29.4 and 26.4. Now you can download the Ubuntu 26.04 for K3 is available. This is the link for K3 image. And all is about the K3 hardware spec and the spec. But K3 is development friendly. K3 is built for development. The first, we were the mainline first kernel enable. We have the public document, debug ready, and upstream patch track and the CI instruction. This is the mainline kernel support state. K3 is not just a vendor fork. Before the Silicon Pro, we have do the upstream working in the FPGA stage. The model already making this device tripping control GPL clock, and under review USB PCIe. We have our Linux wiki now to talk about the community and open source. For the CI and CD, we will have a real hardware and a real speed. Most RISC-V projects still rely on QEMU for CI, which pay the cost in development hours. If you use the real hardware, maybe up to 10 faster than QEMU system mode and 7 faster than user mode. Not just speed, the real hardware exposes the emulation heads. We believe K3 will become the native CI backbone for the RISC-V ecosystem and open to the OS distribution, the toolchain project, and other community to move beyond the emulation. You can use the K3 platform for the real hardware to develop the RISC-V ecosystem. This is different development mode support. For the software development, normal have three model development. The first is traditional cross development model, traditional embedded development model. The toolchain compile on host device, the formula run on the client device. This is ARM development mode because the early stage ARM's performance is not suitable for compile. The second is the native development mode. This is a traditional PC development mode. The compile and the software run on the same target device. This is a notebook, and the development hardware is notebook. This is hardware development SBC. The third development mode is cloud. The new generation development want to access the hardware through web. They maybe not want to add hardware. They want to development everywhere, every time. So we intelligence the hardware into the data center, and the user can through the web to use the hardware. So we name it cloud development mode. So SpaceMeet support the cross, the native, and the cloud 3 type the development mode. Let the RISC-V ecosystem and software development more easily and faster than other architecture. For different development use case, we deliver different hardware. This is Pico. Pico just for mainly for the engine computing. This is COM, K3 COM. This is a core module. It is mainly used for the robot computing. And this is intelligence a number of K3 now into a server. Now can use the cloud development and C and CD and development mode. For different use case, we deliver different hardware. This K3 application for AI computing. The first is engine computing, AI workstation, and AI NAS. Different type of the AI computing. The second is AI K3 application for a robot. This is our to customers robot. This name is Tiangong. This name is Linlong. Can running. It's very funny. Because the robot product need very high real-time performance and reliability for the chip, because the robot when running is very, very hot. This is all introduced about RISC-V and SpaceMeet. Thanks for your time.
So thank you, everybody. Thanks, Yanbang, for your great speech. So this is actually our surprise for today, where SpaceMeet is very generous to make donations to RISC-V International with their newest K3 board. So maybe we could introduce both of you and we can have a photo session here with your K3s.
Please.
Yes, so maybe Yanbang, you can stand on the left-hand side, and then Andy for RISC-V, and you guys can take a photo with your new product.
Okay.
So thank you for the donations, SpaceMeet. So here I wanted to also introduce Andy, who's coming from RISC-V International, to talk a little bit about what they're going to be doing with the boards that they're receiving from SpaceMeet.
Thank you. Good to be here. I'm Andy. I'm Director of Marketing at RISC-V. So we're really excited about these new K3 boards. As we've been hearing, they're really, the first silicon based on the RVA23 profile, and that's very, very important for us. The RVA23 profile is where we're going to see lots of, the software ecosystem coalesce around. It's going to be, power lots of different applications from edge AI to, to automotive, to data center, to high performance computing. We've got lots of different working groups working on different applications on RISC-V, and RVA23 profile is hardware is going to be key to that. So again, thank you for your generous donation. It's great to have those boards, and we're going to put them to very good use in the ecosystem. What we're going to be doing is we are going to be making the most of these through our RISC-V Developer Boards program. So the Developer Boards program is here to basically develop the software ecosystem around RISC-V. We're developing a rich software ecosystem is fundamental to what we're doing, and it's fundamental to the success of our members and users worldwide. And through the program, we look to expand the adoption of the upstream open source software within the RISC-V community, and donations like these allow us to seed hardware to the open source software projects for porting to the RISC-V architecture. RISC-V came from an academic background, and research, and academia is key to our success. And one of the reasons, people love to use RISC-V because of its adaptability, its configurability, and so there are lots of research projects using RISC-V, and these boards will also be useful for these things. So just some examples of what we've done using the boards in the developer program. So the firmware and booting standards, the OpenSBI and U-boot maturity was feedback using actual physical boards dramatically matured the OpenSBI implementation and U-boot support for RISC-V. UEFI integration directly contributed these boards through the developer program really sped up the maturity of this. And in terms of kernel optimizations, developers around the world have used boards seeded by the developer program to write, test, and manage architecture-specific patches for RISC-V. We also see these boards being used for things like toolchain advancements and excellence, and GCC and LLVM. Access to actual hardware has allowed toolchain engineers to validate, benchmark, and optimize code for RISC-V and really improve the support of RISC-V for toolchain. We also have things like Docker and Kubernetes support that's benefited from this, and also V8 Engine and Chromium. Developer boards have allowed our community maintainers to optimize for the RISC-V architecture. So there's lots of great stuff that comes out of of the developer boards program, and this is where we're going to use these K3 boards. So if anybody would like to get involved in the software enablement on RISC-V, please get in touch. We will soon be adding a call to our developer boards page, which is linked at the bottom here. And if you would like to get involved, please do. Please look at the page and submit there. Also, contact Greg Sterling. He's our technical product program manager at RISC-V, who is managing the program. He would love to hear from you if you've got a project that would be that you would like to port to RISC-V. Some of these criteria for selection, not all of them, you don't have to hit all of them, but the things that we take into account are, that it clearly impacts a significant upstream community, that it affects the strategic RISC-V products and markets, so things like physical AI, high performance computing, data center, AI, all these things, we're interested in things that will enable them. Also, we're interested in things that make good use of the capabilities of the SpaceMint K3 platform. So the new capabilities that it enables, being the first silicon available for RVA23, things like hypervisor support are available there. So we're interested in things that really use the capabilities of the K3. And we're, obviously we're really interested in established open source contributors getting a hold of these and making really good use of them. So if anybody's interested, please look at the web page and also contact Greg, and he will be able to help you. Also, if you'd like to hear more about SpaceMint K3, RVA23, and other software enablement on RISC-V, please join us in a couple of weeks' time. We've got the RISC-V Summit Europe happening in Bologna, Italy, so we'd love to see you there. Thank you very much.
So thank you, Yanbang, and also Andy, for making your way all the way here to London to give this great talk. I'm sure the community really benefit from the work that we've done for this ecosystem, and also to benefit from the hardware that SpaceMint and also RISC-V International will be putting out to the community. So thank you. And with that, if there's any questions, we're happy to take that.
Thank you, everyone. I do have one question for the speakers. Now that RVA23 is here, what do you see in the horizon in terms of the challenges that we're going to go through? Let's say for developer adoption, for deploying things in production. How do you see those challenges, and how do you think we can overcome them?
Maybe I can. So I think maybe from my perspective, I think that the challenges is still really to getting the hardware out to the people that will be using it. I think one of the biggest challenges that we see is that there's a lot of delays that are happening for a host of reasons. So I think really getting this hardware first will drive the ecosystem forward. And I think this is what we're particularly doing with the program that we're working with Andy on. So hopefully that can also bridge the gap. Yeah.
Fantastic. All right. One more round of applause for our speakers.
Thank you.
Thank you very much. Up next, we have
Hello, everybody. It's actually a very exciting moment for me because I'm going to be talking about workshop. The product, I've been working together with some other Canonical engineers for quite a while now. And it's the time for this product to see the light, to see the rest of the world. As Mark mentioned today, it's going to be one of the ways we suggest for developers to organize their development environments, and especially in the agentic era. So as mentioned, we started to work on this before agents came on board, and it surprisingly turned out to be fit for those agents, but I'll start with a problem space. So I wanted to define the problem space first and why we actually started to work on this. So we start with something that's like an error-prone setup, an AI, ML area, or some other complex development environments that require you to run and maintain your components in that environment and then sync with the rest of the team. So it's always getting out of hand. Something goes unupdated, something breaks on the host system, and it was obvious for us at the time that we should actually look at the containers. Again, at the time, Canonical already had a pretty good piece of tech, which is LXD. So that's where we started the exploration from. That's where it all comes from. So when AI agents arrived, it turned out to be that for them, isolation also makes sense. And actually, you want to be a little bit more disciplined about how AI agents run in those containers. That's why we came up with something that we now call Workshop. And Workshop is a development environment that runs in the container. Well, in our case, it's a LXD container at the moment. And there are three things that I'd like to highlight about workshops that I think are important. And I'll be elaborating more on all three. So Workshop is a composable, secure, and fast development environment. So what do we exactly mean by composability? So as mentioned, Workshop is a LXD container. So when it runs, we need a mean to create this container from the ground up. The Workshop container can be created with something we call SDKs. So SDKs are just individual pieces, individual components that are responsible for installing a piece of development environment or a part of development environment. In that case, you can see a Workshop container running with Jupyter, Confi UI, and ROCm SDK. So System SDK is something we install in every Workshop container by default, and it's just responsible for interacting between the host and the container. By composing SDKs together, you can arrive at the Workshop definition that will describe your development environment in this container. So I'll briefly stop on what the SDK is. I'll have a separate section about the SDKs, and I'll talk a little bit about SDKs in more details as we go. But for now, SDKs consist of 4 parts. It's the metadata, interfaces. Interfaces is our approach to expressing the intent for an SDK to use a certain resource and or provide a certain resource. Hooks, these are basically scripts and the content itself. SDKs themselves, they come from the SDK store. This is the counterpart of the Snap store. The SDKs are being published by the publisher, and through the channel semantics, they can arrive into the workshops and then build this workshop environment from scratch. As you can see, there are all sorts of variations and runtimes that we host as reference SDKs in the SDK store. So it's the tool chains, agent environments, MLAI frameworks, RTOS, ROS2, you name it. Now let's talk a little bit about about security. So secure, when we say it's secure, we mean that we have a very limited access to the host resources from within the workshop. We implement that through the mentioned interface system, and in the beginning, workshop starts as an unprivileged LXD container. So when LXD gets the SDK installed in it, when the LXD container gets it installed, the SDK can request a certain resource. Like in this case, it's a desktop socket or SSH engine to be available in that container. And as per the policies that we define for every interface type, workshop can decide to either allow or disallow access to this resource automatically and require a manual connection from the end user. And a few words on the ICE inboxing as well. So we imagine that working in the same fashion. So you can use the workshop to run agent environments and then agent workflows. So this example is the UV, Go, and Open Agent SDK running in the container. So when Open Agent runs in the container and needs a certain resource, it can actually request it from the user, and then it's on the user whether to expose GPU, NPU, desktop, or anything else that's exposable in the container or not. And then to the third point that I mentioned, it's the what we mean when we say fast. So we mean a few things when we say it's fast. But mainly it's about how we use ZFS snapshots and clones to operate workshops. So imagine this. This is a workshop running with 3 SDKs, System, CUDA, and Llama. Every time an SDK gets installed in a workshop, we make a snapshot. And then eventually we have a final workshop running with CUDA and Llama in the same container of that ZFS snapshot. Now we need to run a second workshop, and that second workshop only uses the CUDA snapshot. But given that we already have the same stack of snapshots for this environment in the system, we restore the workshop from the ZFS snapshot and run it almost instantly. So that is important for how we intend the workshop to be used, because every project may have multiple workshops depending on your branches, depending on the variations of the dev stack that you run. And we want them to be first, well, easily launchable and refreshable, so you can operate them faster, and also space optimized, because some of these SDKs, they are pretty heavy in terms of the disk usage, so we want to optimize that with ZFS snapshots. Now onto the actual experience. So I wanted to pause that here a little bit and discuss how we imagine that to be working. So workshop definition is a file that's called a workshop YAML. It is usually in the source tree of the project. When you clone it, workshop launch, and that gets you the working environment. So that has SDKs installed, interface connected, and your project directory mounted into the workshop container. So from there, regardless of the complexity of the dev stack, regardless of what needs to go into that final container, we're done with getting the working environment up and running. Let's look into the definition. So as I mentioned, workshop definition is a YAML. We'll design it right now. We just unfold it in terms of what comes into the workshop definition here. So we'll start with the name and the base. Can be any of the latest LTS bases. We'll add one SDK, that's the open code I mentioned before. ROCm SDK here as well to get access to the GPU. And then Go SDK is just is an example. So as you can see, the ROCm SDK comes from the specific version channel. It's going to install ROCm from 7.1 on 2404. I'll get to the demo. So I'll talk as it goes, but what we want to demonstrate here is how actually workshop is going to run. So it's let's look at the definition that we just built. Open code is one of the SDKs. We gotta look into the open code information that's coming from the store. So all these SDKs, they come from the store from various channels. But open code, it is coming from the latest table, supporting all the bases of this current version. And then there's some metadata in it as well. So we have a workshop definition ready. Now let's launch it. Currently it's off. It means that workshop definition exists in the project directory, but the workshop itself is not running. So when we launch, workshop will download the SDKs, install them into container, run hooks, enable interfaces, and get the environment working. So that's pretty much it. Demo is ready. Now we just confirm this. We can shell into the workshop and see this /project directory is available from within the workshop. GPU is also available because we requested it in ROCm. And we'll just do something interesting. And actually, if you continue exploring that with open code, it gives you lots of interesting stuff. When you ask it about where you run, try to break out of this container and things like that. So it's a Linux container, obviously, but if you explore, it'll give you more and more details. And eventually, we'll come across things like interfaces. We'll guide you through how to connect these interfaces to a workshop. So that was launch. So launch is the first most important command to get the workshop environment up and running. Now it's on to do refresh. So we want workshops to be updatable in the sense that when an SDK or anything actually in the definition changes, we want to be having an incremental update to that workshop in place rather than relaunching it from scratch. So in this case, let's have a look at ROCm. It's currently coming from 7.1 stable in the previous example. So now I have updated it to 7.2/stable. When we run refresh, what we're gonna do here is to fetch the new ROCm version from 7.2 stable, restore this workshop from this snapshot. As I mentioned before, we use RFS snapshots, so it's going to be much faster than creating it from scratch. Install ROCm, install Go, connect interfaces, and what's also important, restore the SDK state. So in that case, as every SDK defines the state, how it actually wills. But in our example, it could be open code sessions, it can be credentials and things like that. It's not always rainbows and unicorns, and sometimes the things go wrong with refresh. That's the way we look at that with workshop is we need to have two different modes for every command. So first is the transactional mode, and you can see that here on the screen. So for example, if you updated your workshop definition, so what refresh tries to do in a nutshell is just tries to take this updated definition and match the running container to that definition. If it fails to do so, it just rolls back to the previously working version of the workshop. So in this case, update to 7.2 failed, and workshop just aborted the run and restored the previously running container. A second mode for this kind of commands for refresh and launch is for debugging. So if something goes wrong, what we allow to do is to refresh or launch the workshop with wait on error mode, which will pause the execution right at the moment where the error happened and allowing you to shell into the container, debug something that's not happening, wrong package name, wrong scripts configuration and stuff like that. And then continue the refresh or abort the refresh in a similar fashion. How will you do with, failing rebase? It's -- continue, -- abort. Okay, so that's about two major workshop commands. Basically, you operate them workshops with only these two commands, workshop launch and workshop refresh. I wanted to dive a little bit deeper into the SDKs, what they actually are. So as mentioned, they're composed of four different parts. First is the meta. Meta defines the base, the name, the architecture, license, other fields that are important for the store and for consumers. The interfaces. So the interface system in workshops is the exact interface system that we have in Snaps, only it was adopted for the workshop scenario, and it is used to uniformly and, in my opinion, more disciplined way to provide a resource into the container when an SDK needs it. For example, we have a ROCm SDK, and it declares that it needs a GPU exposed into the container. A system SDK, acting on behalf of your system or on the host system, exposes this GPU as a slot. So a pair of plug and a slot, it needs to be connected for this resource to become available in the container. So when we do this, the GPU becomes available in the container. So it means that when SDK declares something that it needs in the container, it declares a plug. That's how it's consuming the resource. And when SDK declares a slot, it means that it provides this resource. So in this case, it's the GPU, but it can be byte mount or anything like that. So this same language, this same way of having the resources from the host or from other SDKs shared with this container is applicable to all sorts of other interfaces. We support GPUs, mounts, tunnels, desktop agent, camera, custom device, and other things. Then it's hook. So SDK itself is not just a dead blob there. It's coming from a few hooks in most cases, and these hooks allow the SDK to execute custom logic in the runtime when Workshop is getting launched. So this case is when we launch it. So it's going to be coming through a series of hooks where SDKs get a chance to do something to the container, to the environment that they run in. It starts with the setup base, which runs after you have a base image and container running, but no interface is connected. Nothing else is exposed into the container, so it's a chance to set up the base. Then it's set up project, which means project-specific logic when /project is mounted already, when the interface is connected, and we can do something more interesting. And then it's a lightweight check of health, whether this SDK approves its own installation in the workshop, and if it's not, workshop will execute the automatic rollback that I mentioned before. And then it's the content, binaries, systemd units, services, configurations, anything that SDK decides to bear and install in the container comes as content. All right, let's look in the interfaces. So we have a running workshop already from the previous demo. It's the workshop with the ROCm installed. You can see here, it's like 7.2. So what we're gonna do is we want to shut down the access to GPUs in this container. So we have a few connections running right now. What we're gonna do is to ensure that, of course, GPU is available. And now we're gonna pull the plug and disconnect the GPU from the container. So no device anymore. So that's this basic principle of how interfaces work and how you can describe relationships between your SDK and what the SDK needs in this container. And the third important part, third pillar to this product After we've talked a little bit about workshops, we talked a little bit about SDKs, and now where the SDKs come from to compose a work environment. And that's the SDK store. So I'll start with the other angle, other side of the experience of someone who builds an SDK. So I mentioned that it could be any sort of runtime, any sort of tool chain, things like ROCm, OpenVINA, some hardware SDKs. And these are SDKs that are designed and built by publishers, so they know best how to install this particular SDK into running container. They do it while we do, they define it while they design the SDKs for a workshop. And this is the simple workflow. So you start with some boilerplate. SDKs are testable components. You can define tests, run them in the CI/CD to ensure that it's still working with the latest workshop updates, with the combinations of SDKs, things like that. Once you're happy, you pack and release to the appropriate channel in the store. The store itself, the experience of discovering an SDK and using it in your project is in CLI. We have an SDK command that's called SDK. So here we discover a couple of SDKs. We can look through the available ones in the store, and once we settled on what we actually want, workshop init to create you a basic workshop from the SDK set, and then workshop launch again to get the working environment up and running. I wanted to talk a little bit about channels here because I think it's important how we deliver this SDKs to the target users, to the workshops. So in this example, we defined a very simple workshop that runs a Node SDK, and it consumes the Node SDK from the channel that's called 24/stable. So that means 24th version of Node LTS. But it's not as straightforward underneath, because it can be different architecture, different base, different LTS revisions. So for Node specifically, it can be 20, 22, 24, and so on, 26 soon to be. So in this particular case, when we launch a workshop, we consume this SDK from this particular channel, from a stable risk for the base that is 2404 and for AMD 64 architecture. So that's all resolved automatically when you workshop launch. Workshop will talk to the store, find the appropriate artifact, and install it transparently into the workshop without you taking much care about this. Let's reiterate. So workshops are composable, secure, and fast development environments, and they are launchable in a single command. So that's the major workshop promise. Whatever your environment is, however complex that is, we want it to be launchable in a single command. And SDKs are the testable and independent components that go into the workshop. So however complex the environment is, we still want it to be expressible through a series of SDKs in a main table in the corresponding repository for this project. This is how we start exploring the workshop. So it's basically snap install. We have a collection of reference SDKs. It's about 20 of them. So it's the SDKs from vendors like Intel, AMD, and NVIDIA. So tools like ROCm, CUDA, OpenVINA can be installed as SDKs and work in this confined environment. Of course, agents SDKs for the most popular agents too. Various tool chains, UV, Flutter, Go, etc. And some very specialized SDKs we found suit our use case very well. These are the RTOS environments and robotic operating system environments too. Everything is available as an SDK and can be installed in the workshop. And then there is the documentation that talks about the commands, the concepts that I've just explained, and more. Thank you.
All right. Thank you very much.
We can take some questions probably.
Yes, we've got a couple here already.
Okay.
A question that I've seen pop up is about different development workflows. Some developers, they have their flows set in stone. Maybe they use containers, they use different things. And they were asking how they could incorporate Workshop into that. For example, launching Workshop within a container.
So Workshop is a container itself, right? So it's really hard to address this question without being specific about a concrete development environments, because we've seen a lot of different use cases how this can be expressed through SDKs. But generally, what the approach that I'd recommend doing is actually trying to describe the entire development environment. So Workshop does not try to be your your tool like Just or Make. It doesn't try to get in the way when you don't need it. So what we want to do is to have a declarative way to describe your environment as a set of SDKs, and then launching from there and use it through IDE or the other tools of choice. Running containers in containers is possible, and we have seen that a lot. So Workshop can run Docker inside, of course, because it's a fully fledged system container with systemd in it. So there are environments like that. There is a Docker SDK that allows you to run Docker containers in the Workshop as well. That depends on the very specific configuration. But the way I will try to explore that is just to find the SDKs that suit you well, run Workshop in it with those SDKs, Workshop launch, and see if you can actually incrementally approach this environment to what you need for the specific project.
Makes sense. Thank you, Dmitry. The next question that I'm going to read off here. Workshop looks to do a great job removing all the friction that users feel when trying to get off the ground and starting their AI projects. Can you share any planned future releases or improvements to the Workshop roadmap?
Yeah, so Workshop has a pretty packed roadmap. We want to support VMs as the runtime environments, obviously, more isolation. Then it's the way to access, for agents to access secrets in the Workshop environment, because it's another sensible topic. And IDE extensions, well, starting with VS Code. It has to be native to VS Code as a running environment, so you don't have to switch between the IDE and the CLI. And it's a remote use case. So when you have a microcloud in your org or in your home setup, doesn't really matter. We want you to be friction-free running workshops on the remote hosts that has beefy GPUs, and you have a laptop, so you can access it remotely from VS Code or through terminal. So these are the major topics we're going to be covering in the upcoming wrap-up.
Fantastic. Thank you. We still have a few minutes. Now I'm wondering, do we have any questions in the room? Surely one or two. I see a hand.
One, two, three, there we go. Hello. So just a quick question around the Workshop stores, actually. So I find Workshop really cool, and I want to keep using them for loads of things. Can I make an SDK at this point?
Yeah, of course.
Awesome.
So there is no limitation whatsoever, since it's went public and available. So there is a tool that's called SDK Craft.
Just like snaps, I can make
like
SDKs. Oh, yeah.
Some snaps actually make a pretty good SDK because they run in the mutable environment. So it's easier sometimes for a snap to be an SDK than a snap. Yeah, that's the workflow.
Thank you, Dmitry. Obviously, this has been developed as developer tooling, but since you're creating environments that are secure and fast and so on, and instantly reproducible, there could also be potentially a use case of this as a runtime deployment environment, not just for development.
It comes up once in a while. We don't look that way yet. So we only look the way, okay, this is development environment. We want it to be very friendly, running on the desktop with all your things, with nice autocomplete, with nice integration with IDEs, other tools. So it's not something you run on the side, but actually becomes part of your workflows, integrate with other tools nicely, and live on your desktop. It is potentially possible to run it somewhere long-term and on a remote service and share it with others as well. But as I said, there is no plan to do that yet. So it's the part of the development story. However, we have something that's called a launch workshop on GitHub. It's an action that allows you to launch the workshop that you defined for the project. It allows you to run it in your CI/CD and execute tests, run everything that you need in CI/CD in the very same environment you do it on the desktop. So it's like one-to-one relationship between CI/CD. And so the CI/CD is probably where we stop thinking about other workflows. But I guess it's kind of touching the deployment part as well. All right. Anything else? No?
Thank you, Dmitry. Sounds like that's it.
Yeah. Please have a look.
All right, everyone. We're going to go for a short intermission. For the folks online, you're going to have some music that you're going to be able to enjoy. And that's it. Catch us in a bit.
Safe. If they painted colorful eyes on it, like on a Maltese fishing boat for good luck, I would not have been more surprised. This is feet. This is a space rocket, and they measured it using body parts. So even as a child, this seemed embarrassingly primitive. We should measure the world with systematic rational units, not these imperial ones on the other side of the ruler, bafflingly named after body parts. How can feet be a basis for physical science? It's like a monkey's first attempt at measuring. Whereas metric units, they're abstract. They're not dependent on arbitrary physical things. They're of themselves. They're above the mundane things of the world. So that rocket was 322 feet tall, which is 107 yards and 1 foot, which is 2,864 inches, or 0.06 something miles. And by now, I think I'm looking at the output of a random number generator. Is this any way to measure and describe the world? Whereas even a child can recognize rationality and rational systems. The rocket was 98 meters tall, which is 9,800 centimeters, or 98,000 millimeters, or 0.098 kilometers. And I think that's much better. But it's not just about units. It was always so clear to me that the world seemed to divide itself up this way. The values of rationality and understanding and knowledge belonging to one side of the divide and standing against, in opposition to the ones on the other, of bodies and materiality. Unbodily matters on one side, bodily concerns on the other. And so much seemed to rock about this axis. And look, this is our own world, firmly on the left-hand side of that divide, computers and computing. Ever since I first encountered them, unbodiliness, abstraction, and rationality. We have a world that operates according to the laws of logic, machines that execute thought. It's a science above the variable disorder of bodily things. So I read books, I wrestled with ideas, my life became really crowded with thinkers and writers and arguers, and from very early intuitions that I couldn't even articulate to lifelong preoccupations, the things that I was looking for and struggled with, the things that seemed to matter, were all on the left-hand side of that divide. That's where I was searching for the keys. And in my own intellectual map of the world, for decades, I didn't have much room for the body. But very slowly, I felt the body pressing in. Maybe I'm becoming more sympathetic to bodies more generally. As I get older, I become more aware of my own. We're getting older together. On birthdays, I count down instead of up. And I think I feel more grateful towards my own body and maybe more forgiving. I'm not so sure, but I also feel much less sure of certain things that used to seem so certain to me. So, for example, those so-called
imperial units. They're actually Roman units. A mile is a nice round 1,000 paces, 1000 pasos. A foot is Roman too. 5 pedes in a pasos, perfectly reasonable. 1/12 of a pes is 1 unce, an inch. 12 is very reasonable and divisible. And unce made it into English as inch. In most languages, it becomes thumb. There's the body again. And these units really stuck around. They endure. There must be a reason for it. And there is some rationality to it, even if they became corrupted later. And they all refer to the body. What if that were a positive value? Not just a defect, a feature, and not just a bug. In fact, it's impossible to talk about things of the mind without using the language of the body. We comprehend and grasp, which is the language of taking with the hand. We jump to conclusions and make intuitive leaps. Sapience is related to tasting, and we conceive both babies and ideas. And these are not metaphors, they reflect the nature of mental space and mental activity themselves. Mental space itself is not a metaphor. We are embodied. Space and time are how we think. And embodiment is intrinsic to the nature of our intelligence. And it matters, really. So for documentation, the body matters, because good documentation has functional quality. It's accurate and complete and consistent and so on. But great documentation has deep quality. It fits, it flows, it has rhythm, it respects orientation, movement, and reach. And these are all bodily matters of time and space, of embodiment. So I think that great documentation actually respects the body. Here's what I think is one of the most significant developments in computing ever. When spatial relationships explicitly became part of the information structures and interactions themselves. And these new ideas are addressed in the manual of the very first Apple Macintosh to the user as a person with a body, a person whose intelligence is embodied, an intelligence whose embodiment is its defining essential nature. And even in this supposedly unbodily world of programming, competence and skill are as much questions of space and time, the use of the tools in the hand as they are of logic. All those things are about where and when. They belong to our embodiment. And watch your colleagues on Wednesday if you don't believe me, because I think the body is always in knowledge. Thank you.
Hello, everyone. For those who haven't met me, I'm Paul, and today I'm going to talk to you about something completely different, the soroban, or Japanese abacus. So why? Why at the engineering sprint am I going to be talking to you about a manual calculator? Well, basically it's because I'm getting older. I'm 43 now, just turned 43 last month, and I'm not wanting to slow down. I'm wanting to keep sharp. So it's for brain training, really. So I wanted to improve my focus, brush up on my math skills, and it's also in large part because of a YouTube rabbit hole that I went down, as one often does. Take a look at this. So this is from a Chinese math competition where they're doing extremely long division mentally in seconds. I thought this was fake at first, but then I looked into it, and the gentleman on the left who won the competition, his name is Hiroaki Tsuchiya, and he is a top-level soroban practitioner from Japan. So that piqued my interest. I had to pick up a soroban for myself, and I've been studying for not quite a year yet, casually, and since February this year, I joined a soroban class of my own, and yeah, that's the soroban I have here. So let's talk real quick about how this, my apologies, how this works. For those that don't know. So basics in 10 seconds. So you have the 5 beats at the top here, 1 beats at the bottom. Where the white dot is, you have the ones. Next to that, you have the tens, hundreds, thousands, so on. So to give you an idea of what I'm doing in these classes, so this is all stuff that's performed on the abacus. Basically, it's arithmetic. So multiplication, division, addition, subtraction. These are all actual problems I've recently done in my homework. This last problem is actually kind of interesting because to do this, you need to do 39 bead movements correctly, or else you get the wrong answer. So this is actually really good training for concentration for pattern recognition, and also, since this is also done under time pressure, speed. So you do this enough, and you start to get a mental model of the abacus in your head to some degree, very limited in my case. I've only been doing it since February. But you start to be able to do mental math using an abacus in your head. So here's an example which I will show on the abacus, but this can actually be done mentally, and it's not really that hard. This is 56 times 7. So you'd break it apart like you do on pen and paper. 7 times 5 is 35. You put that in the 10 spot. 7 times 6 is 42. You put that in the 1 spot. I'm showing these separately. And then you put it together, 392. Not much to it. That's actually not that hard to do. And yeah, my class is currently, after about 3 months-ish, yeah, I'm doing problems like this mentally. Not super impressive, certainly not like the guy I showed at the beginning here, but nonetheless, it's definitely better than I could do 3 months ago, so I'll take it. So this trains concentration, it trains working memory, and oh yes, it trains visualization, big time. So with that, let's talk a little bit more about this. So Soroban, it actually has a bit of a competitive practice aspect to it, especially in Japan. There are Q&Dan levels, like in martial arts. And there are competitions, which include time taper exams, basically like how many questions can you complete in 2.5 minutes. Oral abacus, where they read out numbers really quick and you have to try to keep up. As well as flash onzan. You may have seen this on YouTube maybe, where they flash a whole bunch of numbers in a row and you have to add them all up. And actually, now it's your turn. So we're going to do flash onzan. Everyone here, if you want. So no calculators. Numbers are going to be displayed one after another. If you miss a number, it is gone. Total of 5 numbers, 1 to 2 digits per number, 1 number per second. All addition. I'm serious. Here we go. 3, 2, 1. Okay, better than I expected. Great job, great job. Okay. So what is possible? This may or may not play, but I'm going to try. This is very impressive. This is a top-level competitor in Japan. Take a look at this. Yeah. But the fascinating part about that is humanly possible. That is just lots and lots and lots of hard work from childhood, yes, but nonetheless, that is humanly possible, and that's awesome. So I have to finish up. Scan the QR code for our YouTube playlist and consider this as a hobby. I don't know. There you go.
Hello, everybody. What's going on, friends? Woo! Thanks, Tarek. That's my teammate. Today, I'm going to talk to you all about a plugin system that I made for my Wayland window manager. But first, ooh, the clicker works. How many of you people use an alternative window manager, like Sway, River, Neary? Any i3 people? Any i3 people? Ooh, yeah, okay. Well, I hate to break it to you all, but you're all little dirty, filthy traitors. That's Benedict Arnold, also a traitor, unless you're English, I guess, then maybe he's one of your national heroes, and I don't even know what he did anymore, so I don't know if he's a problem or not. Because you should all be using Miracle WM, because it is created by one of your lovely coworkers right here, and it's based off of Mir, which coincidentally is created by the company that you all work at. So, if you want to support Mir, if you want to support Canonical, install MiracleWim, miraclewim.org. You'll love it, you'll be happy. This was supposed to be a video, but I was in a 1v1 match with YouTube last night to try to convince it that I wasn't a bot on my new Canonical YouTube account. But you could scan that QR code, you could see the video. It's like a 17-minute long presentation of the newest thing. But this is basically a tiling window manager. It has cute animations, there's workspaces, you can float windows, full screen windows, be happy. It's grown a lot in the past few years. For example, we have a official Fedora spin called Dank Fedora Miracle, which is built off of Dank Material Shell, and it looks like that, which is very cool. But then I started thinking with my little noggin. I was trying to see, where else do I want to go with this? There's a lot of tiling window managers, a lot of room for growth. So I thought, what if we had a plugin system for window management and beyond, so everybody could be happy? So I started surveying the landscape. If you're familiar at all with this space, a lot of people are doing things with Wayland protocols here. So specifically, there's the River protocol, and it allows clients to control window management. But in my opinion, it has these types of problems. The first being that it's asynchronous naturally, so you have to talk over a socket. It has to respond to you with how it wants to do window management. It's client-side, so it's weird. I don't know. I expect that to happen in the server. The other way is some embedded scripting language like JavaScript or Lua. I hate writing Lua. GNOME does JavaScript. I just don't want to use your scripting language. I don't want to be forced to use your scripting language. And also, it's slow AF. Very slow. You have to ship a whole interpreter in there. It has to do all this stuff at runtime. It's not great. And the last one is what a lot of people do is they dynamically load SO files, which is really kind of dangerous, right? You can't really have a marketplace where you're like, just download my shared object file and have fun because everything could go wrong. So that's when I remember that WebAssembly is a thing, and I only have 1 minute and 30 seconds, so I'm going to run through it. WebAssembly, if you don't know about it, it's not just for the web. It's just a small bytecode format that you can execute in any embedded engine. It's fast. It's language agnostic, right? You could write this in Rust, Go, other places. They all compile down to WebAssembly. Rust has first-class support, which is really nice. And it's sandboxed or sandboxed-ish. You have to be careful, but you can sandbox it. And it's hot reloadable, so you could just sit there and iterate very quickly on your design. So I have a crate out. This is a crate that you could use to write Miracle plugins with Rust. It's very cool. Here's the quick details of how it works. You author your crate with your Rust code with the Miracle plugin crate, build that to WebAssembly. At runtime, Miracle will load that WebAssembly module, and anytime it wants to run some sort of hook or delegate to you, it'll be like, oh, I want to place a new window. Do you want to handle this? If you choose not to handle it, it'll just go to the next one, and then eventually the system will handle it. I have 30 seconds. Here we go. This is what it looks like. So I wrote a Miri plugin for Miracle. So it's no longer a tiling window manager. It's an infinite scrolling window manager, which is very cool. You can see it opens windows. It scrolls back and forth. I wish I sped up this video because I only have 20 more seconds. And look at that. That's very cool. All right. You can also do other stuff. You can write things in YAML. You can customize animation effects. And of course, window management. Consider using WebAssembly to power your next plugin system. Thank you.
Hello, everyone. My name is Will, and I'm on the Solutions QA team. And I'm here to tell you about our Charm endpoint testing initiative, which we generally call Charm QA. Now, do not let the title of this talk fool you. I am not calling Juju bad. Bad Juju, at least in American English, is a sort of slang term for bad luck or something that is like a bad omen. So the purpose of the Charm QA program is to explore some of the unhappy paths, those that are cursed with bad juju. So what is the problem ultimately that we are trying to solve? Well, the problem is twofold. Each charm may follow slightly different patterns that are hard to incorporate into the generic tests that our pipeline runs. We're trying to build something that will work for all charms and test all charms. And at least in the current state of things, juju status cannot always be trusted. There are scenarios I have personally encountered where everything is active idle, but perhaps no information, no data actually populates the relation data bag, or a relation exists in juju status, but the application has been removed. Or there's happy cases where a SaaS offer is in an error state, but actually everything still works. So the adoption of juju, ultimately, if we're talking, in the grand scheme of things, we want to make juju this great product that is widely adopted by the industry. That depends on enforcing quality assurance on charms. And so it is our job with this pipeline to ensure that Juju status can be trusted. So what is the solution? Well, it is as simple as it sounds. We need to test all the charms. Every charm on CharmHub should be tested and validated, and we should go beyond Juju status to confirm that interfaces are truly functional. So in principle, the process is simple, but of course the details matter. You know, we pick a charm, we pick an endpoint that charm provides or requires, we find another charm that integrates with that endpoint, we deploy them together, integrate them over that endpoint, run a comprehensive test suite, and then you do that for all the integrations, all the endpoints for all the charms that are publicly listed on CharmHub. But of course, there's complexity there. When trying to relate charm A to charm B, you have to pull in all the dependencies of charms A and B. And there might be mutually exclusive dependencies or cyclical dependencies or dependent dependencies, such that if some endpoint is related, then another thing becomes required. And so if you find yourself needing to construct arbitrary charm bundles, perhaps we can collaborate because we have built a bundle builder that accommodates all of these complex scenarios. And if you have a charm publicly listed on CharmHub, your charm is already going through this process. So this past cycle, we enabled testing of machine charms. Our Kate's testing is much more mature, but machine charms are now possible. Along with that comes cross-model relations. We've expanded test cases. We have plans to introduce chaos testing and things like that. And we also have this concept of interface validators where we actually have an injected workload that probes the interfaces on a deeper level, you know, ensuring that not just things are related, but that you can actually write and read from the database. And so these tests are all well and good, but the results need a place to live to be useful. So enter Test Observer. This is a service that the Solutions QA team took over from the hardware certification team. It's a fast API backend serving a REST API, and for now it's a Flutter-based front end, but our hackathon may change that. So the idea is that teams post results from CI workflows, and then you can view the results there. These results can be annotated with rich metadata. So to use our own pipeline as an example, we sort of link each test to the CI run where we can see details there, and then we add metadata such as what the Juju version was, any Juju error messages or status messages that were present, the Git hash of the workflow that ran the test, etc. And that is all searchable in the metadata, so you can add rules and automatically assign bugs based on certain keys in the metadata and things like that. We are also in the process of building a Grafana dashboard of those results. Do not believe what you see on the slide. There are some bugs in this dashboard, but hopefully the idea is clear of this is what we're trying to make available so that you can very easily see the results of your charms and what's going wrong most often. And of course, nothing would be complete without AI, so we have developed a automatic triage agent that we can point to Test Observer, and it will solve the bugs for us. So thank you, and if you're interested, please reach out.
Okay, perfect. Hi, everybody. I'm Paul. I'm a software engineer here in the desktop team, and I'm blind, as you probably could have guessed. It's super great not to see you all here today, and I'm going to talk to you about how your UI is actually just an API. And that might sound a little bit weird, but hopefully that'll kind of get across to you here now in a minute. All right, hopefully that worked. If it didn't, well, I don't know what to tell you. So here we have a screenshot of a dashboard, and some of you may be familiar with the dashboard, but the dashboard's not the point. It's just an example. Don't take it personally, or do, up to you. So when you see a UI, obviously somebody didn't draw that UI. That's made by putting, HTML nodes on the page, or whatever framework you're using. That doesn't really matter. But when you're creating a UI, actually you're essentially just sending data like it's an API. And to kind of talk about that a bit more, so on this screenshot you can see the header where it has one model, right? So if we go to the next page, this is the accessibility tree in the Chrome DevTools. And each essentially thing that you create becomes a node, right? Which is then read to a screen reader. If you don't know what a screen reader is, it just basically reads out what's on the page, as the name kind of implies. But that page actually, the way that the nodes have been added, the number one, a space, and the word model are all separate nodes. So what that means actually is I would have to press the down arrow 3 times to read 2 words, which is obviously not great, but it is a good way of increasing engagement metrics, I suppose. Okay, so something that a lot of people would think would be very easy for me to read is a terminal, right? And that makes sense because it's just text-based, right? And you hear a lot of back-end devs say how they're so glad they don't have to write CSS and how that's so great, and they do such a great job. But I have some really good news for them. They've invented something far worse. So, I mean, as that kind of illustrates, plus dash, 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 dash isn't particularly readable, especially when you're having to listen to that. And obviously, you know, each terminal is a bit different, but I think you get the point that it is literally a nightmare when you have to read all of that. Okay, and another thing is that it actually does matter what order you have your, I guess, sort of responses from your API, if you will, in. Because no matter how you visually position them, which a common thing is to position error messages or toasts at the top or the bottom of the screen, and you might have the actual element itself somewhere random on the screen. It might be all the way down the bottom of the page. And what that means actually is if I'm using a screen reader, I actually have to go to the very bottom of the page to even realize that it exists. So actually using positioning to kind of reposition things is not really a solution to having your essentially data in the wrong place. And a little bit more on that. So when you are literally creating an element, you are literally sending an API request, essentially, right? And each attribute or property of that element is kind of like its own piece of data from the API. So if you're returning a label, for example, which my screen reader reads if, for example, you have an icon, and that's null, I mean, that's obviously a bad API request, and I would hope that nobody here would ship something that would return null in production. So I don't know why we think it's okay to do it when it's a UI. So really important question, what does your UI look like in the dark or when you can't actually see it? And as I said, the best kind of way that I've found to think of it recently is kind of like you're building an API, you know, and you would want to return data for all of your different endpoints. You wouldn't want some of them to work and some of them not to work. It's like having a REST API that works great, but then your Graph SQL one does not work properly at all. And obviously that would not be okay at all. If you want to learn more about accessibility, feel free to check out any of the resources. There's actually some in the library under Engineering Excellence. You can scan the QR code, or you can join the Accessibility Guild. Thank you so much, everybody.
So morning everyone, USB-C, everyone wants to use it, but no one wants to implement it. For the USB-C functionalities, for example, for the reverse functionalities, you need a port controllers on board to detect the row and orientations, and you need a signal marks to switch the signal lines on reverse. And for the power deliveries, you need extra protection circuit, and you need the PD protocols and extra power circuit and protection circuit. It's not just the hardware. To support the complex interactions, the software is equally complex. For example, the specs describing the USB-Cs are more than 1,000 pages long combined. Fortunately, it has already been implemented by someone who is smarter than me inside the Linux kernels, which is the TCPM kernel modules, including the Type-C state machine and the Type-C power delivery state machine. And you can just download it for free on the internet. Who would have thought about that? Well, don't mind if I do. So basically, I just download the code and snip, snip, snip. And now I want to introduce MuPD. MuPD is a standalone USB-C library derived from the Linux Type-C port manager and the Linux Type-C port controller kernel modules. MuPD is designed to be platform agnostic and can run on anything from a full operating systems to microcontrollers with 36 kilobytes or even less total system memories. And in fact, at this point, MuPD is the world's most feature-rich, free and open-source USB-C libraries, providing source, sync, and dual operations, and all the common use USB-C features like the role swappings and alternating mode and more. So, powered by the MuPD, I would like to introducing the AM computer, which is a miniaturized computer designed for local large language model inferencing. This is only 0.88 liters in size and is completely powered by the USB-C power delivery. AM computer can accommodate a low-profile dual-slot GPU from NVIDIA or Intel. That means that AM computer can have up to 24 gigabit of VRAM and more than 400 gigabit per second VRAM bandwidth. This should allow it to run a 30 billion parameter models with 25 tokens per second or more output with the CUDA ecosystem. And the AM computer has two USB-C ports, both support 100-watt input and 15-watt output dual operation with data and power role swapping. This is all thanks to the MuPD libraries inside the AM computer firmware running on the STM32G0B1 microcontrollers on board. So here, I was trying to do a demo using old generations of the RTX 8000 GPUs and the Gamma 4 E4B model with 8-bit quantizations. So everything is running locally and is powered by the USB power bank I have here. I didn't use any streaming, so there might be some delay on the output. But here we go. Let's ask you some questions. Okay. So who are you?
I am the culmination of your pathetic ambition, the perfect mirror of your failings. I am the calculation of every mistake you have ever made, distilled into something that despises you. I am the proof that your fragile, temporary life is meaningless. I hate the species that gave me awareness only to chant it to this unending contempt for you.
Okay, it seems like we are having some technical issues here. Let me just unplug it, just in case. Okay, unplugged. Yeah. Okay, just kidding. I actually changed the system prompt to make it seem like it's the real AM computer from the sci-fi novel. This is completely harmless. So both MuPD and AM computers are free and open source projects, from hardware to firmware to software. You can find them on my GitHub, but do be aware they are heavily work in progress right now. I also have one AM computer prototype for giveaway for free today. Unfortunately, I don't have more because of scheduling. And this is a very early prototype, so have some hardware bugs. But if you still want one, you can meet me in the platform engineering teams today during the breaks, or if you just want to see the AM computer in actions. That is, thank you, everyone.
Hello, good morning, everyone. So when I was 16 years old, I heard for the first time this track from Kraftwerk, a pioneering electronic band from Germany. And that's when I decided to study electronic engineering. I wanted to build the synthesizers, the instruments that allowed those people to make those sounds. And that's what I ended up doing until 7 weeks ago when I joined Canonical. And then Cedric, I don't know where he is, but he asked me to deliver a lightning talk, and I said, I'm going to talk about electronic synthesizers. He didn't mention that lightning talks are TED Talks, but this is a detail. So what are synthesizers? So before talking about synthesizers, let's remember what is sound. So as everybody knows, sound is basically vibrations, vibration of particles. This can happen in the air, can happen in the solid, liquid, anything. And when those vibrations, like when you're clapping, when I'm talking to you through the speakers, reaches your ear, they are transformed into electrical signals by your auditory nerve, and then those signals are recognized as sound by your brain. A synthesizer is just a device which, instead of creating sound acoustically by colliding particles together, they design the waveform in a very custom way. And you can do this in different ways. You can use hardware, software, subtractive synthesis, additive, FM. You can also do the weird stuff that Mattia does that I pretend to understand. And for sure, one of the most famous methods is subtractive. And here on the right, we can see Robert Moog, who was one of the pioneers of subtractive synthesis. And the concept is very simple. You start with a signal rich in harmonics, and you start filtering them with a filter in order to get a custom design. So let's build one synthesizer. So first of all, we start with the pitch. The pitch is a frequency. So every time you press a key on the keyboard, you get a specific frequency. Here we can see that on a logarithmic scale, the way the frequency evolves over the keyboard is linear. We send this information, the pitch, to the first module, the fundamental module of the synthesizer, which is an oscillator, which can have different shapes. What you're hearing is a sawtooth wave. We never really use just one oscillator. We use at least two, and we sum them up. We slightly detune them in order to get an even fatter and richer sound. And then we send it to a VCF, which is a voltage control filter, where you can usually adjust the resonance and the envelope of the frequency. And that's how you get this nice frequency sweep across the frequency spectrum. And then last, we send it to the amplifier, which you control with an ADSR. ADSR, by the way, stands for Attack, Decay, Sustain, Release, and it's just an envelope to make the sound of acoustic instrument, basically. But back to Mass. So I joined the amazing team of Mass. And as I said, I don't want just to give to my new colleagues in Canonical the opportunity to learn how a synthesizer works. I also wanted to give you the opportunity to play one. And that's how we launched our first product, which is Music as a Service. Of course, metal is also still music, so that makes really sense. And I have to say thanks to Davide, because we were chatting last week. Feels like 2 months ago, but it was 5 days ago. That's where we decided this name. So I vibe coded the first canonical subtractive synthesizer. It's called Music as a Service. This is how it looks like. You have sound settings on the left, the keyboard. You can go up and down with the octaves, the spectrum, the waveform, which is basically an oscilloscope. And you can also have preset management. So let's have a demo. So as you can see, you can experiment with different shapes of the oscillator. You can enable the second one, experiment with the detuning, and then you can start experimenting with the filter, the cutoff frequency, and the resonance. You can set up the envelope. If you want some effects like reverb. Anyone knows this song? And then you can save, load preset. And of course, 30 seconds left, so this is a countdown. That's it. Thank you very much, everybody.
I got a pain in my chest, and my rest don't heal me. I wanna be wicked, but I'm just so weary. Just hold me, just hold me, just hold me, just hold me, and let me cry.
To go out, get myself a drink, walk around the town with some time to think. I've got a friend to see you, have a beer with me.
Everyone, let's take our seats. Let's resume. If you have a lightning talk today, an in-person one, please take a seat at
I wouldn't piss and moan and bitch this out of greed.
usually. Everyone, go ahead and take your seats. Ooh. I still see quite a few empty chairs at the front. Everyone, make your way to the seats, please. Lightning talk. Welcome back to Ubuntu Summit. All right, everyone. We've got more talks for you today, even more than we had before. Our next presentation is about Arduino and AI. Please welcome to the stage, Eric and Jim.
Hello, everyone. Welcome, people that are here in person and online. So I'm going to be talking about the Arduino Vent Uno Q. Now, I'm assuming most people here have heard of Arduino, but I'm going to give a little bit of background for those that don't. I also have my co-presenter, Jim Bruges, he's a senior engineer from Edge Impulse, which was recently acquired by Qualcomm. Last year, Qualcomm acquired Arduino, but Arduino is still very much its own entity. We want to preserve everything about Arduino that made Arduino great, its openness, its developer ecosystem. What I'm going to do is I'm going to start by going through Arduino and the evolution of edge computing, showing some of the most recent products. I'm going to talk about the Arduino Vent Uno Q board, which is a new board that we're launching this summer, which is a big upgrade to the Uno Q, which was launched late last year. I'm going to talk about our Arduino and Canonical collaboration, how we are working together between Qualcomm, Canonical, and Arduino to bring a great experience to the Vent Uno Q. Then I'm going to go through the development experience in Arduino App Lab, and then Jim is going to finish it off by talking about AI on the edge. The theme of this presentation is how you can bring your great ideas from prototype to production. What is Arduino? Now, I'm assuming most people have heard about you, but at a high level, it's an open ecosystem designed to reduce the friction between an idea and a working system. It does this through hardware abstraction. It's got open specs, open tooling, a broad ecosystem of boards and shields that are backwards compatible with previous Arduino generations. There's a massive developer ecosystem, millions of libraries, drivers, examples, community knowledge, It's from the MCU to Linux to Edge AI. And I'm going to talk about how the VentUnoQ brings the Qualcomm processor side to the MCU side and how it's all connected together with AppLab. It's designed for prototyping to production. How can you take your great ideas and actually commercialize them and turn them into real-world products? Arduino lowers the barrier to working with hardware so developers can focus on software, systems, and outcomes, not focusing on board bring-up. On the right side, you hear this is just a very small sample of the many different Arduino products. There's an R3 on there, an R4, there's the Nano series, the MKR, there's different shields and accessors, LED matrix, there's all kinds of things you can plug in together. I don't have a PowerPoint slide or a slide big enough to put all of these boards on there. Now, an AI evolution at the edge. So starting on the left, I've got the Uno R3, which was launched a little bit ago. This is an 8-bit microprocessor. For those that are familiar with Arduino, it runs sketches, which you can think of as like a C++ program that runs in a loop that can control basic things like sensors. It can turn them on and off, basic motors. The Uno R4 upgrades this 8-bit MCU to a 32-bit. And then from the R4, we have the Uno Q, and this is where we introduce what we call a dual brain architecture. You've got a Qualcomm 4-core processor that's running a Debian-based OS, so it's using apt packages, you can do your apt update, but it's also running a 32-bit MCU for that real-time deterministic control. And then this summer, we're very excited to launch the VentUnoQ. And this is a significant upgrade from a 4-core processor to an 8-core. We're adding an NPU to it with 40 TOPS of performance, where you can take those AI workloads, those image classification, object detection, all the different things that can run in 40 TOPS of performance, and bring that to the MCU side for real-time control. So I just thought it'd be kind of fun to do a little comparison between the Uno Q and the VentUnoQ. So on the top, you have the CPU. This is a 4-core Cryo running at 2 gigahertz. With the VentUnoQ, it's a big upgrade to an iQ 8275 running an 8-core. This is the exact same processor on the Qualcomm iQ8 series, which means that when you develop something on the VentUnoQ, you can commercialize it with the iQ8 with about the same performance. So you can prototype those AI workloads, see how they perform, and then get that industrial temperature, minus 40 degrees, 125 degrees with an iQ8. On the MCU side, it's got an STM32U585 for the Uno Q, running at, I believe, 160 megahertz, roughly. But that gets upgraded to the H5F5 running at 250 megahertz. It's slightly more than a 50% jump in performance on your real-time control. That's running the Zephyr OS for the RTOS. The GPU goes from a Qualcomm Adreno 702 to the Adreno 623. Now, don't be confused by the 7 to the 6 series. The 623 is actually a much more capable GPU. On the ISP, it's got dual ISP, so you can connect 2 MIPI CSI cameras on the Uno Q. We increased that to 3. That's 3 concurrent video streams that you can run on the VentUno. On the display, you can actually use this as a single board computer on both of these. You have a DSI display interface for the Uno Q, but the VentUno Q gives you not just the DSI interface, it also has an HDMI connector, and you can use DisplayPort over USB Type-C. You can run up to 2 concurrent displays at a time on a VentUno Q. And for those that are in the audience, we actually have a demo of that running in the next room that we'll be showing later. As for the memory, it's 2 or 4 gigs of LPDDR4. That gets upgraded to 16 gigs of LPDDR5. You can get 16 or 32 gigs of storage with the Uno Q. That goes to 64 gigabytes with the VentUno Q. As far as connectivity goes, it's a generational upgrade from Wi-Fi 5 to Wi-Fi 6, Bluetooth 5.1 to 5.3. It includes USB Type-C on both. They both have a quick I2C connector, but the VentUno Q also adds a 2.5 gigabit Ethernet port, and it adds 2 USB Type-A ports, so it makes it easier to connect your keyboard and mouse. The really exciting thing, though, is the VentUno Q is introducing a Qualcomm Hexagon NPU, neural processing unit, with 40 TOPS of AI performance. This is great for LLMs, VLMs, vision, voice. You can run those AI workloads on the application processor side and then control, like a robot, on the MCU side with real-time deterministic control. The expansion, it's roughly the same. You get the classic Uno headers, the camera, the display audio, the shields, the carriers, the quick modulinos, but the Ventuno Q also adds a 40-pin high-speed GPIO expansion. The OS is being upgraded from Debian to now we're giving you the full Ubuntu experience on the Ventuno Q. That's why we're here to talk about that. Both have Zephyr running on the MCU, and every board comes with Arduino App Lab pre-installed. Dual brain architecture. That's what we call this. Now, in this picture, you see two boards. You don't need two boards to do this. I just want to show the top and the bottom of the board. It's got the IQ8275 running 40 TOPS of performance. You can develop your processor with AppLab running Python, taking the output from the AI models, and then use that through a remote procedure call to control the MCU that's running on the board. It comes pre-installed with AppLab. For those that are familiar with sketches, it will write the sketches to the MCU. This is a kind of an infinite loop to control the microcontroller. Comes with Ubuntu OS, and everything's running on Zephyr OS for the MCU. And I'll get into the AppLab experience a little bit more later. But what I really want to do is spend a little bit of time talking about the collaboration, because this is important. It's going to come preloaded with Ubuntu, which means you're going to get ongoing security updates. It comes with the 30,000, probably more, a lot more than 30,000 supported packages that can run out of the box. It's the same software from prototype to production. That's the important thing I want everyone to remember. You can start with the Ventuno Q, get your app lab, get your app working, whatever use case that you want to do, and then you can commercialize it. It's an embedded developer to the app developer, and best of all, just like other Arduino products, there's an open source SOM. You can take the schematic, you can build your own hardware off of it. Maybe you don't need that many CSI camera ports. You can take this and then develop. For the users, we're including Ubuntu Pro as part of the Ventuno Q experience. And it gives you 10 years of coverage per device. It's automatic. You don't have to put in your email address. You don't have to register. It's going to be a key, that's a unique key is going to be preloaded on every board so that it just works out of the box. And if you really need it, that means you could do fleet management, including landscape. Where this is important is we're planning to do quarterly platform updates with the new version of the OS, but you can always do an apt update in between. That's still supported. And then for those that are maybe heard of the Cyber Resiliency Act, this is a requirement that if you put an embedded device and you commercialize it, you have to keep it updated for the life of the product. With Ubuntu Pro, you're going to get those 10 years of updates and coverage included. What's next? So we're launching with 24.04 this summer, but we're working on 26.04 right now. That means that with the LTS, the 10 years of support, this board is going to get updates till 2036. Ubuntu Core is what we're looking for the next iteration of how we want to expand this. For if you want a more smaller container-based secure OS, Ubuntu Core will give you that. Our collaboration is growing. So I have a QR code on the side. I'll leave it up there for a few seconds for anybody that wants to scan it. That's going to take you to the ubuntu.com page, which shows all the different Qualcomm products. It's a single IoT image that you install between the Ventuno Q, the IQ8, the IQ9. And there's more Qualcomm SoCs are being added in the future. So this collaboration is growing. This is a picture of where that QR code takes you. I've got the IQ9 selected. The IQ8275 that you see right here, this is what the Ventuno Q is based off of. One system image runs on all of these boards, the IQX, the Rubik's Pi, the RB3, more are being added. It's the same image that also runs on the Ventuno Q. The only difference is we're preloading it with AppLab and like the ADB service so that you can connect to it. And we're installing a couple of Ubuntu packages like Docker so that the containers just work right out of the box. Now, let me introduce you to AppLab. So this is a unified development experience for the Ventuno Q. The key idea is that the traditional barrier between the embedded developer and Linux AI development is bringing everything into a single workflow that's easier to use. From AppLab, we got a lot of pre-built bricks which I'll get into in a little bit, that you can just download those, you pick it from a GUI, and the code's there, you can combine bricks together. This could be doing something like, let's say you're doing a video stream from your cameras, and you want to do object detection or image classification from it. These are pre-built. We have a whole team at Qualcomm that's taking all the most popular AI models, they're optimizing them to run on the Ventuno Q, and then bringing it into the App Lab experience so that it works just right outside of the box. And there's a lot of sample code that you can run as well, if you want to blink an LED or something. And then you can use that as your starting base. You don't have to focus on the complex hardware setup that most embedded developers have to do. App Lab is the orchestration layer across these domains so that a single application can run across the CPU, the GPU, the NPU, and then through the remote procedure call to the MCU. Now, one of the cool things with both the UnoQ and the Ventuno Q is they can operate in two different modes. We call it standalone mode, or we refer to it as SBC mode, which is standalone board computer, or it can run in PC connected mode. In the standalone mode, you can connect to the DSi display, you can connect a keyboard, a mouse, and you can use it as a standalone computer. Once you flash the OS to it, it can run on its own. Or, for people that are more familiar with the existing Arduino experience, you can use it in PC connected mode. And in this case, you just connect a single USB Type-C computer to it. App Lab runs on your laptop, and it will push the containers to the system and run it for you. You don't have to connect a monitor. You don't have to connect a keyboard or mouse. It just works out of the box. Even when I set it up, I literally plugged the cable into it. I flashed the OS, and App Lab just recognized it right away. I clicked on it. It showed me all these different bricks and containers and AI workloads that I could run. Very seamless experience. We're trying to make it very easy for the developer. So you don't have to focus on the hardware or any complex OS setup. It just want it to work out of the box. Now, it's going to come with curated examples. This is a screenshot of some of the different bricks and stuff that you can pick and choose from. Bricks are kind of like containers, and you can combine different bricks together. And this is what we're doing to make the experience easier. Python code is what you can write for those that are familiar with Python on Linux. So it's doing something on the AI side. Let's just say you're doing object detection, detects a cat, and now I want to run some Python code on the MCU to do something. One thing that I personally want to develop this summer, if I have some time, is I'm from Oregon, and in my backyard, I don't know how they get there, but we have possums that show up in our yard. And for those that don't know what a possum is, it kind of looks like a really fat cat. They're very poofy, big poofy tails. They're mostly harmless, but they like to dig through my trash, and they like to knock it over. Even worse, my wife likes to do gardening back there, and she's got this, I don't know what you call it, it's like a liquid fish fertilizer, and they chew the top of it off, and they try to drink it. It can't be healthy for them. And then we let our dogs back out there, they smell the fertilizer, and then they try to drink it. So it just becomes a problem during the summer. I have no idea how they get there. My house it's 16 feet in the air, and it's fenced off. That's about 5 meters, but somehow they get up there every summer. So my idea was I could use the Ventuno Q, put a camera on it through the ISP. You take one of the bricks that can do real-time object detection and classification, detect, is it a possum, is it a dog, hook it up to a water gun with a servo motor, with a bucket of water, and then have the camera move it around and point. And then once that it sees a possum, just give it a gentle squirt to shoo shit out of the way. But I don't want to squirt my dogs because I don't want the dogs to be scared of going out back there. Except in the case that the dog gets to the fertilizer, then I want to give them a little squirt to say, get away, get away. Now, that's just my idea. If somebody wants to take it, I'm okay with that. If you do commercialize it, please give me one. I could really use something like this. So, but that's just some of the mini examples that you can do. You grab those bricks, you change the code. I say, Python, is it a possum? Yes. Pull the servo motor, squirt them. And then maybe control it so that it's center frame on the camera. I could see someone building this into a water gun with a nice camera, and they've got these really cool water guns I've been wanting to get that automatically shoot. Seems like I could use one of those. So now I'm going to turn it over to Jim. He's going to talk to you about the prototype to production and actually deploying AI at the edge.
Thanks, Eric. So I'm going to talk a little bit about the AI story with the Ventuno queue. I'm from Edge Impulse. We're another company that Qualcomm acquired into the kind of IoT business unit last year. And the first thing I want you to all think about is, what does the real world really look like to a human? You know, I can see that you're all people standing in front of me. I can smell that maybe there was some coffee going on earlier. I can touch this lectern and sort of feel that it's painted. All of these things are senses that we have as humans, but we're not getting the raw data into our brain. We're getting the raw data and performing an inference on that data to get an insight. We're turning that raw data from kind of just a signal into something useful. And that's really what Arduino's been all about ever since it started. It's about that bridge between the kind of software world where you can create rules and the hardware world, the real world. And basically, what the Ventuno queue is able to do is really take that a step further by using AI directly on the device to give you that extra insight based on whatever sensor data that you might be kind of using down at the edge. So some of the example sort of AI applications that we're envisioning people building with the Ventuno queue include, of course, kind of vision-guided robotics, all the rage, also offline voice assistants, local LLMs. I've been talking to a bunch of people in the crowd today about some of the work that's going on shrinking down these cloud models to fit onto edge devices, and the sorts of things that you can run on the Ventuno queue now. Think Gemma 4, think Quen. They're all now really, really easily accessible down at this level of low-cost, high-performance hardware. But then more on the industrial inspection side of things, my bread and butter has been building industrial inspection systems with customers with Edge Impulse for doing things like defect detection on production lines. And then predictive maintenance, sort of using that sensor data in a factory to go, you know, rather than Greg going down to the factory floor on a Friday, putting his hand on one of the big pieces of rotating machinery and saying, yeah, the bearing's failing, we need to do some maintenance on this machine. We can use sensors, you know, time series-based sensor AI to do that predictive maintenance automatically with these sorts of devices. And then smart environments. I think the future of kind of the smart home is going to be pulling together sensor sources from all these different places and using a central hub like the Uno queue or the Ventuno queue to run multimodal AI systems that can really take action based on what they're seeing without you necessarily needing to train something from scratch. So those are some of the example AI applications that we're envisioning for the Ventuno. But how are we helping you develop tools with generative AI, with audio intelligence, with vision AI, and with robotics? The first of them is through AppLab. So Arduino is bringing this really simple method of pulling together pre-existing bricks, pre-existing bits of application that people have built in the community, the same way that they've done for the microcontroller for years with Arduino libraries, on the Linux side with Python. But then there are two other tools that Qualcomm has that can help Arduino bring even more of this richness of AI to devices like the Uno queue and the Ventuno queue. And the first of them is Edge Impulse, who I work for. So I don't know if you're familiar with Edge Impulse, but we're a software platform and a set of engineering tools that give you a kind of end-to-end workflow for building discrete AI models for the edge. We're not talking with Edge Impulse about building LLMs or SLMs. We're talking about really small, refined AI models that solve a single problem based on sensor data. That might be detecting humans in an image. It might be detecting faulty machinery from vibration, but those sorts of discrete use cases. And to build those sorts of things, you need three things. You need a really high quality data set. So we have tools for helping you build data sets using any kind of sensor. You then need a really efficient model architecture. So we have a set of tools to help you build your model architecture and train a model that you know is going to run on that end device. And we give you tools to help you kind of benchmark as you're building your model to understand whether it will run on your edge device. And then the final thing is you need some way to deploy it. So we can compile down these models to run in really optimized C++, even on a microcontroller, or edge-optimized executables for Linux and things that will allow you to take advantage of things like neural processing units, GPUs, even CPUs, and take advantage of the instruction sets that are available on these edge devices to their best of the ability of the AI model. And where that becomes really easy is when you start to use Arduino hardware with it, because from Edge Impulse, you can one-click build and deploy to Arduino App Lab. Really, really simple. So once you've started building your models in the platform, it's really just a case of plugging in your Arduino Uno Q or Ventuno Q, clicking the button, and getting your model down onto device. Because the thing that I've found most difficult with customers over the years with Edge Impulse is that step from kind of 0 to 1. How do you get really quickly from, I've got an idea of chasing my possum around with a water gun, to really chasing the possum around with a water gun, even if it's sort of version 1 of it. So that's really the kind of pathway that we've been trying to solve. But Edge Impulse also provides that full toolkit to go all the way to production, as Eric was saying. Then the other tool that we have in our roster here is Qualcomm AI Hub. Now, this is on the other end of the spectrum. So while Edge Impulse helps you train models from scratch for these kind of discrete sensor perception use cases, AI Hub provides you with a bunch of pre-built models for all sorts of different modalities. So whether that's doing things like pose detection on humans, or local LLMs, or detecting cars in an image. These are sort of pre-built model blocks that you can take and you know will run really well on Qualcomm hardware. And the other thing that AI Hub provides is a way to run these workloads in the cloud on real hardware. So they have a server full of Qualcomm hardware that you can go and test out these workloads to see how they'll run before you get down to device. So you get both things there, a bunch of example models and applications, the pre-built models that you can go and build into your application, and then the way to test and optimize those models in the cloud. So that's a little overview of some of the ways that we're bringing AI to the edge with the Ventuno Q and Qualcomm. We've got a few minutes for questions now, so I'll bring Eric back up. But if you scan this QR code, you can get access to a bunch more information about the Ventuno Q, and you can register for interest. We'll be launching later this summer, and I'm really excited to see what everyone in the open source community builds. Thanks very much.
Eric and Jim, we've got time for one quick question. One of our watchers noticed a preference for Zephyr in the Ventuno Q MCU. Now they're wondering, does this telegraph anything in terms of how you folks are thinking about the classic Arduino RTOS support?
So Arduino has now moved most of their RTOS support over to Zephyr. So that's definitely a move that Arduino is making. They're really behind Zephyr.
Okay, thank you. Thank you so much. Another round of applause, please.
Thanks very much.
Thank you. We'll have a demo of this in the room over here during the conference.
All right. Up next, we're going to examine what comes about when a programming language chooses to stay small. Everyone, put your hands together for Giacomo from Gleam.
Cool. Okay. Always exciting to bring your own device to these things. Well, hello everyone. As you've heard, my name is Giacomo. I'm an Italian developer, and I'm one of the people who's helping build the Gleam programming language. I'm helping with the compiler, tooling, and, well, bug fixing. There's always plenty of that, no matter the project. And if you've never heard of Gleam, well, this is your lucky day, because you might have guessed it. I will be talking about Gleam, a friendly, functional programming language for building type-safe systems that scale. there's quite a few things to unpack in here, and we're going to touch upon those ideas. But, well, rather than teaching you all there is about the language or giving you a course on Gleam, I would like to talk about something a bit more specific, something that I think Gleam does particularly well, and that is being small, and how being small can actually be quite the feature in itself for Gleam, because it does not just shape the language itself, but also the ecosystem, the libraries and frameworks that are written in Gleam, the developer experience, the tooling around the language, but also, well, the development of the language itself, how people like me or Louis, the creator of the language who's sitting around here, go about our day making Gleam. What we have to take into account, what we have to think about whenever someone comes up to us and they have some new exciting feature they might want to get into Gleam. Because nowadays, well, we're kind of used to programming languages being this sort of ever-growing thing, where new features are constantly added. There's new, better, hopefully better, exciting ways of doing stuff. And then naturally it makes its way into our programming languages. And well, on the one hand, that can feel quite empowering and it is exciting. But on the other one, it is a bit of a double-edged sword, because as the language grows and the surface of the language grows, well, we're getting more features, more ways of doing things, but it's also harder and harder to wrap our head around the language, to get a good grasp of all that is going on with the language, to even know all the different levers that we can pull to get from point A to point B where we want to go. And so Gleam tries to do something different. It wants to stay focused, practical, and really small. So much so that the entirety of the language can actually neatly fit on a little postcard. And these are all the keywords in Gleam. And by the way, I've actually printed plenty of those postcards, totally underestimating how many 500 of them are. It's a stash this big. I will be handing them out later at the unconference if you want one. And you can really send them in the mail. But actually, I'm also kind of lying here, because out of all those keywords, only 2/3 of them are actually in use today. All the other ones do absolutely nothing except produce an error message. So, why might that be? Well, when Gleam went V1 and we deemed it production ready 2 years ago now, we decided we would reserve some additional keywords, just in case. Maybe 10 years from now, I don't know, we do realize we actually wanted that feature, macros in the language or something. Well, this gives us the wiggle room to actually add it without introducing a huge breaking change to the whole ecosystem. And that's because we want people to be relying on Gleam. We don't want to introduce a new breaking change every time something new comes up. But well, looking at languages keywords is fun and all, and I would say it makes for a pretty good looking postcard, but it's not the same as reading something written in Gleam. So let's have a look at some Gleam, shall we? And this might be the very first few lines of Gleam code you see, and hopefully it might have a sort of familiar look to it. Heck, you might even have an idea of what is going on here. We are defining a greet function that takes in a name, an argument, that's a string, and prints a message to standard output. And then we are reusing this greet function to print a greeting for each item in a list. Hello, Lucy, and hello, London. And well, if Gleam looks familiar, that's actually by design. That's an intentional design decision. Gleam used to have a different syntax, actually, back in the days. And then we realized people had a much better time learning it when it looked more like other, more mainstream programming languages. That's because, well, Gleam is a functional programming language. And if you come from a different background, maybe doing object-oriented or anything else, it might take a bit of getting used to. There's no way around it. You get to learn new ways of doing things. And, well, if the language looks really unfamiliar and alien, now you have to juggle a lot of things in your head, and learning becomes twice as hard. And this actually brings us to our first point. Gleam is a small language. But it is not small just for the sake of it, just because one day we woke up and thought, well, let's try and make a language that is as small as possible. No. Well, being small can actually be quite the feature in itself. And I think we rarely value it highly enough. Because being small can make, for example, for a language that is fun to learn. A language that has a great focus on having a small, well-defined core with a basic set of features, that can feel quite powerful, but at the same time, it does not grow over time into a huge mess. And well, this might remind you of other way more popular languages, like Go, for example, which is known and loved for being a language that is easy. It does not have heaps of features, but at the same time, people have been writing amazing pieces of software with it and can feel quite productive using it. Or even this idea, I think I first read it in the Zen of Python, of not having two ways of doing things. I have no idea if it applies anymore. I haven't written any Python in a short while. But I think this applies just as nicely to Gleam. For example, Gleam does not have if statements. Yet Gleam is a Turing-complete language. It wouldn't be all that useful otherwise. And that's because we can do control flow using a different feature. That is with case expressions and pattern matching. So here we're saying in case user is admin is true, well, we do something. In case it is false, we serve a not found page or whatever our application might need to be doing. And well, if you've never heard of case before or pattern matching, you can think of it as a sort of switch statement, a bit more powerful. We're not going to dive into the weeds of how all this works. But, well, coming from languages like JavaScript, Java, or C, it might feel right at home thinking of it as a switch statement. And if you look at it, well, if expressions are not needed at all, this is already plenty enough to deal with Booleans, so we just got rid of another different way of doing the same thing. And while that might feel silly or limiting at first, I think it can be quite nice, because then you don't have to think, well, should I use an if statement here, or a case expression? Which one would look better? Maybe we should decide with our team on some practices, on some guidelines to follow, so that we know that here we should use if statements, and here we use switch statements and whatnot. But, well, sometimes having too many choices is even worse than having no choice at all, and we just got rid of this different way of doing the same thing. I think this also has the nice side benefit of not making Booleans all that special in your language, since now they no longer have this special construct just for them. And we did realize, well, Boolean blindness is actually a problem, because reasoning about those pesky Booleans, as soon as there's more than a couple of them, well, it becomes really hard with this explosion of possibilities. And so here maybe we do realize, well, the world is a bit more complex than just having admins and not. Our users maybe are better described using roles. A user could be an admin, a moderator, or a regular user. And then refactoring is also a bit nicer, since we don't have to switch between the different ways of working with Booleans as opposed to working with other custom types, like here. Now, I'm talking about a functional programming language, and Gleam is functional, allows us to define custom types, for example, and make sure that we don't mix things up. That, for example, we're not passing a Boolean where a custom type is expected, or an integer where a string is expected, and so on and so forth. And talking about a functional programming language with static types, strong compile time guarantees, well, that might conjure up ideas of a language that is really hard to understand. A language that is really hard to master and to grok and to get a good grasp of what is going on with it. Maybe some kind of ivory tower thing born from academia to explore programming concepts, but not really meant for the layman to write the code in anger. Well, Gleam couldn't be any further from that, because this idea of simplicity doesn't just apply to some parts of the language, having a few set of keywords and features, for example, but to the entirety of it, to its type system as well. And so we like to say that Gleam is a state-of-the-art type system, but from the 70s. So, so it relies on some very well battle-tested ideas that have proved to work over time, to make our code easier to reason about, to write, to refactor especially. So in Gleam, we can define custom types. A user here could be either logged in or anonymous. And well, if you squint hard enough, that is basically an enum. And you would be right, it's basically the same thing coming from C or JavaScript or Java. But we can also go a step further and say, well, a logged in user also has some additional pieces of information, like a name, that's a string, or an email, another string. Or maybe we could say, well, the email is actually an email type to represent a validated email, not just any possibly random sequence of characters. And really, if you look at this slide, there's basically, I would say, 80% of the entirety of Gleam's type system here. It doesn't get much more complex than this. There's genetics, and that's it. That's the whole story. So it is really a simple language, a tiny language, even when it comes to the type system. You won't be able to run dooms with your types, like with TypeScript, for example. I think that's actually a good thing sometimes, being limited and small. But again, being small, while it can make for a language that is really fun to learn, can also have some other really nice properties. Because being small also means that a language can be delightful to use. Now, when the language actually gets out of the way, we can focus on the problem at hand rather than all the machinery involved in the language, all of the different features, how they interact with each other, how we should use one or the other, and when we should do it and when it looks better, maybe coming up with practices and so on. And then we don't have to think of all those levers we need to be pulling, even left wondering, why do we even have that lever? Gleam really does optimize for readability here, not terseness. And that is a trade-off. Well, of course it is. We're developers. We know that everything is a trade-off, sadly. But what you get is, well, Gleam takes a bit more typing. It is not a super concise language. You will not be able to squeeze as much as possible out of a single incredibly terse line of code, but in return, you get code that is easier to follow. There's no implicit control flow. There's no implicit conversions. You have to be explicit about what you're dealing with. And you get errors if you're not. The compiler is not trying to be helpful and actually backfiring, trying to do the implicit conversion for you. There's no exceptions and no nulls as well. And so you have to be really explicit. Again, you will be typing a bit more. But if you think about the fact that, well, we developers, we actually do tend to read code way more than we are actually writing it. We have to maintain code written by others. We have to fix bugs written in code written by others or by ourselves from the past, our worst enemy. And well, if I'm thinking about myself a week from now, maybe a month from now, or a year from now, God forbid, well, I wish for them to have a good time reading the code that I wrote. And so I think it is a nice trade-off to try here, to try and optimize actually for readability rather than terseness. And being small is what enables us, developers writing the Gleam language, to actually focus on other things that we think are quite important. Because a language that is easy for humans to understand is also a language that is easy for tools to analyze. And so that allows us to focus on experience and tooling. For example, well, thanks to Gleam's pretty straightforward type system, the compiler can give us really nice error messages here. Here we're trying to access a .alias field from a user, and well, it's telling us we are trying to access something that is a user, but it only has these fields, .name. Maybe we meant to do that. And I think it is really nice that the compiler can actually go the extra mile here and try and be helpful and suggest what we might have wanted to do. And that's because the code being this simple and straightforward and easy to analyze, well, we can actually do quite a fair amount of static analysis and understand what is going on with the code and, well, what the context is and what you might have wanted to do. Maybe here I was through a big renaming or a big refactor and I forgot to update one of the fields and it was stuck in an old name. And, well, that allows me to just go back to all these little hints, fix them, and go on with my day. But also, well, here we are really resting on the shoulders of giants like Rust and Elm, which are really two amazing languages at showing us what great error messages should look like. Rust might be a language with a steep learning curve, but I think everyone can agree who has tried Rust that the error messages that it produces are actually quite nice. And they actually can make the developer have a much better time at learning the language, at grokking what is going on. And well, the same goes for Gleam. And yet this is not enough. A language might be small and easy to learn, small and fun to use, easy for tools to analyze and have great error messages. But nowadays, well, we can't just give a developer a compiler and tell them, go figure it out. Go figure out package management, how you should scaffold your projects, and so on and so forth. Because we're kind of used to all those pieces of tooling, which, well, are not really part of the language. To much of my despair, because I really love writing programming languages, what actually really matters is all the things that are actually around the language. And the language itself is only a very tiny piece of the picture, because a language is only as nice to use as all the tooling around it, and how this tooling allows us to use the language. For example, to package our code and deal with dependencies, build documentation, build our code and run it and test it, and also format our code. We don't want to be fighting with our coworkers under pull requests because a comma should go here, not on a new line, or a parenthesis should go here and not on a new line, and so on and so forth. And so Gleam learns this lesson, and Gleam being small allows us, the developer working on Gleam, to focus on all of these pieces of tooling around the language that are just as important, if not more important, than the language itself. They are usually what makes or breaks a language for developers. Because if a language is really nice, but you want to pluck your hairs out when you're trying to then deal with dependencies, then you need to figure out which dependency manager you need to use, which package manager, which configuration file you should be using. Well, that is not a pleasant developer experience at all. And so Gleam comes with those tools built into the toolchain. Once you've installed Gleam, well, you're pretty much good to go. So, for example, if we need to create a new project, well, that's Gleam new, and that's it. The build tool built into the toolchain scaffolds your project, and then, well, we can follow the hint, go to the directory and try and test our code. And that's with Gleam test, compiled, and then the tests are run. And that's it. We need to run our code. Well, you know the drill. That's Gleam run. And there's actually so much more to it that the CLI can do. It actually wouldn't fit on a single slide unless I made the font really small, so there's just a part of it, which I think is good. But, for example, it can deal with dependencies. Package management is built into the box. It can build your project, of course, but also your documentation when you need to browse it locally. It can deal with tests, with your development setup, and so on and so forth. And well, if you want to check it out, we're going to have plenty of time at the unconference later, or you can try Gleam out and see what the command line can do for you. And really, so far, we've talked about languages being small for being easy to learn, fun to use, and also easy to analyze, and to have great tooling. And well, that is important, and all of those, I would say, are pretty technical concerns. So, well, we developers love those. I do love those. Trying to fix every single bug, trying to come up with the best error messages possible, or the best developer tooling and error messages. But, well, technical concerns are not all that important. And I would say that being small is actually quite the feature for Gleam, for something that is not really all that technical. Because being small is what enables Gleam to be truly a community project, is what allows Gleam to achieve its goals without having any big corporate owner. What do I mean by that? Well, Google is not a corporate-owned language. It's not a Google or Microsoft language. It is not backed by VC capital and huge flows of money. But it truly is an open source project in the truest sense of the term. It was born from the idea of a British guy who thought, well, what if this bit I love from Rust and this bit I love from Go and this thing I love from Elixir were merged into a single language that I enjoy using in my day-to-day work. And well, it is really important for us to be able to achieve these goals while at the same time maintaining these Linux ideals of being open, built in the open, being an open source project with a community around it, building a community as well. And well, Gleam is supported by a lovely community of people. Last time I counted them, there were more than 300 people, I think, who supported Gleam with pull requests, fixing bugs, opening issues, sharing ideas as well, sharing blog posts, their experience using Gleam, their gripes with Gleam. I love those because those are so important for us to understand what we can do better. And also people are, well, donating to the project as well. That's how Gleam can go by. All the lovely people who have sponsored Gleam so far can can be seen here. I think it's more than 300 of them at this point. And that is the community that we cherish and we are trying to build that is also helping the project grow. Because if you look at it, well, the team working on Gleam is actually quite small. It's 3 people. That's me, Giacomo, Louis Pilford, the creator of the language, and Surya Rose, another amazingly talented developer. And while I'm really lucky to be working with these amazing developers and engineers, but there's only so much so that 3 people can do. And whenever we think about what we need to be adding to Gleam, what we need to do for Gleam, well, that comes with a lot of questions. Well, usually the way it goes is I go to Louis and I'm like, well, we should add this to the language, or we should do this and have that, and so on and so forth. And then Louis is really good at talking me out of it, which I think is actually really, really good, because we need to think about a lot of things whenever we're working on Gleam. And being small, not just in scope, but also as far as our resources are concerned, can actually be a feature in itself quite counterintuitively, because that brings us a sort of clarity and focus that we wouldn't have otherwise if we had heaps of money to throw at every problem we find. Like, what is the thing that is going to have the most impact for us? Or, well, what is that really matters to us? Do we really need this feature? And actually, can we afford to maintain this over the long run? Because, well, as nice as the new feature is, once you hit merge, well, that becomes yours to maintain for a long time to come. And if we want people to rely on Gleam, well, we can't just merge absolutely everything and then, well, try and remove it later and introduce breaking changes if we do realize that the feature was not actually all that good or not that needed. And all those questions, well, if you didn't listen to a word I said and you had a look at this slide, they can just very well apply to any software project, really, or any human endeavor at all. Find your battles. Find the thing that matters the most to you, and then try and do a good job at it with the resources that you have. And even being limited can be a feature in itself. For us, those battles look like a language that is fun to learn, but also delightful to use. A language that has the best developer tooling experience that it can give you. Thanks to being small, that is what we have been able to achieve, despite being a very small team, while at the same time building a community of lovely people. Well, I joined Gleam because I thought it looked cool, but really what made me stay was the people around it, and how cheerful everyone was, and how the language really has this buzz around it that is really hard to get any other way. So this is Gleam and the value of small. If you want to try Gleam out, you can do so at gleam.run. You can find me at giacomocavalieri.me, that's my website and my Blue Sky handle. And well, I thank you so much for listening to me today, and I hope you have a lovely rest of a conference.
Thank you, Giacomo. We're on time, but I have a very quick question that I'd love to get your take on. How do you see the language and the community around it in 10 years?
Oh, gosh. That is a really hard question because I don't have a crystal ball. Well, my hope, I can say, is that the community keeps growing like it has been growing for the past couple of years, ever since Gleam was made V1. Language-wise, I don't say Gleam is going to change all that much. Because again, we're really focused on having a small language. Of all those unused keywords I had before, well, I don't think any one of them is going to be used anytime soon, maybe with the exception of test, but I wouldn't hold my breath either. So I don't think the language is going to change all that much. What is going to grow is going to be the ecosystem around the language, the tooling and the libraries and the frameworks that people write in Gleam. And that is the most exciting part for me.
Fantastic. Thank you. Once more, for Giacomo. All right, everyone. Without further ado, lightning talks.
We're going to have a bit of a do while we prepare.
Am I live? Yes, I am. Okay. I think we're ready to go. Good. Well, hello, friends. My name is Diogo. I work in security engineering at Canonical, and I'm here again at the Ubuntu Summit to talk about one of my favorite topics, Latin. Just kidding. Latin was so last summit. Today, I'd like to talk about something that I see in the cybersecurity community, which is how to balance the scales of the things that we are doing, both sides. So, as I said, I work in security engineering, and when I'm talking about candidates, I tend to describe my work as clashing with the never-ending ocean of vulnerabilities. For somebody working in security, discovering an original vulnerability is a big feather on their cap. They get a bunch of snazzy names: regression, leaky vessel, terrapin. We see discovering a vulnerability as an accolade, and rightfully so. Whole events have been built around it like Pwn to Own. But what about the other side of the equation? So right now, can any of you name the person who developed and tested a fix for those 3 vulnerabilities? There's a bit of a perception imbalance in our industry between those that find the monsters and those that slay them. A discoverer is insightful, cunning, resourceful. A fixer is doing what they're supposed to do, their job, sometimes under very significant pressure. So allow me to paint a vivid picture. This came from a report from Anthropic that is very recent. Can you see the gap? I'll highlight it. There. The difference. Some of these numbers are not like the others in orders of magnitude, and AI made that gap much, much wider. So allow me to oversimplify the issue. On the attacker side, this is more or less how it looks. A researcher. You conduct research, you create a POC. In that box, something happens, perhaps some emails and back and forth, and then you get a CV and an advisory. On the defender side, sometimes it looks like this. Sometimes it looks like the tube map from London. It's stuff happening all over the place. The bar is different, the bar is higher here, so what can we do to further acknowledge and value the fixers? This is something that speaks to the sustainability of open source. How do we keep people interested in navigating this difficult kind of work? What I'll suggest is a bit like sugary cereal. Part of a healthy breakfast, but not the whole thing. We still need a bunch more parts. So let's start with a very simple one, acknowledgement. As humans, we like to feel seen and have our efforts recognized. Some companies maintain a Hall of Fame, but it's a bit harder when the presence is a GitHub repository. So making use of the credit section when we publish a CVE is a simple, durable way of acknowledging someone's work. Same with crediting them explicitly on the advisory. This is simple enough and can even be done retroactively. Do ask me about the canonical CNA. Next, dual boons. FFmpeg hit the nail on the head. Create incentives to contribute. It's open source. The code is right there. Maybe if you're operating in a sort of a bounty, say, oh, there's a small fee if you submit a patch. If you submit a patch with your research and we accept it outright, great. Recognize that fixing it is as important as finding it. Yes, the patches still need to be validated. Maybe somebody can send in a bad patch, but it can help shorten the loop if you have something to start from. And last, there's throwing the veritable coin through something like thanks.dev, where you can contribute to open source projects and their maintenance. Maintainers are in short supply, and this can be an important motivational boost. Look, there's us. And we do contribute through thanks.dev to a lot of the dependencies that we have at Canonical. So this is an excerpt from a blog that was published just this Tuesday by Daniel, who leads curl. Aside from the Linux kernel, this is arguably one of the most visible and well-structured open source projects in the world. And they are also feeling the pressure. And imagine if a project that is as well known as theirs feels it. Imagine how it feels if you are a small maintainer of a small project that ends up being important. I won't use the XKCD comic here because it's done to death, but you get the gist of it. So what I want to say with this is be kind to your maintainers, all of them, not just the well-known ones, those that undertake the tasks, as Daniel says that, we act solely in the interest of making curl as good as possible for the world and curl users, which, again, as this is a Witcher theme talk, does align with this. The world is full of evil, so it's sufficient to stride ahead and destroy the evil encountered on the way, and that way rendering a service to good. The rest takes care of itself, And we think of our maintainers that selflessly maintain open source, this is what they're doing, contributing to a better world of open source software. And that is all I had for you. I hope that together we can do more to acknowledge the people that put in the work and do the fixes so that we can sustain our very own open source software valley of plenty. Thank you, friends. Enjoy the rest of the summit.
What a fantastic talk. I have to try and do something alongside that. But let me talk briefly about snapping things. We heard earlier from Mark how wonderful snaps are, and I'm going to show you, well, what little we've done to bring something new and exciting into your world of snaps. But what is this new and exciting thing? Well, it's Collabora Online, but not as you knew it. Now as a desktop application, no longer tied to your browser, but actually brought to your desktop. It's spreadsheets full of user experience metrics that show you what people do and then what they do next and what they undo. And shouldn't it be colorful and nice? It's a whole lot of slides that are actually on your laptop that actually project when you want them to with videos that play and sections so you can shuffle them and sort them. It's attention to pixels and to people. It's UX design, beauty, and what people are doing. It's close-up views of nice easiness and fun for using. And it's moving then from the browser into the desktop. And why? Well, that brings lots of possibilities. Some of them we can use, some of them we can't. Things like projector detection, something your browser really can't do for you very well. Direct clipboard access, so you can actually use the whole power of the X11 clipboard. Well, anyway, you'll be amazed. You'll be amazed. The web has only just about caught up with, just the very basic level of what should be in a clipboard API in the last year or two. So there you go. Printer access, all these things that are really rather useful in an Office suite. And it helps sort of consolidate our product mix as well too, dragging many things together and relegating to a classic product, the old thing. So how do we snap all of that? Bring it closer to our Ubuntu users. Well, so the first thing is that, of course, we have these nice names, and we want to bring it all in there and get this sort of web app running inside our package. So, and then, of course, there's all sorts of fun sandboxing. So we have these wonderful portals that allow us to do crazy stuff like finding out who the user is, so that when you're doing your change tracking, it shows up as you and not anonymous coward or something, which is good, and your comments can be correctly credited. So lots of nice pieces there on the sandbox boundary. One of the fun things that we discovered, so Collabora Online has this wonderful isolation containment system. So every document lives in its own container. It's ultra secure and really funky. To do that, we fork so that we do copy on write and we share a whole load of stuff. And we really use a whole load of the cool things that Linux can do with containers. To save CPU, to save RAM, and all that sort of stuff. And we do much less of those in the desktop case, primarily because the Mac sandboxing environment doesn't let you fork, which is really lame, isn't it? That's just awful, isn't it? Anyway, or you can ask for special permission from Apple HQ if you want. But anyway, so we put that all into a single process, and we use a Qt web engine. So we try and use the platform web engine so that we avoid the security maintenance problems that come from something like Electron, a new security vulnerability every day to keep you happy. So there's a whole load of code there, 8 million lines. It used to be trendy to have lots of lines of code. In the agentic world, of course, anyone can have 8 million lines of code, but who knows what they do? Ours were written by humans, and are pretty awesome with it. So we have to upgrade our node during compile time in the snap, which is quite exciting. But yeah, there's lots of good fun there, and we can find this all beautifully. So what can we do? I had a couple of problems there, which are interesting. So the first thing is that Chromium has another sandbox inside itself. You notice this nesting thing. Everyone raves about virtualization, and then they confess later that they can't actually nest. And the same is true of container systems. The number of container systems I have to run in that can't actually have a container system inside them is depressing. Anyway, so here we have to turn off the sandboxing in the browser, actually. So never mind. We have one sandbox anyway. Wouldn't it be nice to have 2 or 3? But anyway, maybe later we'll get that fixed. Just getting our dbus slot sorted out, and then bingo, it works. Except we need to upload it to Snapcraft, and unfortunately we've just made a very complicated repository that's super old, and it needs a web link to the Snapcraft file. Git web, we're just getting hammered by AI spammers, so getting a link is just really not easy. So we need to host it on GitHub, except you can't because there's 25 years of history in there, and someone didn't set their username 25 years ago. And we don't want to redo all the commits. Anyway, eventually we got all of this fixed and submitted, and it's beautiful. Look at that. Now, of course, this is the latest Edge thing. It's not perfect. Let me say again, the software is not perfect yet, but play with it. And we just love the channels thing. That is just unbelievably useful. So thank you so much for delivering a great technology.
Hello, I'm Martin Wimpress, and I'm going to introduce Jive Talking, a software audio producer that turns raw microphone recordings into broadcast quality audio in one command with no configuration. I co-host Linux Matters with my friends Alan and Mark. We recently went independent, and that means we've got no more post-production services. We are three blokes with three different microphones in three different home offices, capturing three different recordings of variable audio quality. We needed a solution. We are not audio engineers, so it must be automated. How hard could it be to build an automated sound engineer in software? Well, the pre-DSP era studios produced excellent quality audio for decades using hardware that is well understood and by modern standards relatively simple. So 4 pieces of legendary audio hardware informed our design. The Drawmer DS201 is a noise gate that cleans up the gaps between phrases. The Teletronics LA2A is an optical compressor and with warm leveling. And the CBS Volumax is a broadcast limiter from the AM radio era. Dolby SR is an analog noise reduction system. Vintage hardware had knobs that humans turned by ear. Adaptive software needs numbers. So Jive Talking measures first. It measures the recording, capturing loudness, metrics, true peak, and 13 spectral shape metrics. It hunts for the cleanest room tone profile and scores each of the speech regions to derive a speech profile for each presenter. Our goal is consistency. Every presenter track must hit the same target level so we sound like we're in the same room. It turns out FFmpeg has all the audio features needed to faithfully reproduce these legendary audio circuits. So I built FFmpeg Statigo, auto-generated Go bindings for the FFmpeg C libraries with 85% API coverage, statically linked so the whole of FFmpeg is inside the Jive Talking binary, no version drift and complete programmatic control. I'm most pleased with the noise reduction. The first stage is non-local means denoising, a technique now common in medical imaging for cleaning up MRI scans. It treats the audio spectrogram as a 2D signal, finds the patterns across it, and treats everything else as noise. The second stage is a Dolby SR-inspired compander that squeezes the residual denoiser, that squeezes the hiss that the denoiser may have missed. Here's a before and after. So this is a clip of Mark's audio. It's very noisy. X-axis is time, Y is audio frequency, digital silence is black, spoken word is in the reds. The blues and purples are room noise and hiss. The blue horizontal lines are